Hello there, myself Rahul, and welcome to this Terraform series. This series is gonna be a little longer series because I have divided this whole series into multiple chapters. And you will see each chapter name onto the screen. So take a pause over here and go through the topics so that you know like what you will be getting out of this particular series. And also for your help, I have put down the timestamp of each chapter into the description section. So if you are already familiar with some of the topics, then feel free to skip those particular chapter. But if you are a beginner and you want to learn Terraform, then I would highly recommend to start from chapter 1 and go all the way till all end of the chapter so that you know the Terraform and how it works and how you can just use those concepts into your actual day-to-day work. So without further ado, let's start with our chapter number 1.
And these are the topics which I have planned for today's session, starting from what is Terraform, then what are Terraform commands, that is Terraform init, Terraform plan, Terraform apply. And the third, we are going to create our first Terraform file. And the fourth one is how we are going to install Terraform on our system. After that, we have a couple of demo. The first demo is setting up virtual machine on actual Google Cloud platform using Terraform. And the second demo is setting up an EC2 instance on AWS and the same using Terraform. This is going to be a long session, so if you want to skip some of the topics, then that is also fine. I'll put the timestamp of each topic into the description section, so just click on those timestamp to follow those individual sessions. And if you are a beginner and you want to learn Terraform, then I would recommend to follow this complete session, because this is going to be a very basic session where we will be starting everything from the scratch. What is Terraform? Terraform is used to provision and set up your infrastructure on a cloud platform. The next question comes, what is provisioning and setting up of your infrastructure? Suppose you have a Google Cloud Platform account or AWS account, and that's the only thing you have. So you need to set up your servers or the virtual machine so that you can deploy your application. So Terraform will help you to create those infrastructure using Terraform file. So you don't have to manually go into Google Cloud or AWS console and manually create those virtual machines and install your software packages. Once you know Terraform, then you are going to create a multiple Terraform file, which will help you to set up your complete infrastructure from the zero. Then what is Terraform file? This is the example of a very simple Terraform file where you will have two components. One is provider and second one is resource. And always remember, the Terraform file always have an extension of .tf. So if you look carefully over here inside the file, we have specified provider as Google. So if you specify provider as Google, then you are definitely going to interact with a Google Cloud platform. And in case if you are going to mention here AWS, then you are going to interact with the AWS cloud services. The second component which I have mentioned over here is the resource. So resource varies from Google Cloud platform to AWS, because if you are provisioning a virtual machine on a Google Cloud platform, then we are going to call that resource as a Google Compute instance, as you can see in this Terraform file. This Terraform file is a sample Terraform file for a Google Cloud platform. But in case if you are working on a AWS, so instead of a Google Compute instance, you are going to mention EC2 instance. This is just a little idea how to create your Terraform file and how you are going to interact with a cloud service provider. But the Terraform file is not self-sufficient enough to interact with a cloud service provider. You need to know some Terraform commands. Then what are those commands are? The first command is Terraform init, which is going to prepare your local environment for setting up your cloud infrastructure. Second, Terraform plan. It is going to tell you like how many resources you are going to add, update, or delete. The third command is Terraform apply. This command is actually going to run your virtual instances on a Google Cloud platform or AWS. And the final command is Terraform destroy. So this command is something which is going to destroy or delete all the instances or the resources which you have created using previous Terraform apply command. Don't worry, we are going to cover all these commands in more detail into the next slides. Starting with our first command, that is Terraform init. Suppose you have a directory Terraform demo on your local system or a desktop, and inside that directory you have a file that is main.terraform. And this is the code snippet where we have specified the provider and the resource. Don't worry, we are going to look the complete actual Terraform file into the later session. But this is just an example where we have specified the provider, that is Google, and the resource, that is Google Compute instance. Now, after that, once you run the first command, that is Terraform init command, then it is going to contact the cloud service provider, and it is going to download all the required dependency onto your local system. So what does it mean? So once you run this command, then you will see the same directory, you will get a directory called .terraform. So in that directory, it is going to download the required packages which is needed for interacting with your cloud service provider. Since this example is for Google Cloud Platform, so it has downloaded Terraform provider Google version 3.61. So here you can see this is the .terraform file which is just got created once you issue the terraform init command. So if you summarize what is Terraform init command is, then it is just preparing your local environment by downloading all the required dependencies based on the provider which you specify. Since we have specified the provider as a Google, so it has downloaded all the required dependencies for Google Cloud Platform. And in case if I have specified over here AWS, then it is going to download all the required dependencies which is needed for communicating with the AWS environment. So this is how the Terraform init works. All right, the next command which we are going to look is Terraform plan. So again, we are going to take the same example. We have created a Terraform directory, and this is our main.terraform file where we have specified the provider as Google and the resource as a Google Compute instance. And after that, we are going to run the Terraform plan command. Once you run the Terraform plan command, then you will see following message at the end of your terminal. And this message is going to tell how many resources you have added, how many resources you have changed or updated, and how many resources you have destroyed. This command is still not responsible for creating any resource on a Google Cloud Platform or AWS platform. It is just going to inform you like what is going to happen or what is going to change or what is going to destroy. So here our main .terraform, if you look it again, then we are trying to add a resource that is Google Compute instance. That's why we have got a message one to add. That means we are going to add one new resource to the Google Cloud Platform. To summarize the good Terraform plan command, then it is just going to inform you what is going to add, what is going to update, and what is going to destroy on a Google Cloud Platform or AWS platform. It is not going to update or change anything on actual cloud platform. It is just going to inform you. That's why the name is plan. Moving to the next command is Terraform apply, and I'm just going to tell you this is where everything will happen or the actual thing will happen. So again, I'm taking the same example. I have created a directory Terraform demo. Inside the Terraform demo, I have a main.terraform file. And again, there is a provider, there is a resource for Google Cloud Platform, and I'm going to run the command Terraform apply. And once you run the command, if you are running this command for a Google, since this example we have taken it for Google Cloud Platform, then it is going to start an instance that is a virtual machine on a Google Cloud Platform. And suppose if you have taken the same example or we have updated the same main.terraform file for AWS, then we are going to get an EC2 instance on AWS platform. Don't worry, we have a separate complete lab session for AWS and Google Cloud Platform where we are going to create the complete Terraform file and we are going to spin those virtual machine and EC2 instances on those cloud platform. Now you have got an idea like how the Terraform command works and what are the sequence of running those Terraform command. Now in this slide, we are gonna see our complete Terraform file. This is an actual code of our main.terraform file. This code sample or this complete main.terraform file, I have taken it for Google Cloud Platform, but this file structure or the components which I'm going to explain is going to be pretty much same for AWS instance also. Okay, let's start with the first component. So the first component is provider. Since we are talking about Google Cloud Platforms, that's why I have mentioned the provider name over here is Google. Second, if you are going to interact with a Google Cloud Platform or AWS, then you need to have some kind of authentication. So you need to create this JSON key, that is your authentication key on a Google Cloud Platform first, and then you need to download that JSON key onto your local system, and you need to pass that that JSON key to this Terraform file. The third component which we are talking about here is the project ID. So if you go to Google Cloud Platform, then you need to select project over here. So here I have already created a project called GCP Terraform, and this is the project ID for it. So we need to copy this project ID and paste it over here inside our main.terraform file so that this Terraform knows like in which project we are going to create those resources. Moving further, the fourth component we are talking about here is the region and the zone. This settings is pretty much dependent on in which part of the world you are. So I'm currently in the Europe zone, so that's why I have selected the Europe West region. But if you are in some other part of the world, then select the nearest zone to you. Now we are done with our provider section. The next section we are talking about Google Compute Instance. So the Google Compute Instance is a resource. That means we are going to provision a virtual machine on a Google Cloud platform. That's why we have specified the resource name as a Google Compute Instance. But in case if you are working on an AWS, then you need to specify the name as AWS underscore instance. Okay. The second keyword over here, I have kept it as a default. So this default is a user defined name actually, and you can keep any name of your choice. All right, then there is a next component. Sorry, I have pasted it, I have clicked it, but the next component over here is the name, that is tag. That is also a user defined name. So any resource which you are trying to create, you can put a suitable name over there. All right, now moving to the sixth component, that is machine type. What is machine type? So machine type is something like a CPU. So what kind of a CPU or what kind of a powerful CPU you need? Since this is an example or demo, that's why I have kept actually a very small CPU, that is a micro CPU. But in case if you're looking for a production environment, then just go for some bigger machine type, that is E2 small medium, but still E2 small and medium are just only for development and demo purpose. Just look out for documentation and pick some suitable CPU if you are looking for a production environment. The next component which we are talking about is the operating system. Since we are starting or we are setting up a virtual machine, it needs to have an operating system. So what kind of operating system you want to install in it? So this is the tag boot disk and initialize params. Here we are going to specify our Debian Cloud or Debian 9 system. So we want to have a Debian operating system installed on our virtual machine. The next component which we are talking about is the network interface. And if you know, if you are working on a cloud environment, then you need to have an public IP, which so that you can access your virtual machine. So you need to define a network interface for that. So this is the code snippet which you need to keep inside your main.terraform file. And if you don't want to control the IP address, then you just define that network as default. And Google Cloud Platform is going to assign a public IP address for your virtual machine. In the previous slide, we have seen the complete Terraform file for a Google Cloud Platform. So now in this slide, we are going to compare the two Terraform file, one for Google Cloud Platform and one for AWS. So here on the left hand side, these are the code snippet from a Google Cloud Terraform file. So which is I'm not going to explain because we have seen in the previous slide. But on the right hand side, we are pretty much interested in AWS. So as I told you, we need to specify the provider. So here we are going to specify the provider as AWS. Then again, we are going to specify the region based on your location in the world. Second, this access key and secret key. This part is little different. Here in Google, we need to download that JSON file which combines of your authentication. But here we need to specify the access key along with the secret key. So that you will get from a AWS console. Don't worry, we have a demo. So I'm going to show you like where to copy the access key and the secret key. The next, we need to specify the resource. So in Google Cloud example, we have seen the resource name as Google Compute Instance. But here we need to specify that instance name as AWS instance because we are going to provision this instance on AWS environment. Then you need to give some suitable name. So I have given the name as EC2 example. The next component inside the resource is AMI. So you need to find the AMI ID from your Amazon console or AWS console actually. I'll show that ID, but to give you a hint, what is AMI? AMI is a machine ID because in Google Cloud Platform, you need to specify operating system like a Debian 10, but here you need to choose the predefined images. So Amazon provides you a list of images. In that list, you can find one for Ubuntu, Red Hat, CentOS, or Fedora. So you can choose any of the machine ID out of that list and put that ID over here so that it can provision those machines for you. The second is instance type here, and that again denotes the CPU power. So if you're looking for a demo purpose, then you can choose T2 micro or something similar. And if you're looking for production grade CPUs, then just look for the documentation and choose some very high processing power CPUs. Okay, moving further, now we have sufficient knowledge about Terraform and what are the Terraform commands. So the next task we have for us is like we need to install Terraform on our local system. So I have prepared this guide where I have put all the instructions and the commands which is needed for installing Terraform. So I'll put the link of this guide into the description section, so you don't need to copy of any of the command. Just come back and check this guide and copy all the commands for installing Terraform onto your local system. So here on the right hand side you can see this is my guide, and I'm going to click on install Terraform on Ubuntu. So first utility which you need is you need to install the unzip utility on your system, because we are going to download the installer of a Terraform in a zip file. So you need to have this unzip utility if you are working on a Linux operating system. So I'm assuming that you have installed the unzip utility because I have already installed on my system. So I'm not gonna perform that step again. The second step is we need to go to terraform.io. Click on the download CLI, and below there you should choose the installer based on your operating system. So since I'm using Ubuntu, so I'm going to use Linux. So I'm just going to select 64-bit, right click on here, copy the link, head back to your terminal on the left hand side, and I'm going to download this zip file using wget command, paste the URL, and here you can see the Terraform zip has been downloaded on my Ubuntu system. Now we need to unzip the file. So the command is unzip Terraform, and the unzip has been completed, and we can see the file Terraform which has been extracted. Now we need to go back to our guide for the next instruction. So now we have copied the link, we have downloaded the zip file. Now we need to move this file inside user local bin. So for that, what we need to do is we need to use the command sudo move the Terraform file into the user local bin. And for that, you need to have the sudo permission. Otherwise, you won't be able to move this file inside the user local bin directory. So I'm just going to copy this command and paste it over here. So here you can see my file has been moved, and you can verify using user local bin command, and here you can see the Terraform has been moved to the user local bin directory. And now we can verify the installation by running the command terraform -v, and here you can see we have installed the Terraform version 0.14.8. Alright, demo time. So the first demo which we are going to perform, we are going to set up a virtual machine on a Google Cloud platform using Terraform. If you are interested in AWS, then you can skip this demo part and directly jump to the AWS demo. But if you are interested in setting it up on a Google Cloud platform, then you can follow this session also. Okay, so I think we have sufficient knowledge which is required to provision a virtual machine on a Google Cloud platform using Terraform. So we are going to use all those concepts which I have explained earlier, and we are going to implement all those concepts in this demo. Also, I have prepared a guide where I have put all the instruction which is required for this demo. So during the demo, if you forget to note any of the commands or any of the bash script which I'm going to run, so you can come back and check this guide. I'll put the link of this guide into the description section, so you don't have to copy or make a note of any of the instruction which I'm going to perform during the demo. So you just come back to this guide and copy, and feel free to copy any of the commands. To start the demo, the step number 1 is we need to create a project on a Google Cloud platform. So here you can see on the left hand side, this is my Google Cloud platform account where we are going to create our first project. But before that, you need to sign up if you haven't done before. So just go ahead and create a Google Cloud platform account, and they offer you a 1-year free trial where you can experiment on a Google Cloud platform. So I'm assuming that you have an active account on a Google Cloud platform. Okay, so how to create a project? That's our first task. So here you can see on the left hand side, this is my Google Cloud Platform console. And here in the left side of this Google Cloud console, you can see there are some projects which I have already created. But if you haven't created any of your project, then just click on this new project and you should be able to create your new project. But anyway, that you can do it. It's a very simple step. But here I have already created a project with the name GCP Terraform. So that's going to be your first step, which we need to perform in this demo. Moving to the step number second, here you can see in the left hand side, I have already selected my project, that is GCP Terraform. The step number second is where you need to create a service account for your project. And this service account we are later gonna use for authorization. Okay, so in the left navigation menu, click here and you need to go to I am an admin section. And inside that I am an admin section, you need to click for service accounts. So here you just click on service account. And here you can see I have created some service account earlier, but you can create a new service account for this demo. Click here to create your first service account. And here you can mention your service account name. So I'm just gonna put demo service account. And then just click on create. And here on the right hand side, you can follow the same instruction over here also. Okay, so the step number third, where you need to assign some roles. So the first role which we are going to assign the project owner role. So you need to select the project. So just drill down into this drop down menu and look for the project here. And here you need to select the role as owner. Okay. There is one more role, that is compute admin role, that you need to assign. So click on add another role. And then you need to again drill down and you need to check for compute section, compute option over here. And it should be somewhere. Yeah, this is compute engine. And here you need to select for compute admin role. So that's the compute admin role which I'm gonna select. And here you can check in the guide also. This is the screenshot which I have taken from the same console. Okay, after assigning the compute admin role, we need to assign one more role, that is compute network admin. So click on add another role. And again, just go for compute option. I think I just saw somewhere here. Yeah, there, here it is. And we need to go for compute network admin. Just select that one also. Okay, so that's three roles which you're gonna need for this demo. And after that, just click continue. And then just click done. Once you're done creating your service account, then you can see over here, this is the service account which we have created, that is demo service account. And here, if you look carefully, there is a key ID column. So there is no key associated with this account. So the next step is we are going to generate the keys for this account. And that is going to be our step number 4. So here you can see on the screenshot, we need to click on these 3 dots over here for the account which we have created. So here the account which we have created is demo service. So just click on this option and then you need to look for manage key option. Just follow along with this guide. All the instructions are there. So, and after that you need to look for this add key drop down. So that is over here. And here we need to click on create new key. So once you click on create new key, then it will pop an option for JSON or P12. So we need to create a JSON file. And if you go back to our slide, which I have shown you, I think it's over here. So if you go back to our slide, then here you can see we need to download a JSON file. So this is the same JSON file I'm talking about. Okay, sorry, it is over here. So this is the same JSON file which we are going to download. So just click create. And you just need to save this file somewhere onto your system. So I'm just click OK. And here you can see I have just downloaded the JSON file, and this JSON file will be useful for you to authorize your Terraform to communicate with your Google Cloud platform. Okay, moving further, now we have completed the step number 4. We have now downloaded the JSON file that will be used later during the authorization process. But the step number 5 is we need to create a main.tf, that is our Terraform file, which I have already explained. But we are just gonna create this file from the scratch. So what we need to do, first of all, switch back to our terminal. And this is where I have already installed the Terraform, and that you can verify using this command. Okay, so we are running the Terraform version 0.14.18, sorry, 8. So I'm just gonna create one directory over here, mkdir terraform gcp demo, and just switch to that directory. I'm just gonna clear the screen, and I'm just gonna first of all create a file that is main.tf. Yep, I'm gonna open this file into vi mode. Okay, so this file is empty, and we are just gonna first copy a provider code. Okay, so just copy this code snippet. I'm just gonna explain what this is all about. So here you can see the provider is Google. Although we have downloaded the key file, but we haven't renamed that file to be like a JSON account GCP account.json. So I'll do that part later. Secondly, we need to mention the project ID, that is GCP Terraform. So if you go back to your Google Cloud Console over here, and if you click over here, then this is your project, that is GCP Terraform, and this is your Google Cloud project ID, that is GCP Terraform 307199. So you need to copy this project ID into your Terraform file. So that is going to be your project. Okay. So we just only left with this GCP account.json that we need to specify, or we need to create, or we need to copy the JSON file into this my virtual machine, which I'm running over here. Okay. And this is my region, which can be anything. It can be Asia or US based on your location, and the zone also. Okay, so this is our first provider code which we are gonna put inside our main Terraform file. So I'm just gonna save and quit. Moving to the next step, we need to copy the code snippet for the Google Compute instance, because that's the actual virtual machine which we are gonna run, and that is going to be the E2 micro machine. Okay, so again we are gonna update the main .tf file which we have inserted just the provider code there. So we are just now gonna insert the Google Compute code snippet inside that main.terraform file. So first of all, just copy this code snippet, and again open that file into the vi mode. And here you can see we already have the provider code. So I'm just gonna go into the edit mode, and I'm just gonna paste the compute instance code also. So here, this is our Google Compute instance. That's the keyword which you wanna keep, and this is the name. I have kept it as a default, but you can keep any name of your choice. That's absolutely fine. And here, this is going to be the tag, or again the name. So it is absolutely okay to keep any name of your choice. But be careful about the machine type. You need to specify the exact name, what kind of a machine you want. So I'm keeping it as a E2 micro. I just want the lowest CPU as possible, or the lowest configuration CPU as possible. Third thing, the boot disk. I'm using Debian 9 Ubuntu machine. And the fourth thing is we need to specify the network interface, and I just created this configuration over here, and I kept the network to default, so I'll get so that I can get some public IP for my virtual machine. Okay, so I think we are done with this main.terraform file, and that is sufficient enough to start your virtual machine inside your Google Cloud platform. The only thing which we are left is with this JSON. We haven't created this JSON file yet. Although we have downloaded the JSON file after creating the service account, but we haven't copied that file into this same directory so that it can be used. Okay, so first of all, I'm just gonna quit here and save this configuration or the main.tf file. I'll clear the screen, and just to re-verify whether our content has been saved, I'm just gonna run the cat command, and here we can see everything has been saved properly. Okay, so I'll clear the screen and I'll do the ls command one more time, and here you can see we only have the main.tf file over here. We don't have the gcp account.json file that we need to create it. Okay, so first of all, once again, do the cat. I just want to copy the same name, so I'll just copy it. I'll clear the name screen. I'm just gonna run the command touch and this, so it's gonna create that file, and now you can see we have the json account, gcp account.json file over here. And if you want to view the content of it, then it will be empty, and here you can see this is completely empty. So first of all, I'm just gonna copy the content of the key file which we have downloaded after creating the service account. So that is I'm gonna do. Let's head back to browser and see where we have downloaded our JSON file after creating the service account. So this is the file which we have downloaded. So I'm just going to open that file. So this is the file, and I'm just going to open in one of my editor. So this is the content of my JSON file, or the key file which we are going to use for authentication. So I'm just going to copy the content of this file. I'm just going to head back to my terminal, and I'm just going to open the JSON file which we have created, that is gcp account.json, and which is empty right now. So I'm going to open in edit mode, and I'm going to paste the content over here. And after that, just save and quit. Okay, so now we have placed our gcp account.json file just parallel to our main.terraform file. So we have everything in place now. So if you move further into the guide, and there is a step number 6 where we are going to perform these commands. The first command is terraform init, terraform plan, and the third one is terraform apply. So we are just going to look all these commands one by one. So the first command is terraform init command. Okay, so just copy this command, clear the screen over here, and just run this command. I'm just going to explain what this terraform init command is doing. So if you remember, if you see our code snippet in the main.terraform file, here is the provider, that is Google. So whenever you mention a provider over here in the main.terraform file, and when the first time you're gonna run the terraform init command, it is going to download all the dependencies for the provider, that is Google. So here, this is the line in which it is going to download all the dependency which is required to communicate with our Google Cloud Platform. So in the terraform init command, these are the prerequisite step which is done by the Terraform. So this is a mandatory step whenever you're going to work with a Terraform module. So you need to run the Terraform init command so that you can download all the required dependency which you have mentioned in your provider or in your main.terraform file. So here the provider name was Google. So if in case the provider name was AWS or Azure, then it is going to download that dependency when you issue the Terraform init command. Now you might be wondering, there are lots of things which are happening behind the scene when I issued the Terraform init command. So don't worry, we are just gonna see what it has done in the background. So if you run the command ls_lart, so you will see a directory which is created as a .terraform. So this is the directory which gets created once you issue the Terraform init command. So in that directory, you will find all the required dependencies which is downloaded when you issued the Terraform init command. So to view the content, just run the command ls and then go inside the directory Terraform, and there will be some more directory, that is provider, HashiCorp, and here you can see Google, and there will be version and that Linux, AMD 64 machine, and this is going to be your final, I think, file or the dependency, that is Terraform provider Google 3.60, that's the version. So as I told you, whenever you issue this command, so it is going to download all the dependencies which you mentioned into the main.terraform file. So we have mentioned Google, so it has downloaded the whatever latest dependency of Google provider which was available during the demo. So it has downloaded that dependency into your local machine. So here you can verify those dependencies. Okay, moving further into the guide, we have completed the Terraform init command. And here you can see this is the console log which I have pasted here in the guide. So in case if you forget, or if you want to verify your output, then you can just cross check with it. Okay, so as you can see, we have completed the Terraform init command. The next command is Terraform plan. Okay, so what is Terraform plan command? So Terraform plan command tells you like how many resources either you're going to add, either you're going to update, or either you're going to destroy or delete. So it is just going to tell you what will be the plan. Are you adding it? Are you deleting it? Or are you destroying it? So that is the main intention behind the Terraform plan command. So I'll clear the screen and I'm just gonna run the command terraform plan. Okay, so the output will be a little bit big on your console and it will be a little overwhelming, but don't worry, we are just gonna go through the complete output. So this was the command which I have run, that is terraform plan. And as you know, if you see our code snippet, then we are trying to create a virtual machine, a virtual compute instance. So this is the compute instance which we are trying to create. So here you can see it first highlighted what we are going to do. So we are going to create a resource. So that's the first thing it is going to mention you when you run the Terraform plan command. So you are going to create a resource. So that's correct. Yeah, we are going to create a resource. And what kind of resource it is? So that is a Google Compute instance. So that's the resource which we are going to create. And if you look carefully at the bottom of this, so the plan is one to add. That means you are trying to add one resource. That's a new resource actually. So that's the thing which you need to notice over here. The second is zero to change. So are you going to update or change any of our existing resource? Then it's zero, because no, we are not going to update or change any of our existing resource. The third is zero to destroy. That means we are not going to delete or destroy any of our existing resource. So our main intention is we just want to create our virtual machine inside our Google Cloud platform. So that means we are going to add a resource, that is virtual machine. So this is the this is the Terraform plan command. One thing which you should remember, this Terraform plan command never create a resource. It just tells you what it is going to do. Okay, so here you can see we are just trying to add one resource and nothing else. So this command will never going to provision or run any of our virtual machine on our Google Cloud platform. Before we move further and issue our next command, that is going to be Terraform apply, I just wanted to show you my Google Cloud console so that I can show you that I'm not running any of my virtual machines already. So here you can see this is my Google Cloud platform and these are the resources. The resources list is completely empty, and you can also verify from here from the left navigation menu, going to compute engine and going to VM instances. And here you can see the list is completely empty and I am not running any of the virtual machine already. So the next command is we are going to run the terraform apply command. So that is going to be our next command where it is going to communicate with our Google Cloud platform and it is going to actually start a virtual machine on our Google Cloud platform. Okay, so I'm just gonna copy this command and on the left hand side on the terminal, first of all, I'll clear the screen and after that I'm just gonna paste the command. And it will ask enter a value. So are you going to provision this virtual machine? So I just gonna say yes. Okay, so here you can see if you read the logs carefully, it is first of all it says that it is creating and it took some time to create those machine, and after that apply complete and one resource added. So that means our virtual machine has started in our Google Cloud platform. So just go back to our same Google Cloud VM instance screen and just refresh this page. And here you can see this is the test instance which we have started. And as you know, we have mentioned the zone Europe West 4. So that's our zone and the name is test. So if you go back into our code snippet of our main.terraform file, then you will find the test we have mentioned. So that's the test name which we have mentioned. Okay, So that's our virtual machine name, which we have provisioned using Terraform. And one more thing, you can see the external IP which we have got. So this is the external IP which is returned by Google Cloud Platform. And you can use this external IP to SSH into this virtual machine. Okay, so this is how you provision a virtual machine inside Google Cloud Platform using Terraform. So now we have seen Terraform init, Terraform plan, and Terraform apply command. So these are the most three basic command which you need to know to work with Terraform and any other cloud service provider. Okay, so we have done the verify steps also, so that you can check it by yourself by going back to your Google Cloud Console and that you can verify. The next command is terraform destroy, and that is going to be the last command for this demo. And this is, it says destroy, so it is going to delete everything. So here you can see our test instance is running, and now we just wanted to destroy this instance. So just copy this command from here, go back to terminal, clear the screen, and paste the command. So as the command says destroy, it is going to remove, and here you can see now there is zero to add. Yeah, we are not adding it, we are not updating it, but yeah, we are trying to destroy it. So that's the command. Just type yes, and it's gonna take some time, and it's going to delete our virtual machine instance. Okay, so here it has destroyed our resource, and we can go back to Google Cloud Console and just refresh this screen to see if whether it has deleted or not. And here you can see the test instance or the virtual machine has been deleted. Alright, so now we are done with our first demo, that is provisioning a virtual machine on a Google Cloud platform using Terraform. And now we have pretty much seen the Terraform init, Terraform plan, Terraform apply, and Terraform destroy commands. Moving to the second part of the demo, where we are going to provision a EC2 instance on AWS console. So again, I have prepared this guide for AWS also, and you can find this link of this guide into the description section of this video. To start the demo, first of all, the main requirement for this is you need to set up your AWS account. That is going to be our first step. So I would recommend you to create an account with AWS, and AWS offers you a 12 months free trial or 750 hours per month limit free trial, which you can use for this kind of a demo. But you need to provide some credit card information, so that's absolutely okay. That will charge you $1 for authorization, but after that it won't charge you for anything. So I'm assuming that you have an AWS account and you have already signed up for that. Moving further, after you have signed up for AWS, you need to log in, and you need to log in as a root user. So that is going to be your second step. So I'm just going back to my AWS account, and here I need to input my email ID and password. So I'll be back after entering my username and password. And also remember, you need to log in as a root user. Once you log in into your AWS console, then this is the dashboard which you're gonna see. Okay, moving along the guide, the next step is where we need to generate the access keys. So as I told you, like whenever we are working with the AWS, so you need to have your access key as well as the secret access key, so that Terraform can authorize itself to communicate with AWS. So for that, what you need to do is you need to go on My Security Credentials, and that you can do it by clicking on your username over here, going to My Security Credentials, and then go for access keys over here. And here you can see I have already generated my access key. But if you are doing it for the first time, then you need to click on this create new access key. And once you click on it, so it is going to show you the access key ID as well as the secret key. Here I have hidden it because that's some confidential information which I don't want to share, but you get the idea. Like you need to generate this access key and the secret access key here. But always remember, this secret access key will be visible only once for security reasons by AWS. And once you close this, then you won't be able to use or view this secret access key actually. So you need to copy both access key as well as the secret key. So I'm assuming that you have copied both the information, and after that you can just click on close. And here you can see as I have already created one on 18th of March, but here I can see there is a one more access ID key which has been generated on 23rd of March, the day when I'm recording this video. Okay, and both are in active state. So that's the thing which you need to notice over here. So moving back to the guide, same instructions I have mentioned over here with the instructions and the screenshot. And here you can see you need to copy the access key ID and the secret access key. The step number third is where we need to create a main.terraform file, as similar to the previous demo where we have seen for Google Cloud Platform, also where we have created the main.tf file. So this is on the left hand side, you can see my terminal, and I'm just gonna create a directory AWS demo. I'm just gonna switch to directory AWS demo. I'll clear the screen. I'm just gonna create the file main.tf, and I'm just gonna open in the VI mode, and this file is empty, so we don't have anything over here. Okay, so the step number one over here is we need to mention our provider details in for AWS. So the syntax for that is resource, provider type, and the name. Name is not optional, but it's a user defined, or you can skip it also. That's also fine. Okay, so here is the actual example where I have mentioned like what is provider, what is AWS, and region, access key, and secret key. Here you can see this is XXX because I don't want to put my actual secret key or access key over here. I'll copy this code snippet from here, and I'm just gonna paste it inside my main.terraform file which I have just created. And I'm just gonna replace this access key because I don't know with the actual values which I have created inside my AWS console. Okay, so now I have copied my access key and secret key. As I told you, I cannot show those secret key and access key because of security reason. But after copying and pasting your access key and secret key, you just save and quit it. Okay, so after that, moving further into the step number second, where we need to create our AWS instance. And for that, we need to find the Amazon machine image, and that you can find by using AWS console. So go back to your AWS console, click on services, go to EC2, and in the left navigation, you should see an option AMIs. Click on AMIs. Here in the drop-down drop-down option, always remember to select public images. And here you need to type the option Ubuntu because I'm just gonna use the Ubuntu as my operating system for virtual machine. Click enter. And here you can see this is the AMI which we are looking for. So once you click on this line number, then you can just copy this AMI ID from here. Copy to, I'm just gonna copy it. Okay, and then copy this value and store it somewhere because we are gonna need it later. Okay, moving back to the guide, all the instructions I have mentioned for how to find the AMIs over here also. The next instruction is we need to mention the AWS instance. So that's the next code snippet which we are gonna put it over here. So copy this code snippet where we are going to create our AWS instance, and this is the name, that is we are keeping EC2 example. So it is a user defined name. You can keep it any name of your choice. Secondly, we have copied the AMI ID. So you need to copy and paste that AMI ID over here. And third thing, you need to mention the instance time. Since it is a demo purpose, so I'm keeping it as a t2.micro. But you can increase this instance type based on your requirement and choose some higher configuration also. And this tag name is completely up to you what kind of a tag name you're gonna put. So I'm just gonna put Terraform EC2. Okay, so that's the code snippet which I'm gonna copy from here and paste it inside my main.tf. But I'm also gonna update the AMI also. Okay, so copy it and go to your terminal on the left hand side and yeah, open in VI mode, go into edit mode and paste the content over here. So the thing which we need to replace it over here is the AMI ID. So I'm just gonna remove the existing one and I'm just gonna paste the new one which we have copied from the AWS console. So I'm just gonna paste it over here. So now save and quit. Okay, and you can re-verify whether you have saved correctly or not by using the cat command. And here you can see everything, the provider name and the AWS instance. All right. Moving to the next step, now we are ready with our Terraform file, and now we can run our Terraform command. So the first command which we are going to run is the Terraform init command. So what does the Terraform init command do? So first of all, just copy this command and I'm going to explain like what it actually does. So just run this command first of all. Okay, here you can see our command has run successfully. So the Terraform init command is responsible for downloading all the dependency which you mentioned for the provider. So the provider over here is AWS. So if you'll see our code snippet, so that's the provider we have mentioned, that is AWS. So whenever you are going to run a Terraform init command, so it is going to first of all look which is your provider. So that is your AWS, and it is going to find the latest version whatever available. So at that point of recording this video, the latest version was 3.33, and it is going to download all those dependencies onto your local system. Okay, and you can verify this dependency by running the command lslart, and you should have a .terraform file, folder which is created after running this terraform init command. Okay, and as you remember, we have only created the main.terraform file. Okay, and these files has been created after we run the terraform init command. Okay, so and you can also view the content here also by running the ls command, and here you can see. So these are the content of our terraform directory. And here you can see there is an image Linux AMD 64, which means that's the virtual machine or EC2 instance image, which is Terraform has just downloaded by using this provider information which we have mentioned. So if you go back to our guide, so this is the provider information, that is AWS. Once we mention this thing, then Terraform init command going to download all the required dependencies for AWS. All right, so now we have run the Terraform init command. The next command is we need to run the Terraform plan command. So I'll clear the screen over here, and I'm just gonna run first of all the command terraform plan. Sorry, I just did the typo over here. I'll just clear the screen once more, and I'm just run terraform plan command. All right, so the output of this command is a little bit big, but don't worry, we are just gonna go through the output and try to understand it. Okay, so what the Terraform plan command does, it just tells you that what it is going to do once you actually run the Terraform apply command. So Terraform apply is the next step, but there is a final command Terraform apply, which is going to actually run your or install or provision your EC2 instance on AWS. But we are still one step behind, and we are focusing on Terraform plan command. So Terraform plan command tells you like what is going to happen in future, and the future is the next step. So it is going to create one resource. So that's why there is a green plus sign over here and with the option create. So that means once you run the Terraform apply command, then it will be going to create an resource. Okay, so if you look carefully, there are three options over here in the plan, that is one to add. That means one resource will be added, and that's correct. We just want to spin our EC2 instance. So we are trying to add a resource in our AWS environment. That's why it shows one to add. We are not updating anything, that's why it's 0, and we are not deleting anything, so that's also 0. So Terraform plan command tells you like what is going to happen once you run the Terraform apply command. So it will just sketch you the plan, like how many resources are going to be added, removed, or updated. All right, so now we have seen the Terraform plan command. So the next command is the Terraform apply command. So this is the command which is actually going to start our EC2 instance by contacting the AWS server, and it is going to start our EC2 instance. All right, so this is the command Terraform apply. So I'm just going to copy from here and paste it on my terminal and hit enter. It will ask like, do you want to perform this action? So just type yes and hit enter. Okay, so our Terraform apply command has finished successfully, and here you can see it has added one resource and the message is apply complete. So now we can go to AWS console and verify whether our instance has been created or not. So go back to your AWS console, go to services, go to EC2, and here you can see instances running, that is one, so which we have started recently. Just click on it. And here you can see the status is running. The name is Terraform EC2, and which you can verify by using our main.tf file. And here you can see the name is Terraform EC2, the same name which we have given over here. So you can see over here also, and it's running. And yeah, this is the our EC2 instance which we have just provisioned using Terraform, and you can verify the zone also, and this is our public IP address so that you can use it to access it. And yeah, so this is how we provision our EC2 instance using Terraform. Alright, so the next command which I would like to tell is to destroy. So now we have created this instance, so how we can destroy it? So the command is pretty much similar. The only thing which we are going to change is the last keyword, that is destroy, and hit enter. And it will again ask for confirmation, so just say yes and hit enter. Okay, so the destroy has been completed and it has destroyed or deleted our one resource. So on the right hand side, we can just refresh this console and see whether it has been deleted or not. And as you can see, the instance is gone. So we have no longer any EC2 instance running over here. Okay, so you can remove this filter also. So you can see we have previously terminated two instances, but none of any of the instances running right now. Alright, so with that, that was our last command, that is Terraform destroy, and that's the demo I just wanted to show you for AWS part also.
In today's session, we are going to discuss what is Terraform input variables, how to declare Terraform variable, what are the different types of Terraform variable, that is string, number, boolean, list, map. And finally, we are going to see demo for each variable types. And there is also going to be a second part of this session. And in that session, we are going to touch upon some advanced concept about Terraform variables. In the second session, we are going to start with the variable.tf file. So we will focus like how to create a variable.tf file and how to store your variable inside that file. Secondly, we are going to also look on the Terraform tfvar file. So this is a little special where you can also store your Terraform variable. So we are going to see that one also. And there is a one more concept where we can create a multiple Terraform var file based on your different environment like staging, production, or testing. And lastly, we are going to see how to pass those variables using the command line. Along with the demo, I have prepared this guide. I'll put the link of this guide into the description section of this video. So in this guide, you will find all the Terraform file along with all the Terraform command which I'm going to perform inside the demo. So you can just come back and check this guide and you don't need to remember or note down any of the commands. So I'll put this link into the description. So just go back and check this guide where you will find all the details which is required for this demo. To start with, what is Terraform input variable? So this is my Terraform file. This is a sample Terraform file where I have not declared any variable yet. So if you look carefully over here, this is my provider, that is AWS, because I'm going to provision an EC2 instance on AWS. So this is my provider tag over here and with the region, access key, and secret key. Secondly, this is my resource where I'm going to define my EC2 instance and the type of EC2 instance which I'm going to provision in AWS. So here you will find all the details, like here I'm trying to create a EC2 instance of t2.micro. And the tag name which I'm going to assign is Terraform EC2. So the question is how the variable fit into this picture of Terraform. So consider a scenario where you need to change the instance type from t2.micro to t2.medium. So is it possible to change? Then the answer is yes. Using the variables, you can change the instance type from t2.micro to t2.medium. And you do not need to hard code this value inside your Terraform file. Similarly, if you need to change the tag name inside your Terraform file, then that's also possible, and that you can also do using the variables. Here is one of my Terraform file where I have declared a variable, and in that variable I'm going to change, or I'm going to define the instance type. So the variable name over here is var.instance_type. So this is the variable name which I have kept, and just below the file you will see this is my variable where I have defined the actual values, what it's going to hold. So here I need to define three things: description, type, and default. And in that default, we are going to specify its actual value. So this is how you define the variable inside Terraform, and this is the syntax you need to follow to declare a variable. So starting with variable is the keyword which you need to keep. And secondly, in the double quotes, you need to define your variable name. The variable name can be of your choice, so you can put some meaningful name to your variable. Apart from that, there are three things which you need to be careful about. So first one is description. Second one is type, and third one is default. So starting with the description, so this is something, a meaningful name which you need to provide to your variable, so that you can identify what kind of a variable it is. Second, you need to define the type, what kind of a variable it is going to be, whether it's going to be string, boolean, list, number, or any other type. The third thing is default, what it's going to be the default value. So here, just I'm taking an example. So I'm just trying to assign a value t2.micro. So if you're trying to set up a instance time, so here you can change the value. So like t2.medium also. Now we know the syntax on how to declare or how to create a variable inside Terraform. So the first variable type which we are going to take is string. As I mentioned earlier, first of all, we need to take a keyword variable. Secondly, we need to define the variable name that is of your choice. So here I have taken the variable name as instance_type. Third, we need to define the description. So here you can define some meaningful name of the variable. Fourth, we need to define the type, and here I'm defining the type as string because we are going to declare a string type variable. And what's the value of this string type variable? So the value is t2.micro. Before we actually jump into the demo, there is one thing which I would like to mention over here. If you're trying to learn Terraform for the first time, then I would highly recommend to follow the part 1 where I have explained what is Terraform and how to create your first Terraform file, because that will help you to understand these concepts in a much easier way. Okay, let's head back to our guide and see what is the Terraform file for defining the string type variable. So if you scroll down into the guide, there is a section 2.1 where we have defined the Terraform file for a string variable type. So here, if you scroll it down further, then here we are going to first define a provider. Then we are going to define a resource, but in that resource, we are going to create a variable that is instance type. And in the same Terraform file, we are going to create a variable. So here I have defined the variable that is of name instance type is string, and the instance type which we are taking over here is t2.micro. So what you need to do is you need to copy this code from here, head back to your terminal, and you need to create main.tf file. So I'm just gonna create this file and as well as edit it. And once you open that file into the edit mode, you just need to paste the content. And just to reiterate, we are creating the provider. We are just creating a tag provider that is for AWS. Then we are defining the resource for AWS instance, and that is t2.micro. And for t2.micro, we have taken the variable that is of string type. Okay, so once you paste those content inside the main.tf file, you need to save and quit. Okay, that's been done. You can verify the file. So yeah, we can see all the details are there. Before we run the Terraform command or apply these changes, let's go back to our AWS console and see if we have any previous EC2 instance running or not. So this is my AWS console where I need to refresh this page and see if there is any running instance or not. So as you can see, there is no running instance here. Okay, so let's head back to our guide, or sorry, terminal, and I'll clear the screen. Now we have created our main.terraform file along with the variable of string type. Now we need to apply those changes. I'll increase the font size over here so that you can see a little bit more. Okay, so the first command which I'm going to run is terraform init. It is going to download all the dependencies for AWS because we are going to create an AWS resource. Okay, that's been done. I'll clear the screen. The second command we are going to run is terraform plan. It is going to tell how many resources it is going to add. Okay, so here you can see it is going to add one resource, that is EC2 instance, and that is t2.micro. Okay, I'll clear the screen again, and I'm going to run the final command, that is terraform apply. Okay, it will ask, do you want to perform these actions? So you need to type yes. Now it's creating those EC2 instance on AWS. Okay, so the instance has been created. Let's head back to our AWS console and verify our EC2 instance. So you just need to refresh this page. And here you can see the instance state is running. And the name of that is Terraform EC2. And if you look our guide over here, I think this is over here. So here we have defined the tag name as Terraform EC2, and that is again, it is the same tag name over here. So that means our EC2 instance has been created successfully, and we have created a string type variable inside our Terraform file. Now we have seen like how to create your string type variable inside your Terraform file. Before we jump to the next variable type, let's destroy this instance. So you need to run the command terraform destroy. Oh, sorry, I have misspelled over here. So you need to type destroy. Moving to the next variable type, that is number. So again, the syntax is going to be pretty much same, and all the field description, type and default is going to be the same. The only thing which is going to be changed over here is the type. You need to define the type as number, and the value, that is, you need to define some numeric value to it. Let's head back to our guide and see the actual Terraform file for the variable type number. So if you scroll down further, then this is the heading for number variable type, and this is the Terraform file which is we are going to use for number variable type. So here the structure and the Terraform file is pretty much same, provider and resource. The only thing which we have changed over here is the count. So what does it mean by count? So in the previous example, we have seen like we have created only one EC2 instance, but here we are going to provision two EC2 instance on our AWS console. So here we have defined the variable that is instance count, and the type we have taken is number, and the default value which we have given is 2. So that means we are going to provision two EC2 instance on our AWS. Copy this code from here and go back to your terminal and create your main.tf file and paste the content over here, save and quit. Clear the screen, verify the content of the file, and yeah, it looks pretty much okay to me. I'll clear the screen again, and we have seen the Terraform command sequence. Like first of all, we need to run the Terraform init, then Terraform plan, and then Terraform apply. So I'm just gonna run all these three commands because I have already shown those commands in the string type variable. Alright, so now we have applied all the Terraform configuration, and now we are provisioning two EC2 instance. So let's get back to our AWS console and refresh this page. And here you can see we have two Terraform EC2 instance running over here. So this is how you can use the number type variable in Terraform to increase the instance count, and you can use to provision multiple machines inside your AWS console. The next variable which we are talking about over here is the boolean. So again, the syntax is pretty much same. The only thing which you need to define is the type, and the type which we are going to define is bool for boolean. And it can hold two values, either it can be true or false. In the guide, in the point 2.3, you will find the example of a boolean variable, and this is my Terraform file. And in this Terraform file, I'm just enabling the public IP address. So this is the tag which you need to use, associated public IP address, and you need to pass the value that is true. So here I have created a variable, a boolean variable, and the value I have assigned is over true, and the same variable name I'm going to use over here. So I'm just going to perform the same step. I'm just going to copy this file, copy this code of Terraform file into our main.tf, and I'm just going to run the commands Terraform init, Terraform plan, and Terraform apply, and then we are going to verify on AWS console. So I'm just going to fast forward all this command, and I'll be back once everything is done. Alright, now I have applied all the Terraform commands. Let's go back to our AWS console, just refresh this page. And here you can see our EC2 instance is running, and now we have our public IP address associated with our Terraform EC2 instance. Till now we have seen string, number, and boolean. Those are single data types, but now we are going to see a collection of data types. So we will start with the list. and as the name suggests, list contain multiple values. So here the variable syntax is again going to be the same. The only thing which is going to be changed over here is the type. So you need to define the type as a list, but along with that you need to mention what kind of a list it is. Is it going to be a string? Is it going to be a number? Or is it going to be a boolean? So here the type I have defined is over here is a string, and the string contains the user. So I'm taking the list of user as user1, user2 and user3. Let's head back to our guide and see the example of a list Terraform file. So this is my list Terraform file where I'm going to provide the AWS provider, and the resource type is AWS instance. And the one thing which I have added over here is the IAM user to this resource. So for this EC2 instance, I'm going to add a list of user as an IAM user for AWS, and the variable name I have kept over here is this variable username. And this is little special because I'm going to, it's kind of a iteration which I'm going to perform over here. So here I'm just going to define a function that is length, and then length is going to calculate the length of my list variable. So list variable is over here, which I have defined as a user underscore name, and it contains three values: user1, user2 and user3. So again, it is going to put all this value inside that IAM user, and it is going to create the all three user inside my AWS console using this count.index, because we have already taken out the length of my list. So now I'll create a main.terraform file copying this code, and I'll run the command terraform init, terraform plan and terraform apply. So I'll fast forward that particular portion, and I'll be back once my EC2 instance is running. Alright, so now I have applied my configuration of my Terraform commands. Let's go back to my AWS console and refresh this page. And here you can see my EC2 instance is running. The next thing which we need to verify is the IAM user. So click on AWS homepage, and this is going to be your dashboard. Click on IAM, and here you will see users. So click on it. And here you can see we have created three users, user1, user2 and user3. There is a typo in the user3, but anyway, you know the rule over here. So now we are able to create the three users inside our AWS console. Moving to the next and last variable, that is map. And again, the syntax is pretty much same, but only thing which you need to be careful over here, you need to type you need to define the type as a map, as well as you need to mention what kind of a variable it is going to be. So here I have taken an example for a string map type. And as you know, map always consists of a key and a value. So here the key is project and the value is environment. So this is how I'm going to define my map variable. Head back to our guide, and here you can see I have defined my Terraform file in the 3.2 section. So this is my Terraform file which I'm going to use to define my map variable. And here I have defined the provider as AWS, and again I'm going to provision the EC2 instance on AWS. And this is the variable name which I have kept over here, that is project environment. And in the project environment, I have taken the project name as project alpha and the environment type as dev. Okay. So again, I'm just going to perform the same step. I'm just going to copy this Terraform file and I'm just going to run the command terraform init, terraform plan and terraform apply. So I'll just fast forward those commands and I'll be back once everything is applied. Alright, so now we have applied our Terraform configuration. Let's head back to our AWS console and refresh the page. And here you can see we have provisioned our EC2 instance. We need to verify one thing for this EC2 instance, that is environment and project name. So you just need to click on this instance ID. And once you click on this instance ID, then you will be redirected to this page and you need to click on this tags. And here you can see the project is project alpha and environment is dev. And if we'll go back and check our guide, and here, this is the same environment and project which we have defined inside our map variable. All right, so that concludes our first part where we have seen the string, number, boolean, list, and map variable type inside Terraform. In the second part, we are going to see the variable.terraform file, Terraform tfvar files, multiple Terraform tfvar files, and how to set the variables using command line. Hello everyone, this is Rahul and welcome to the second part of Terraform variable series. Alright, so what do we have in today's session? So this is my second part on Terraform variable. So first of all, we are gonna see how to create a variable.tf file, that is variable Terraform file, because where you're going to store your variables. Secondly, we are gonna see one more advanced concept on terraform.tfvar. So it is one more file where we are going to create the variables, but it is a little bit different from a variable.tf file. So that is going to be the second topic of discussion. Don't worry, we are gonna perform the demo on each topic which we are going to discuss today. So the third in the list we are having is Terraform tfvar, where we are going to create a multiple Terraform tfvars based on the different environments such as staging, testing, and production. So the third in the list we are having is multiple tf.var files. So it is also a same concept, but in the multiple Terraform tf.var files are based on the different environment which we generally have. So then let's take an example: testing, staging, production. So we are gonna see the demo of that one also. And the last topic which we are going to discuss is how to pass a variable using the command line argument. So that is going to be our last topic of discussion along with the demo. If you haven't seen my previous session where we talked about variable types such as string, number, boolean, list, and map, then I would highly recommend to check my first part where I discussed about these Terraform variables, because that is going to be the basis for today's session. Alright, so to start with our first topic, that is variable.tf, that is variable Terraform file. So first of all, we are going to consider a simple scenario where we are going to create only one Terraform file, that is main.tf, and in that file we are going to create variable also. So we are not going to create a variable.tf file separately. So first of all, let's understand this concept. So here you can see we have created a variable that is var.instance_type, and the same variable we have defined in the same file, that is main.tf over here. So the variable type over here is string and the value is t2.micro. So in this approach, what we have done, we have created only one file, that is main.tf, and inside that file we are having our actual Terraform script along with our variable. This concept is very easy, and this implementation is very easy when you are trying to learn Terraform. But this practice is not followed when you actually work with production or staging environment. So you need to have some dynamic configuration in your Terraform file. So for that purpose, we are going to create a separate variable.terraform file. So how to do that? So to improve our code, what we need to do is, first of all, you need to create your main.terraform file. So in that Terraform file, you will see we are having provider, that is AWS. Second, you are having a resource, that is EC2 instance. So these two components are mandatory for creating a Terraform file, but this is just an example. It can differ for Google Cloud Platform, for Azure also. But here, if you look on the right hand side, this main.terraform file doesn't contain any variable. So how to create those variables, or how to store those variables inside Terraform file? So for that, we are going to create one more file that is called variable.tf, and inside that file we are going to write our variable. Okay, so as you can see on the left hand side, the same variable we have created in the same file, that is main.tf. But once we are talking about the variable.terraform, then we are going to create a separate file, and the name of that file should be variable.tf. Okay, so here everything is same. The only thing which we have did over here, we have created two files. One is main.tf and second is variable.tf. And everything, if you compare on the left hand side, will be same. Okay, now we know the concept of variable.tf file. Let's perform some demo. So along with this session, I'm going to post this link of this guide into the description section of the video. So all the commands and all the scripts which I'm going to perform during this demo will be available in this guide. So you can follow that guide. As of now, I'm running this guide on my local host, but as soon as I publish this video, so this guide will be available on my website. To start with, first of all, we need to create main.tf file. And for that, this is the content. We need to mention the provider, that is AWS. Second, we need to mention the resource. And here we are going to start an EC2 instance on AWS. So that's the resource which we are going to provision using Terraform. So I'm just going to copy this script from here. And this is my terminal on the left hand side, and this is my Linux machine where I have already installed Terraform. And if you haven't done the installation, then also I'll put the link and the video session where I have shown how to install Terraform into the description section of this video. Okay, so to start with, first of all, I'm going to create a main.terraform file, and for that I'm just going to directly write main.vi main.tf. Okay, I'm just going to paste the content over here, and I'll just save and quit. I'll clear the screen. So here you can see my main.tf file has been created. I'll view the content, and yeah, I can see everything looks okay to me. Okay, if you follow along the guide, then the second step which we are going to create is variable.tf file. So here the content is pretty much simple, and here we are going to declare a variable of type string, and the value is t2.micro because we are going to spin a EC2 instance of t2.micro because we are just performing for the demo purpose, so we don't need heavy CPU machine. So that's why I have taken t2.micro. So I'll clear the screen on the terminal on the left hand side, and I'm just gonna write vi variable.tf. Okay, and I'm just gonna copy this content and paste it over here. After that, I'll save and quit, and I can see if file has created. So yeah, my file has been created. I can verify the content of variable.tf by running the cat command. And yeah, it looks okay. So the next question is how this whole variable thing will work together. So here in this guide, I have mentioned the command terraform apply, but if you are doing it for the first time, then you can't run the terraform apply command directly. You need to follow some sequence of terraform command. So as you can see on my terminal on the left hand side, first of all, I'll clear the screen. The first command which you need to run is terraform init. So this is the first thing which you need to do. It is going to download all the dependency for AWS environment on your local system so that it can initialize all those things. All right, so now I have run the terraform init command and all the required dependencies has been downloaded for AWS environment. So before we run actual terraform apply command, there is one more command, that is terraform plan. That is our second step which we need to run. So terraform plan command is actually telling you how many resources it is going to be added. So as of now, we are trying to create a EC2 instance. So that's why we are going to create one resource into AWS environment. So this command is going to tell you like how many resources is going to be added. So that is 1. So that's the purpose of our terraform plan command. So as of now, we have seen 2 commands. Those are the prerequisites command which you need to run every time before you run your terraform apply command. So the 2 commands are terraform init and terraform plan. Okay, so before we apply, I'll clear the screen, and the final thing which we need to do is terraform apply. And it is going to take some time. I'll be back once this terraform apply command is done. All right, so as you can see below, our terraform apply command has just finished and it has added one resource to AWS. So I'll head back to my AWS console, and this is my dashboard of my AWS account. This is a free account which I am using. Click on EC2. And here, if you see, the one instance is running. So click on it. And here you can see our Terraform EC2 instance has just provisioned and it is up and running. So this is how you are going to create a variable file, and the same variable file can be used to define the t2.micro instance type. And this is just an example of a variable.terraform file, and this file can be complex in your real world scenarios, but this is just a simple example and the demo for variable.terraform file. Before we jump to the next topic of discussion, the first thing which we need to do is we need to destroy this EC2 instance, because we are going to again spin the same EC2 instance but with a different setup. Okay, so how to do that? So for that, there is a command terraform destroy, and it is going to destroy your EC2 instance. It will ask enter a value, so you need to type yes, Okay, so here you can see the message destroy complete. So that means our instance should be destroyed, and that we can verify from here. We just need to refresh, and here you can see our instance has been deleted. Moving to the next topic, the thing which we are going to do over here is we are going to create a Terraform tfvar files. And again, these files are being used to store the variable, and we are going to perform the same demo where we are going to provision an EC2 instance on AWS, but this time we are going to use this tfvar files. Our setup is pretty much same. We are going to create a main.terraform file. After that, we are going to create a variable.tf file. But here we are going to create a one more file, that is Terraform tfvar file. Yeah, I know it might be little confusing to you. We are already having variable.tf file, and again we are creating a Terraform tfvar files. But why do we need it? But hold on your question. We are going to answer that question into the next topic of discussion, where we are going to create a multiple tfvar file. But just for the time being, just try to understand, like we need to create one tfvar file where we are going to store the variable value. So we are going to create three files over here. First of all, main.tf, and here we are going to write the provider. Second, the resource which we are going to provision, that is our EC2 instance. And that EC2 instance we have already stored in the variable, that is instance type. So in variable.tf, we are going to declare the variable. That's it. We are not going to store any value. We are just going to define a variable over here. And this variable name over here, you can see we are using into the main.tf. Okay. The third file which we see over here is Terraform tfvar. And in that file, we are going to put the actual value of our instance type, that is t2.micro. And since this is a string type, that's why it is under double quotes. Let's start creating these files. So first of all, I'm going to create a main.tf. And for that, what I'm going to do, I'm just going to copy the content from here. I'm going to head over to terminal, and I'm just directly going to write vi main.tf. I'm just going to paste the content. I'll save and quit. Moving to the second file, that is variable.tf. I'm just going to copy it. I'll clear the screen over here. I'm just going to write the command vi variable. And always remember, try to put the correct name. If you make any spelling mistake in the file name, then it might cause you some trouble. Okay. So I'll just paste the content here. I'm just defining the variable, but not putting the actual value. I'll just save and quit. I'll clear the screen. And the next file which we are going to create is Terraform tfvar. I'm just going to copy the name directly, so it will be a little easy for me. Okay, so I'm just going to paste the content. That's done. Okay, I'll clear the screen. I'll just verify the content, and here I can see 3 file has been created. We can verify it by going into it. And yeah, it looks okay. The main.tf, I'll clear the screen, and we can also look for variable also. And yeah, it looks okay. And again, we can look for Terraform tfvar, and it's look okay to me. Okay. The next step in which we are going to run 3 commands, Terraform init, then after that Terraform plan, and then Terraform apply. So I'm just gonna speed up this process because this gonna take some time. So I'll just fast forward this process, and I'm just gonna run these 3 commands one by one. Once you run the Terraform apply command, then it is going to ask, do you want to perform this action? So you simply need to type yes. Now our EC2 instance has been provisioned. We can go to our AWS console. I'm just going to refresh this page. And here we can see our Terraform EC2 instance has been created. And this is the name which we have supplied using Terraform tfvar files. Now we have seen how to use tf.var file. Let's first destroy this instance. Moving to the next topic, where we need to create a multiple Terraform tfvar files, and we are going to answer that question, why we need Terraform var files and why they are important. Okay, so here on the left hand side you can see we are having a main.terraform file, and here the example is pretty much same. We are going to provision an EC2 instance, and the provider is AWS, and this is the resource which we are going to provision. But here if you look carefully, then we are going to create here 2 variables. So the first variable is instance type, and the instance type which we are going to define is t2.micro. Secondly, there is a one more tag, and we are going to create a variable for that tag also, and the variable name for that is environment_name. So why we are using environment_name? Because I want to create this Terraform file for different environment, that is staging and production, and I want to supply those values inside this tag variable. So if I'll hard code some value over here, then I cannot put or assign some different values inside this main.terraform file. So that's why we need to have multiple Terraform var files to supply those values. Okay, but don't worry, we are gonna see the demo as well as this example. So here I'm going to create a variable.tf file, and this variable.tf file is going to be empty. We are only going to create, or we are only going to declare variables. Now we have our main.tf and variable.tf. The next file which we are going to create is our stage tfvar file. And as you can see, the name of the file is different, and we are using stage because we want to have this file for staging environment. And again, we are going to create a one more file, and that file is going to be for production, and the name of the file is production.tfvar. So here the variable assignment is pretty much same. We are going to assign t2.micro value, but the environment name will change. Here we are going to define stage for staging and production for production. And then we are going to use these files based on our requirement. If we are going to put this file, or we are going to apply this configuration on a stage environment, then we are going to use stage tfvar. And if we are going to apply the same configuration on production, then we are going to use the production tfvar, so that we can change the value of environment variable. Either it's going to be stage or either it's going to be production. So that's why we have created these two files, and we have created these variable along with the variable.tf file. Then the next question comes, like how we are going to supply this file name using the terraform apply command. So here is the syntax for supplying the different tfvar files along with your terraform plan command or terraform apply command. So here the command is pretty much same. You can write terraform plan or terraform apply followed with the keyword -var -file and then your actual file name. If you are going to apply this configuration for stage, then you are going to put stage.tfvar. And if you're going to apply the same configuration for production, then you're just going to supply the production tfvar. Let's head back to our guide for the demo. And here, first of all, we need to create a main.tf. Along with that, we are going to create two variables for environment name as well as instance type. But let's first of all create the main.tf file. I'll copy the content from here. I'll go to terminal and I'm just going to write main.tf. I'll paste the content. I'll save and quit. Next, we are going to create a variable.tf. So I'm just going to copy the name of the file. I'll just type the command vi and I'm just going to paste the content over here. I'll clear the screen. And again, we need to create two more files. One is stage tfvars. So I'll just copy the name and I'll go back to my terminal. I'll paste the content over here. I'll save and quit. And again, I have not written that production.tfvar, but I'm just gonna create that file also, stage or maybe production.tfvars. I'll update the instruction in this guide. And meanwhile, I'll just copy the content from here for stage. And here I'm just gonna change the content to production. I'll just save and quit. Now again, we need to run the three commands. So the three commands are terraform. First of all, terraform init. Then second, I'm gonna run terraform plan. But as you can see, this command is now a little special. Here you need to supply the name of the file, the tfvar file which you need to apply. So I'm just going to apply stage tfvar file. And then I'm going to run the terraform apply command again with the same parameter over here. So I'm just going to fast forward this clip and I'll be back once everything is done. Now we have run all the three commands along with the file which we need to supply in the Terraform plan and Terraform apply command. Next, we will go to AWS console. I'll just refresh this page. And here you can see our EC2 instance has been created. And if you look carefully over here, then here the name of the instance is stage. So that's the name of the instance which we wanted to have. Moving to the next topic where we are going to supply the same variable using the command line. So here, first of all, I'll explain how we can achieve that. So first of all, we need to create the main.tf file. And the file is pretty much same. We are going to create it a provider, and then we are going to create a resource, that is our EC2. And here we are going to declare a variable, that is var.instance_type. So that's our variable, and it will hold the value t2.micro. Okay. Then secondly, we are going to create a variable.tf file, and this variable.tf file will be empty. It will only have the variable name inside it. Okay. And third thing, since we are going to perform this on a command line, so we need to supply some value at our command line. So the command, like for example, terraform apply. So here we need to supply the variable name along with its value. So how we are going to do that? So first of all, we need to write the command terraform apply followed by -var, and then you need to supply actual variable name, that is instance_type, and followed by its actual value t2.micro. To start with, first of all, we are going to create a main.tf file. So I'll just copy the content from here. I'll go back to my terminal. I'll open in the VI mode, main.tf. I'll paste the content. I'll save and quit. I'll create one more file, that is variable.tf. And I'll also paste the content from here, and inside that file I'll save and quit. Now we are having main.tf and variable.tf in place, and we can verify using the ls command, and yeah, both files are there. Now we need to run those three commands, and for that we need to change a little bit. So first of all, we are going to run terraform init command. After that, we are going to run terraform plan command. But remember, we need to supply the variable name. So the keyword we need to first put is -var. After that, we need to assign the instance type, the variable name, along with its value. Okay. So I'm just going to run all these three commands, and I'm just going to fast forward this clip. So I'll be back once everything is ready. Now I'm done with all the three commands, so we can go back to our AWS console, and I can refresh the page over here. And here you can see our EC2 instance has been provisioned. So this is how you pass a command line argument, and you can pass a variable into your Terraform configuration. In today's session, we are going to discuss about Terraform locals. Terraform locals is a very important concept, and it comes very handy when you are working with a relatively very large Terraform files. To understand this concept, I have taken a sample Terraform file code snippet over here. And here, if you look carefully, I'm trying to define two resources. One is AWS VPC resource, and another one is AWS subnet resource. And here I have created the tags for each resource, and each tag starts with the name staging, because I'm using this Terraform file for staging environment. That's why I have kept the tag name starting with staging. But let's suppose if you want to use the same or similar Terraform file in the production environment, then what you need to do? You need to manually go into the Terraform file, and you need to update these values from staging to production, because that will be more suitable from production environment perspective. But I don't think it's a good practice to go inside your Terraform file and manually update all the tag name one by one. So for that purpose, we have a concept of Terraform locals, and you can declare a local variable inside your Terraform file. The main benefit of using the locals variable over here in the Terraform file is you need to declare variable at one place. And once you declare or modify that variable, then it is automatically going to affect your complete Terraform where you have used that Terraform variable. So here you can see at the top, we have defined a variable like staging environment, and we have assigned the value staging. Okay. And throughout the Terraform file, we are using the same variable like in the AWS VPC and AWS subnet. So if we are going to change or modify this name staging to staging 1 or staging 2 or staging 3, then we don't need to manually go inside each resource tag and update the value. We just need to update the value at one place, that is inside our local variable. Before we proceed, if you haven't seen my previous session on Terraform variables, where I have explained what is like Terraform variable, string, number, boolean, list map, and how to use variable tfvar files and command line variable. So please go back and check those previous session if you are just getting started with Terraform and you want to learn more about Terraform variable. So those will be a really good session before you jump into Terraform locals. All right, let's see some demo. And this is my main.terraform file which I have created. And here, if you'll see carefully, here I'm just trying to create an AWS instance, and that instance is EC2 instance over here. If you look carefully, so this is the definition, or this is the tag which I'm going to use for EC2, and the instance type which I'm trying to use is T2 micro. Okay, and apart from that, here I'm providing a provider tag that is for AWS, which we need to mention because we are going to perform this demo on AWS. And apart from that, there are a couple of more tags, that is VPC and AWS subnet. In the next upcoming session, I'll explain what is AWS VPC and AWS subnet. But in the meantime, just try to remember we have created multiple tags over here because we are doing the demo for locals. So that's why we are just concerned about these tag names. And each tag names over here is starting with the name staging. Same here. Same for subnet and same for instance. Okay, so we will try to improve this Terraform file using the Terraform locals. The first step would be to create a local variable, and for that we are gonna create one tag that is locals, and in that you can define a variable, and variable name you can keep whatever of your choice. So I'm just gonna keep the variable name as staging environment, and you can assign some value to it. So the value name can be let's say staging, and after that we need to use that variable inside our different tags, that is VPC, subnet and instance. So for that, how you need to do is just remove this staging tag over here, put some $sign over here, and after that curly braces, and then you need to type in the value over here, that is local dot, and after that you need to use your variable name. So the variable name we have defined over here is staging environment. So just use that variable name over here and you're done. So just copy the same variable name from here and replace here as well as here at line number 35. Okay, so now you can see we have improved our Terraform scripting code. So here we have declared only one variable, and now we are using the same variable throughout a different resource block. So in case if you want to change this name to staging 1 or staging 2 or staging 3, then you don't need to manually go for each tag name and update the value. You can just simply come over here in the locals and update the value, and it will just update throughout your Terraform file. Before we apply our Terraform configuration, I just wanted to show you my Terraform, my AWS dashboard, so that you can see like I am not running any previous EC2 instance here. So here you can see instances are 0 and I don't have any previously created VPC. So you can just check that one also. And here you can see there is a one VPC, but I don't think I have created. It's the default provided by the AWS. And here you can see the list. There is a one VPC running, but the name is empty. And this is like something which we get by default from AWS. Okay, and similarly for subnet also we can check. Yeah, I'll just click on subnet over here, and here everything has been created previously, so I haven't created this subnet. Yeah, so let's go back to my Visual Studio and run some Terraform apply command. Before we run Terraform apply command, there are a few commands which we need to run, and the first command is Terraform init. And once you run the Terraform init command, it is going to download all the dependency for AWS environment. Now I have run the Terraform init command, so I'll clear the screen. The next command which you need to run is Terraform plan. And once you run the terraform plan command, then you can see all the variables which we have declared will be replaced with its actual value. So in the tag name, if you look carefully here, so here the variable name has been replaced with its actual value, that is staging. So now you can see the staging VPC tag over here. So this is how we create a local variable, and it is going to replace those variable name with its actual value. So now I have run the terraform plan command, and it is going to add 3 resources because we are going to create VPC, subnet, and EC2 machine. Okay, I'll clear the console over here, and the next command which I'm going to run is terraform apply. And you need to supply value yes. Alright, so now our terraform apply command has just finished. Let's go back to AWS dashboard and verify our resources. Now I'm on AWS console, and first of all, I'm just gonna verify my EC2 instance. So I just click on EC2. And here you can see one instance is running. So just click on that one instance. And here you can see our EC2 machine name, that is staging Terraform EC2. And if you go back to our Terraform file, then that's the name which we have assigned. Okay, so here that is our EC2 instance which is running on our AWS console, and the name is something over here, Terraform EC2. But before that, we have used the variable name that is staging. Okay, so I just wanted to recheck that thing. Okay, so that is our EC2 instance. Next thing which we need to verify is our VPC. So click on VPC. And here you can see 2 VPCs are running. One is by default provided by Amazon, and the second one which we have just started. And here you can see the VPC with the name staging VPC tag. And if you go back to our Terraform file, then you can verify the same resource name which we have given inside our tag. So that is VPC tag, and it is it is prefixed with the name staging. Okay, so that is our VPC instance. And the next thing which we need to check is subnet. So click on subnet, and it should pop up over here. Okay, so here it is. So previously by default we have seen 3 subnet, but here is the 4th one which we have just provisioned, and that is staging subnet tag, and that is also coming from here. It should be over here, subnet tag. And lastly, once you're done with everything, then we can destroy all the resources, because I'm just using it for demo purpose, so I just don't want to keep it running. So I'm just gonna run the command terraform destroy, and it is going to destroy all the resources which we have created using subnet, VPC, and EC2 instance. I hope you liked today's session on Terraform locals. In the next session, we are going to look about Terraform output values. And in today's session, we are going to see Terraform output values. First, we are going to see what is Terraform output values and what's the concept behind it. And secondly, we are going to perform an actual demo on our AWS console. Now the question comes, what is Terraform output values? So if you are previously familiar with any programming language, then you might know like how to print any message on a console. So let's take an example with a Python. So if you want to print a hello message on a Python, then you are going to write like print, and in the parenthesis, you are going to write your message. So it is going to be printed on your console. And similarly, if you have worked with Java, then you can just write down system.out.println and the message inside it. And this message will be printed on your console. In Terraform, we pretty much use the same concept, and we call it as a output values. So here in the Terraform file, you're going to define your output values, and that could be defined using the keyword output, and then you need to assign some name to it. So here I'm assigning the name my console output. You can see over here, I can highlight it here also. So this is the name of my output values, that is my console output, and you can put any message inside the value. Okay, so once you apply this configuration, that means Terraform apply. Once you run the Terraform apply command, then it is going to print this message onto your console. So this message like hello, this is output. So this message you will get once you run the Terraform apply command. Before we jump to the demo, if you haven't seen my previous session where I have explained what is Terraform and how to set up Terraform on a Google Cloud as well as AWS, And after that, I have explained like what is Terraform variables and what is variable.tf, tfvar and command line variables, and also the Terraform locals. So please go and check those sessions. Those are really useful to understand Terraform. To start the demo, on the screen you can see on the right hand side, this is my guide which I have prepared. And in this guide, I have mentioned all the codes which I'm going to use inside my Terraform file. So feel free to copy that code if you're trying to learn the Terraform output values. And on the left hand side, this is my Visual Studio Code where I have written my Terraform file. Okay, so I'll put this link into the description section, so feel free to use it. Okay, so to start with, the objective of this today's session is we need to perform the demo for output values. So this is the output value which we want to print on our terminal. Okay, this web message is pretty simple. Hello, this is output. This is the sample message which we want to print. But before we actually run those apply Terraform plan command, first of all, let's understand this main.terraform file. So here, first of all, the first section is provider. Since I'm performing this demo on AWS, that's why I have used provider AWS. Secondly, I'm going to start an EC2 machine and virtual machine on my AWS instance. That's why I have taken an AWS instance as a resource and the machine ID, because we need to mention a machine ID that you can copy it from AWS console. And if you don't know, then please check my part 1 where I have shown like how to copy this machine ID. And the instance type which I am provisioning is T2 micro because we just want to use this for our demo purpose, not for production use. That's why I'm using very less CPU over here. And the third thing, the output value. So this is how we declare an output variable or output value inside our Terraform file. So first of all, you need to use keyword output. After that, you can assign any name. This can be a meaningful name for your output values, but keep some suitable name. And for the demo purpose, I have kept it as a my console output, but you can change it as per your need. And this is the message which I want to print over here. Okay, so this is my overview of main.terraform file. The first command which I need to run over here is terraform init, and that will download all the AWS dependency onto your local system. And once you're done with the terraform init command, the second command which you need to run is terraform plan. Okay, so my Terraform plan command has just completed, and here you can see on the console, this is the output which I have got. So hello, this is the output. So this is the first output which you got after using the Terraform output values, and you can change it also. And I can type the message, I have changed it. Okay, that's done. Let's rerun the command. I'll clear the terminal over here, Terraform plan. And here you can see the message has been changed. Okay, I'm not going to run my Terraform apply command right now because this is a very simple message which we wanted to print. So Terraform plan command is self-sufficient enough to print these kind of messages. But in the next Terraform file, I'm going to run the Terraform apply command where we are going to print the actual ID of our EC2 instance. For that purpose, we need to run our Terraform apply command so that we can see the actual output. Okay, but this is how you print a message on the console of our Terraform. Here you can assume this as a hello world of our Terraform. Moving further, let's update this Terraform file, and instead of printing some static messages, we want to print some dynamic values. And the what dynamic value which I'm talking over here is the public IP address of my EC2 machine. So as you know, we are trying to start an EC2 machine on AWS. So once an EC2 machine starts on AWS machine, then it gets an public IP address. So we want to print that public IP address using this output values. Okay. So if you move into the guide, there is a section like how to print public IP of AWS instance. So for that, what you need to do is you need to update your output values with this. So what you need to mention AWS instance, first of all, the keyword, because if here you can see on the studio on my left hand side of my terminal. So here, this is the AWS instance. That's the resource. So you need to mention the exact same name over here. After that, you need to mention the name of your resource, that is EC2 underscore example. Because I have taken the name EC2 example. You might take some other name. So just replace that name over here. And after that, you need to put public IP. That's the keyword which you need to mention so that you can get the public IP address of your EC2 instance. Okay, I'm gonna copy this line, this value line from here, from my guide, and I'm just gonna head over to my main.terraform file. I'm just gonna remove this static line where we were printing hello. So what I'll do, I'll just paste that updated value. Okay, so I'm just gonna save this file, and on the terminal, I'll first of all clear it. Since we have already run the terraform init command, so you don't need to rerun it again. So the next command which you can run is terraform plan. Okay, so as I told you, this is something dynamic which we are trying to print onto our console. But in the previously, we have seen we have printed a static message, and once we want to print a static message, then we can see on our terminal as soon as we run the terraform plan command. But here we are trying to print some dynamic value, that is public IP address of our EC2 machine. And since we are running the terraform plan command, so terraform plan command doesn't provision or doesn't start EC2 instance on AWS. That's why this is like known after apply. Here you can see we are not getting any public IP address because terraform plan command doesn't actually start an EC2 instance on our AWS console. So that's why we are getting known after apply. So the next thing which you need to do is you need to clear this terminal, and the command which you need to run is terraform apply. It should be like this, terraform apply. So it should take a minute or so, and yeah, we will get the public IP address after that. You need to type in the value yes over here. Okay, so now my EC2 machine has been started, and here you can see the output, my console output, and the IP address which I am getting over here is 18.195.170.33. So that's the actual public IP address of my EC2 machine. And now our EC2 machine has been started on my AWS. Let's head over to our AWS console and see whether this machine has been started or not. So here on this browser, you can see this is my AWS account, and yeah, I'll increase the size of this screen, and we can just click on EC2 over here, and here you can see one instance is running. So just click on it, and here you can see this is the EC2 instance which I have just started, and the name is Terraform EC2, and that you can check from here also. So that's the same name tag which we have given over here. And also you can verify the attributes, and so if you scroll it horizontally, so this is the public IP address, if you can see 18.195.170.33. so that's the same IP address we are getting over here. So I'll keep it over here, and you can see it over here. Probably this font is too small for you, so I can increase the size of the screen so that you can see. So now you can see the public IP address over here, that is 18.195.170.33, and that's the same IP address we got over here as a console on our output values, that is on our terminal. Alright, so now we can destroy our EC2 instances. We have seen like how to print our public IP using the output values. So I'll just minimize this browser, and I'll go back to my terminal. I'll clear the screen, and the command which I'm going to run is terraform destroy, and it is going to destroy my EC2 instance. So I'll be back once it's done. As you can see, destroy complete. That means our EC2 instance has been destroyed, and we can verify by going back to our AWS console and just refresh this. And here you can see there is no EC2 instance which is running right now. Okay, so now we know like how to use our output values, and here this is the guide where I have mentioned all those things, so you can just check this guide. There's also one more important attribute actually, that's called sensitive, and once you put this sensitive flag to true over here, so it will not print any sensitive information onto your terminal. So let's say if you don't want to expose your public IP address or any password or any host name from your staging or production environment, then you can use this attribute along with your output values. So it will just save you from printing those sensitive information onto the terminal. Okay, so how to do that? What I'll do is I'll just copy this sensitive equals true over here, and I'll just increase this size, and I'll just hit enter. And after that, what you need to do is I'll just remove this value. I'll just gonna print some static values. Hello, this is sensitive. Okay. I just don't want to provision my EC2 instance again and again, but we just wanted to see the sensitive flag. Okay. So I'll just do clear the console, and since I have already run the Terraform init command, so I don't need to run it. The command which I'm gonna run is Terraform plan, because I'm printing the static value, so I don't need to run Terraform apply actually. So I'm just gonna run Terraform plan. And here you can see, once you run the Terraform plan command with the sensitive equals true into your output values, then it is not going to output any values, or it is not going to print any values onto your console. So with this feature, you can pretty much save your sensitive information from getting printed onto your console. Along with this today's session, I'm just going to share one guide with you, and you can find all the command and the instructions which we are going to use throughout this session into this guide. So I'll put the link of this guide into the description section, so feel free to use it. Let's first start with the count. But before we begin with the count, let's understand some concept. These for, count, and for each loop work on a list variable or either map variable, because a list or map contains more than one values. So as you know, whenever you are working with the for each loop or count in any programming language, then you are working with the collections, and the collection which we are talking about is either list, map, or sets. So here you can see this is the variable which we have defined, and this variable is of type list, and that is string. So here the variable name which I have kept it over here is user underscore names. The description which I have given is I am usernames. In Terraform you can put any meaningful name over here into the description section. And the type is list, and that is of type string. And the three values which I have assigned over here, that is user1, user2, and user3. So when you are working with the count in Terraform, first of all you need to define the variable, and this the variable which we have defined is of type of list containing 3 users. And if you see this diagram over here, then this is how it is going to store the values. So as you know, the index position starts with the 0. So in the 0 you are going to store user1, in 1 you are going to store user2, and in 2 you are going to store user3. This is just a normal thing. Okay. So the next thing, how we are going to use the count variable. So here I'm going to create an IAM user in AWS, and in that resource we are going to first of all define the count. And here you can see we are going to use the length function, and in the length function we are going to pass the variable user underscore name. So if you look carefully over here, this is the keyword which we have used, that is var dot followed by your username variable. So if you look carefully, the username variable which we are going to use over here is the same which we have defined above. So this is the username. Okay. So first we have defined the variable, and then we are going to create a resource, that is IAM user in AWS. And inside that AWS user, we are first of all going to count how many number of users are there, and then we are going to use this feature of Terraform where we are going to put count.index, and that will just iterate over the values, that is user1, user2, and user3, and it is going to create 3 IAM user inside our AWS. So as I shown you previously in the diagram, like user the index position 0, 1, and 2. So this count.index will iterate over those index position. That will start with 0, 1, and 2, and it will put those values over here. So once this configuration executes, then it is going to create 3 AWS users inside our AWS console. This is my Terraform configuration for the demo of count. And first of all, we are going to define the provider. Yeah, because we are going to work on AWS, that's why we have kept the provider as AWS. If you are going to work on Google Cloud, then just you need to substitute the value over here with the Google Cloud or Azure. But since we are working with the AWS, so that's why I have used AWS. Region, you need to select it based on your location, and you can just keep like if you are in Asia region or America region, then please choose suitable region which is close to you. Access key and secret key. If you don't know how to use those access key and secret key and from where to get it, then please see the part 1 of this Terraform series where I have shown like how to get the access key and secret key. Anyway, I'll put that link in the description section of this video so you can follow that one also. Secondly, we are going to create an AWS instance, and that is going to be our virtual machine. And the instance type is t2.micro because we are just starting it for demo purpose. That's why I just kept a very small machine. And the tag name which we are going to assign is Terraform EC2. It is just a user-defined tag name. You can keep anything of your choice. And this is the interesting part, the IAM user, because we are going to create a variable and then we are going to iterate that variable so that we can use the count. So as I explained previously in the guide, so this is the variable which I have declared over here, that is user names along with 3 value, user1, user2 and user3. And this is how I'm going to create an IAM user using the count. Let's move the terminal a little bit up. And the first command which we are going to run is terraform init. This command is going to download all the required dependency which is needed to communicate with AWS. And now we have completed the terraform init command. I'll clear the screen. The second command which I'm going to run is terraform plan. Terraform plan command, what it does, it actually tells you like how many resources it is going to add. So here you can see it is telling us like 4 resources to add. So that means we are going to create 3 users, user 1, user 2, user 3, and the 4th resource is our AWS instance, that is t2.micro. So these are the 4 resources which we are going to create. But Terraform plan does not create those resources into AWS. It just tells you, it's kind of a dry run. So it just tells you like how many resources it is going to add, it is going to change, and it is going to destroy. Okay, so now we have successfully run the terraform plan command. The next command which we are going to run is terraform apply. Terraform apply. And this command is going to create our resources. And it will ask, do you want to perform this action? Just simply type yes and hit enter. And now we have completed the terraform apply command successfully. And it tells you like 4 resources has been added. Let's go back to our AWS console. And here you can see this is my AWS dashboard, and I am into the section IAM dashboard because we have created 3 IAM users, and we just wanted to verify whether those 3 users has been created or not. So before running the terraform apply command, I had a 0 user. So now I have successfully executed my terraform apply command. So I'm just going to refresh this page, and here you can see 3 users, and we can verify those 3 users also. So user 1, user 2 and user 3. So these are the 3 resources which we have created using our Terraform configuration. We just wanted to verify our 4th resource, that is our EC2 instance, and just type and click on here. And here you can see one instance is running. Just click here, and here you can see this is our 4th resource which we wanted to verify, that is Terraform EC2. And if you go back to our Terraform configuration, so here you can verify the tag name also, that is Terraform EC2. Okay, so this is how we are going to create our IAM user using the count of Terraform. Now we have seen the count example and the demo. I'm just going to destroy all the resources, and I'll just clear it first, and the command for that is terraform destroy. So it will take some time, so I'll be back when terraform destroy command has been completed. As you can see, now we have destroyed all the 4 resources. Let's head back to our guide. And now we have seen loop with the count in Terraform. The next topic which we are going to discuss is the for each loop. So click over here. And again, I'm going to take the same example. And in this example, again, I'm going to create the same 3 users, user 1, user 2 and user 3. The only thing which is going to change over here is the resources of AWS IAM user. So previously we have used count over here, but this time we are going to use for each. So here you can see we have to mention the keyword for each along with the variable keyword and our username variable. So we need to use this user underscore names variable which we have created over here, as you can see over here. And after that, you just simply need to type the each dot value. So this each dot value is going to iterate over each value of user, that is user 1, user 2 and user 3. And it is going to put it over here under the name. So this for each loop is little bit simpler than the count. but this is how we are going to perform it. So what you need to do over here is you just simply need to copy this for each part of this Terraform script, and here is the complete Terraform script if you wanna see over here. But I'll go back to my Visual Studio, and here I'm just gonna remove this resource where we have used count. I'm just gonna remove it, and I'm just gonna paste the for each loop, and I'm just gonna save it. Okay. All right. So I'll increase the terminal size over here. I'll clear the screen, and now we have already run the Terraform init command, so you don't need to run it again and again. The next command I'm gonna run is Terraform plan, just to verify whether there is any problem or there is any syntactical mistake with my this Terraform configuration. Oh, I forgot to mention that one important concept regarding the for each loop. You cannot use list over here. So this is how a Terraform plan command really helps you to identify the issues before running the Terraform apply command. So here with the for each loop, you cannot use list. You need to use set or map. You can see the same instruction over here in the guide. I have already mentioned, I think this is the set you need to use. You cannot use list over here. So that's the thing you need to change. And let's go back to my Visual Studio, and I'll clear the screen again, and I'm just gonna run the Terraform plan command again. And now we are able to execute it successfully, and again it is showing 4 to add. So now what I'm gonna do, I'm just gonna run the Terraform plan command Terraform apply command. So I'm just gonna run Terraform apply command. Alright, so now we have successfully completed our Terraform apply command, and it says 4 resource has been added. So let's go back to our AWS console. Just refresh this page, and here you can see 3 users has been created, and these are the 3 users, 1, 2 and 3. And similarly we can verify the EC2 instance also. And here you can see our one EC2 instance is ready. Yeah, it's up and running. So now we have seen like how to use the for each inside your Terraform configuration, and remember to use set instead of list. Either you can use set or map for to work with the for each loop inside your Terraform configuration. So I'll just destroy this Terraform configuration, and I'll be back when the Terraform destroy has finished. Now my Terraform destroy has just finished. I'll clear the screen over here. Let's head back to our guide, and the next topic which we are going to discuss over here is the for loop. So here in the for loop, again I'm going to take the same variable example where I'm going to create the 3 users, user 1, user 2 and user 3. But this time I'm not gonna create our actual AWS user. Instead, I'm just going to use the output functionality of Terraform configuration. If you haven't checked what output variables are in Terraform, then please go and check. I'll put the card over here so that you can just check how to create output variables in Terraform. So instead of applying and running those Terraform configuration, we are just gonna see how to print those values on to our console. Okay, so here I'm just going to copy this section because we have already created the variable inside my Terraform file. So I'll go back to my Terraform configuration file, and here I'm just going to remove this resource and paste this one over here, this output variable. So it is just simply going to print user 1, user 2 and user 3. So here I'm just going to use the for loop instead of for each loop. Okay. So what I'm gonna do, I'm just simply gonna save this file, and then I'm gonna run the Terraform plan command. I'll just increase the size of this terminal. But you already know the drill, like how to run the Terraform plan and Terraform apply command if you actually want to perform this step onto AWS. But instead, I'm just simply gonna run the Terraform plan command. And here you can see this is the output which I got back. That changes to the output is print name, and this is the output variable name which I have taken, print the names. And here you can see the output user 1, user 2 and user 3. So I just wanted to show you this concept of for loop also instead of running it on an actual AWS, because we have seen the previous count and for each by implementing on AWS. But this is how you are going to implement the for loop. The loop is pretty much simple. This is the variable name that is user underscore name, and this is how you create the for loop inside your Terraform configuration. And in today's session, we are going to talk about Terraform State. So the topics for today's discussion is what is Terraform State and how to use Terraform State inside your Terraform projects. Apart from that, we are also going to look how to manage your Terraform State and what are the best practices. And along with that, we are also going to look on like what is Terraform local state and what is Terraform remote state. And to demonstrate that, we are going to see a demo where we are going to push a local Terraform state into AWS S3 bucket. If you are new to this channel and if you are just getting started with the Terraform, then I'll put the link of my previous session which I have uploaded for Terraform into the description section. So feel free to go through those sessions so that you can understand those concepts really well. Alright, let's switch over to my desktop. The first question comes in my mind is like how the Terraform state file is created, or do we need to create a Terraform state file? So to answer that, like you can see in this diagram on the left hand side, we have a Terraform plan command. And apart from that, you can also see there are Terraform init and Terraform apply command, which we generally use. So Terraform state file is not created by us, but instead it is created by Terraform. So whenever you execute Terraform plan on the left hand side, you can see or Terraform apply command, then this Terraform state file is created. So in the middle, you can see in the red color, this is my Terraform state file. And it contains all the resource information in the form of metadata. And this Terraform state file is created onto your local workspace. So it is created by Terraform, not by you. And it is created along with your project onto your local workspace. And after that, all the changes, if you have executed Terraform apply command, then first it will create a Terraform state file. And then after it will apply all the changes to your AWS infrastructure or a Google Cloud infrastructure in case you are using Google, or in case if you are using Azure, then it will apply it to Azure. So this is the typical flow of our Terraform apply or Terraform plan command. And whenever you execute these commands, then this Terraform state file is created by Terraform, and it just happens like in the backend. You don't see it, but we can actually see the Terraform state file. Now we know the basics of Terraform state file. Let's see a little demo where we are going to create a Terraform state file. So this is my workspace, and I'll put the link of this workspace into the description section. It's a GitHub project, so I'll put the GitHub link. So this is my Terraform state file project which I have created. It's a very small one. So here I have defined the provider with the reason, access key and secret key. And this is my variable where I'm storing the access key and secret key. But this is my main Terraform file where I'm just creating an EC2 instance of T2 micro onto my AWS account. So this is the project Terraform remote state, and here I have only a couple of files, main.tf and variable.tf. So in this project, this is a fresh project. I haven't done anything yet. So once I'll issue the Terraform plan or Terraform apply command, then we are going to create a Terraform state file. Not we, but Terraform is going to create a Terraform state file. So that's the first step, that how the Terraform state file is created. Let's open the terminal from here. Go to new terminal, and I'll just extend it over here. I'll clear the screen, and let's check the directory. So we should go into Terraform remote state project. I'll clear the screen, and I'll also issue the command export ps1 so that I can reduce the length of this command line. It's too annoying sometimes. Let's put $. Okay, clear. So now this is my terminal and this is my project, and I'm inside the directory Terraform remote state. So the first command which I'm going to run is Terraform init. You might have noticed that once I issued the Terraform init command, this command, it has downloaded some dependencies. So if you look into the Terraform file, this is our provider, and the provider is AWS. So whenever we issue Terraform init command, then it downloads all the dependency which is needed for AWS. So here it has created a directory .terraform, and inside that you will find a file which has been downloaded by Terraform init command. So that's the first step once we issue the Terraform init command. But still we haven't created, or Terraform haven't created a Terraform state file. So I'll clear the screen over here, and the next command which we are going to issue is Terraform plan command. Okay, so Terraform plan command says it is going to create or add one resource. So after that, we are going to create the resource using the next command, that is terraform apply. Type yes. Okay, so now Terraform apply command has just finished and we have successfully started an EC2 instance. And now, where is the Terraform state file? So here you can see this is the Terraform state file which has been created. So once you issue your final Terraform apply command, then this Terraform state file is being created. And this is done by Terraform. It is not that we are creating this Terraform state file, but it is just by default created by Terraform. And it contains all the metadata information which is which we have specified into the main.tf file. So this is the information related to the current main.tf file. So here you can see this is the AMI which we are planning to, or which we are starting to create on AWS, and this is the EC2 which is running on EU Central region. So there are lots of information which is available inside this Terraform state file, and this is just created by Terraform by itself. So this is the Terraform state file over here, and this Terraform state file exists locally onto your Terraform workspace. So that's why this Terraform state file is known as local Terraform state file, because it is just local to you. You have not shared with any of your colleague or any of your team member. So that's why we call this Terraform state file as a local Terraform state file. So what happens is, like, whenever you execute any command onto your Terraform project, so I'll clear the screen. So let's say if I execute terraform destroy command, then again it is going to update the Terraform state file, because Terraform state file is just like a recorder or a black box for Terraform, where it records all the steps which we are going to perform. So the first thing which we need to do is to create a Terraform state file is you need to execute Terraform apply command. So once you execute the Terraform apply command, this Terraform state file will be created if this is your fresh project. So this was my first fresh project. That's why I have it has created a Terraform TF state file. Now after that, after creation of the Terraform state file, whenever I execute any new command, so let's say I have executed Terraform destroy command, so it is simply gonna update the Terraform state file, because it is just updating the meta information related to my main.tf file. So that's why for each step, it's act as a recorder. So it's just like a black box for this Terraform project, and it's gonna keep on recording whatever happening inside my Terraform project. So if you're updating, deleting, or destroying anything, then it will just keep the information into the Terraform state file. And also it is going to apply on actual AWS cloud infrastructure also. Alright, so now I have destroyed my Terraform resource or EC2 resource, which was running on on AWS. So let's see the Terraform state file once again and verify our changes. So here, this is my Terraform state file, and as you can see, it has shrunken quite a lot. Now it contains very limited information. So previously, before issuing the Terraform destroy command, it has a lot of information, because during that time, we were trying to create a EC2 instance onto AWS. But now we have destroyed it. So it has removed all the information related to our EC2 instance, which we have created previously. So now you can say, like, a Terraform state file is updated every time whenever you issue or do any kind of activity. And activity, what it means is like a Terraform apply, Terraform destroy, anything which you do on your resources using Terraform. Alright, so that was the first part where we have seen how to create a Terraform state file and how to create and store that Terraform state file locally onto your workspace. The next part, which we are going to see, like how to store the same file remotely onto S3 bucket. So we are going to create an S3 bucket, and inside that S3 bucket, we are going to store this Terraform state file. And that all we are going to do with the same Terraform script. We are not going to do anything manually. Everything we are going to do, we are going to create the Terraform state file, and we are going to store the Terraform state file onto S3 bucket via Terraform. Alright, so this is my the same main.tf file, and previously I have disabled the remote section of my Terraform script. So where I have mentioned like what is the backend, that is S3. So I'm just going to enable this section, because previously we were only interested in creating a local Terraform state file. So I'm just going to save it, and here there are a couple of things which I would like to mention. So whenever you're trying to store the state file remotely on a S3 bucket, then you need to define the resource into the Terraform main.tf file. So here we have defined the block, that's Terraform, and that block is backend, and it is using the S3 bucket. And then you need to specify the name of the bucket. So this is the bucket which I'll be creating on my AWS account, and this is the key. So this key is little special. So assume this as a directory inside S3 bucket. So how do you store a file inside your computer? So what you do, you just create a directory, and inside that directory you store some file. So similarly, this is the bucket, and inside that bucket we are going to create a key, which we call it, but it's assumed that it's a directory, and inside the directory we are just going to store the Terraform state file. And apart from that, we also need to mention the reason. So in which region you are working. So in which region you are going to create this S3 bucket. So again, we are just going to create it into the same region, that is EU Central 1. All right, so now we have enabled this. Just save it, and also take a look at this Terraform state file. I think it should be, yeah, because we have previously destroyed all the resources which we have created. That's why this file is quite shrunken a lot. One more thing, we need to create this S3 bucket before running this Terraform apply command, or before running or executing this main.tf file. So this is I can show you my AWS account. So this is my AWS account, and here I have already created an S3 bucket. So the name should be same, otherwise you might get into some error. And the creation of S3 bucket is pretty simple. You can simply go here and type S3, and it will give you an option for S3. And then once you click on this S3, then it will redirect you to this home page. And here you can just click on this orange button, that is create bucket, and it will help you to create a bucket. So this is how I have already created an S3 bucket. And after that, this is my Terraform project. I think, yeah, this is the one. So now I'll clear the screen over here, and I'm simply gonna execute the command terraform apply. It's giving me an error, backend initialization required, run terraform init. So I'm just gonna run the terraform init command once again. So terraform init, because we have previously destroyed all the resources, that's why it is asking me to rerun the terraform init command. Okay, then I can run the terraform plan command also, just to see. Okay, it is going to create a one or add one resource. That's fine. I'll clear the screen, and then I'm just gonna run the terraform apply command. Type yes. Now my terraform apply command has just finished, and we can first see the terraform state file, and I'll just reopen it maybe. Okay, sorry, I forgot to mention, yes, we are creating this a remote Terraform state file. That's why it has not updated this local state file. So let's get back to our AWS console over here, and I'm just going to refresh it. Click on this bucket, and here you can see this is the key, this is the directory which I mentioned you earlier. So here, this is the bucket. This is the key. So key is just like a folder inside your bucket, and inside that folder it is going to create a Terraform TF state file. So this is the folder, click on it, and here you will find Terraform state file. So this is the Terraform state file which we have stored remotely onto our S3 bucket. So this is how you're gonna create a remote Terraform state file, where we are gonna save the same Terraform state file. Instead of locally, we are gonna store it remotely. So this is how you create a Terraform remote state file. Now the question comes, like if you are having a Terraform state file locally, then why do you need to store the Terraform state file remote? So consider a scenario, you are working in a company where lots of developers are working on a same Terraform project. And as you know, if you have messed up your Terraform state file, then you are not able to execute any of your command, because your Terraform state file is not properly synced. So if multiple developers are working on the same Terraform file, like in our case, we had created a main.tf file, that is our main.terraform file. So if there are more than one developer is working, then you cannot have a two-state file of Terraform. So you need to have a single copy of a Terraform state file. So that's why you need to store the Terraform state file remotely. And but that means you need to store somewhere. So that's why we use S3 bucket, because AWS has provided a really good support, or Terraform has a really good support for S3 bucket. So this is how you're gonna share this Terraform state file with other fellow developers, so that they are also in sync with the same Terraform state file. Now we have discussed the importance of a Terraform remote state file when we are working with multiple developers, or you're working in a team. Then next question comes, like, if you have taken some days off and you are not working on your project, then how you're gonna pull the latest changes which has happened in your absence? And for that, Terraform provides one more feature, that is Terraform State pull command. And with the help of this pull command, you can pull all the latest changes which has happened in your absence, and you can get those information onto your local workspace of your Terraform. So Terraform State pull command is a very similar command to the svn pull or git pull command. So with the help of svn pull or git pull command, you bring all the latest changes which has been done by other teams onto your local system, so that your code is up to date. So similarly, Terraform State pull command will help you to update your local Terraform state information. So let's head back to desktop again and see how to use that command. This is my workspace, and the command which I'm going to run is Terraform State pull. And remember, we have already started our EC2 instance, and we have already stored the state file remotely. So here you can see it has pulled all the information related to Terraform state file which we have stored remotely. So that contains all the information about our EC2 instance, and that you can verify from here. If you look here, then this is the AMI, and this is the EC2 instance that is running on a EU Central, and you can copy the AMI just in case. I'll just scroll it down again over here, copy it from here, go to your main.tf file and Control F and find it. So here you can see. So this is how you can pull the information back which has been stored on a Terraform state file using the Terraform State pull command. And similarly, if you follow this guide, which I'll also share into the description section, so here you will find a Terraform State push command also. But this Terraform State push command is really not a good practice, because you might destroy some of the other team member changes, because Terraform State push gonna update the Terraform state file, and once you update the Terraform state file without knowing other team member changes or without knowing the gravity of the situation, then it might destroy quite a lot of things. So Terraform provides a Terraform State push command, but it is not recommended to use it. So, but just to know you, that Terraform State push command is also existing there, so you can use the Terraform State push command also. So this is the guide. So whatever I have discussed during this session is available onto this guide, so you can follow this guide whenever you feel. So in this session, we are going to discuss all these three provisioner along with the demo. Apart from these three provisioner, there are some vendor specific provisioner, that is Chef, Habitat, Puppet, and Salt Masterless. And these vendor specific provisioner requires a little bit of spatial setup where you have Chef and Puppet running onto your system. But those are the topics for some future discussion. But in today's session, we are just going to focus on these three provisioners. Along with the today's session, I'm just going to share this guide with you. And this guide will contain all the examples which we are going to cover into this session. So let's take an example like a file provisioner. So here you will find all the code snippet for the Terraform script which we are going to use for the demo. And similarly, you can use the same guide for local as well as the remote exe provisioners here. So here, the only thing which you need to change over here is the access key and the secret key, because that differs for each AWS account. So I'll put the link of this guide into the description section, so feel free to use it. All right, let's start with our first provisioner, that is our file provisioner. And as you can see, the purpose of the file provisioner is to copy a file from our local development machine, that we call it as a source, to the destination. And the destination is going to be our cloud. So here I'm using the AWS EC2 instance, that is remote machine, and that is going to be my final destination. And here I'm trying to copy the file testfile.txt. So this is the file which I want to copy. So basically, file provisioner help you to transfer a file from a source to the destination. And here at the bottom, you can see this is the code snippet for our file provisioner. So it starts with the keyword provisioner, and then you need to mention like which kind of a provisioner it is. So here I'm using the file provisioner. That's why I have mentioned the keyword as a file. And then we need to mention the source. So source here, it contains my local directory or the local hard disk where I have stored my file, that is testfile.txt. So this is the location where I have stored my file. And this is the destination. So destination is going to be our AWS EC2 instance. So what it's going to do, it's going to copy the testfile.txt to this path, home Ubuntu testfile.txt. So this is the code snippet which we are going to use for our file provisioner. And here is my Terraform script for file provisioner. To start with the first block, this is my provider block, that is AWS. And here we need to mention the reason, access key, and the secret key. Since I'm working in the Europe region, that's why I have used EU Central. Along with that, you need to mention the access key and the secret key. And if you don't know how to fetch the access key and the secret key, then please do follow my part 1 where I have shown like how to fetch all those information to work with the AWS. Along with that, we need to mention the resource block. And as you know, in the previous slide, I have mentioned like we need to start a virtual machine, and that machine is going to be our EC2 instance. So that's why we need to create this resource block, which will start a virtual machine running inside our AWS cloud. So here we need to mention some details, and as I have mentioned, everything I have explained like how to start your EC2 instance in the part 1. So if you don't know anything or if you feel like it is too complicated, then I do recommend to follow the part 1. But anyway, you need to mention the AMI, the machine ID, which we are going to start. Since I'm starting the Ubuntu machine, that's why I have used the AMI of that Ubuntu machine. And then secondly, you need to mention the CPU or the machine type. So since this is an example, that's why I have used the T2.micro. If you are using it for some other purpose, then you can use some powerful CPUs. And then we need to mention the key for SSH. I'll explain when we are going to perform the demo, and when we are going to move to the AWS, then we are going to create this key also. And for the same key, we need to create a security group also. That's why I have created this security group. I'm going to show you that one also. And the main thing, that is provisioner, that is file. And this is my provisioner where I have mentioned the source and the destination. So this is the source where my file is located, and this is the destination where I'm going to copy my file. And this destination is going to be my EC2 machine. Apart from the provisioner, we need to mention the connection block also in the resource block. Just if you'll see carefully, then I'm still inside my resource block. So here I need to mention the connection block also. And if you have worked with the Linux server, then you need to copy the file securely. That's why you need to use SSH. And that's why we are using the connection block over here, so that we can copy our file securely. And this provisioner is going to use this connection block to make an SSH connection and copy that file securely. Moving to the next block, that is AWS security group. So we need to define some ingress and egress resources over here. So egress resource is going to be the default one where you only need to mention the CIDR. You can read about the CIDR block on the wiki or Google it. It's very simple, but we don't have to deep dive into those details. But there is an ingress block which you need to pay a little bit more attention. Here you can see the port is 22, and here we are using the protocol as a TCP. So if you have worked with the Linux servers, then we need to SSH, and when we want to SSH into, then we are going to use the port that is 22. So that's why we need to define an inbound port that is 22, which needs to be open on our EC2 machine. That's why we need to create this egress resource or egress block here inside our Terraform script, which is going to open that port, and we can securely copy our file, this testfile.txt, to our remote machine. And the last block is we need to define the AWS key pair. And as you know, we have created an AWS key, and we have used the same reference of AWS key from here into our resource block. You can see over here also. So this is the same AWS key we are going to use. So here you need to mention the public key. We are going to create a key pair where we are going to create a private as well as the public key. But here we need to use only the public key, and private key we are going to keep it on our local development machine. So I'll show you how to create those key pair. But just to keep in mind, we need to create the key pair, and we need to put the public key, only the public part over here, public key part. The next thing which we need to do is we need to create an AWS key pair, and we are going to put the name AWS_key. So if you head over to my blog post in the Terraform Provisioner, so here I have mentioned the link of how to SSH into AWS EC2 instance. And once you click over here, then it will open this guide where I have shown like how to create a key pair. So you need to use the SSH keys and utility to create our public and private key pair. So simply copy this command from here and go to your terminal. And here you need to simply paste the command and hit enter. By default, it is going to create a SSH key pair at this location, but I don't want to create my key pair at this location. So what I'll do, I'll just mention my own custom path where I want to my key pair file to be. So if you follow along this guide, then you can copy the path, but this path can be different for you because your development machine will be different from mine. So you can use your own local development machine path. So, okay, so I'm just going to paste it over here. But since I have already created this AWS key on my system, so I'm going to simply create one more key, that is AWS underscore key 1, and hit enter. And you don't need to mention any password phrase. So simply keep enter, then again enter. And it is going to create a SSH key chain, or the key pair, that is public as well as the private key. To verify that our key has been generated, go to the location where you have created the keys. And this is the location which I have mentioned. And here you will see we have created key pair. The first is the private key, AWS key underscore key 1. And this is my public key, AWS underscore key 1.pub. And we are going to use this public key inside our Terraform script. And this private key, which doesn't have any kind of extension. So this is the private key which we are going to use for SSH purpose, so that we can log in into our AWS machine once we start our AWS machine. Okay, so what you need to do is you need to open with any editor, and here you will find the content of our public key. So this is the public key which I have generated along with my private key. So you simply need to copy this content, go back to your Terraform script, which should be here. And you simply need to paste that content over here. So this is my Terraform, this is my public key over here. So you just simply need to replace this public key. And that should be the key pair part. And always remember to put the correct key name over here, and always put the correct key name with which we have created the public and the private key. So if you have created a key with the AWS key 1, then please put the same name over here. And apart from that, you just simply need to copy this code of this security group. You can copy as it is. You don't need to change anything over here. So you can just simply copy this egress and ingress resource as it is. It is not going to change for you also, because you are going to again use the same 22 port for SSH into and for TCP also. All right, now we have done all the prerequisites which is needed to perform an example of our file provisioner. So now we need to execute our Terraform script. So the first thing which you need to do is you need to run the command terraform init. And once you run the terraform init command and it completed successfully, then the next command which we are going to run is the terraform plan. And this command is going to tell you like how many resources we are going to add inside our AWS. So here you can see it is going to tell you like we are going to create 3 resources, or it is going to add 3 resources. So the 3 resources which we are talking about is this EC2 instance. Along with that, we need to create a security group, and also we are going to create a key pair. So these 3 resources are going to be added. So that's why this count is 3. Once you successfully run the terraform plan command, the next command which we are going to run is terraform apply. And then you need to simply type yes, I want to apply those changes. All right, here you can see it has applied those 3 changes successfully. Let's head back to our AWS console and see our EC2 instance has been created or not. So click on EC2. And here you can see there is one instance which is running. Click on it. And here we need to click on the instance ID. Click on connect. And this is the command which we are going to use to SSH into our AWS EC2 instance. But before that, we need to remember that we need to change the key permissions also. Since, as you know, we have created AWS key 1, but that I have shown you just for example purpose how you need to create, but still I'm using the AWS key. I'm not using the AWS key 1. I'm still using my AWS key which I have created previously. So before you run or before you create, before you connect to our AWS instance using this SSH command, you need to change the permission. By default, what happens is it might have assigned some additional permission. It might have like a read-write access to other users also. So just simply go and copy this command and execute this command. So you need to go to terminal once again. And here, this is my terminal. And what you need to do is you need to go to the same path. So this is the location where I have created my keys. So I'm just going to use the same path, paste the path. Oh, sorry, I need to remove this key name also. Clear it. And here I can see I have created a AWS key 1. Okay. And this is my public key, AWS key.pub. So these are the 2 keys, but we need to change the permission of our private key. This is the key which we need to change the permission for. So by default, like AWS says, it has a .pem extension, but you don't need to worry about it. You simply need to copy this command, go to your terminal, paste the command over here, and just remove the .pem extension and hit enter. So it will change the permission. And once you change the permission, and then you're going to copy this or you're going to execute this SSH command from here. So simply copy this SSH command and paste it over here into the terminal. And one thing which you need to change over here is we need to remove that .pem extension, because we have created a private file without any extension. So that's why I'm just going to remove that pem extension from here and simply hit enter. If you are doing it for the first time, then it will ask you for do you want to trust this resource? Then you just simply need to type the yes. So once you type the yes and then hit enter, then you will be into your virtual EC2 instance. So here you can see this is my EC2 instance, which is up and running. I'll clear the screen, and here you can see this is my IP, that is of my Ubuntu machine. And same thing you can verify over here also into the EC2 instance. Click here again, go to this instance ID, and here these are my details of my EC2 instance. And you can verify with the private IP4 address also. So the address is 172.31. I will put it over here. So 172.31.5 and 10. So this is the 172.31.5 and 101. Sorry. So this is my EC2 instance which I am able to connect it. The next thing which you need to verify is that we have copied the file successfully or not. So simply type ls, and here you can see the file is testfile.txt, which we have copied. So our Terraform file, Terraform script has executed successfully, and we are able to copy the file, which you can see over here. So this is my source file from here, that is tstfile.txt, and we are able to copy it to our destination directory. So here we can see this is my terminal, and if I can do the ls, so yeah, this is the file, and we can view the content of the file also. So this is my test file, the content of the file is. So this is how we work with the provisioner, that is file provisioner, and by this way you can simply copy the file from your local machine to your destination. Alright, to summarize our first part of provisioner, what we have done so far is we have created our EC2 instance, that is our virtual machine, and that is going to be our destination. So that we have started, and also we have created a public key and a private key. We have used the public key inside our Terraform script, and we have used the private key to SSH into our Terraform, the instance which we have created using Terraform. And also we have seen how the provisioner works and how we can create our first file provisioner. So all the concepts like public key, private key, EC2 instance is going to be the same for other provisioner, that is local and the remote provisioner. And only the provisioner block we are going to change inside our Terraform script. So let's head over and see our next provisioner, that is local. As the name suggests, this is a local exe provisioner. So it is going to work only on your local machine, and that is local development machine. So here on the left hand side, you can see this is my source machine, that is local development machine. And on the right hand side, this is my AWS EC2 instance, which is running on AWS cloud. So the local provisioner only affects your local development machine. So this is the provisioner block which I have written. So here again, you need to mention the provisioner keyword, and then you need to mention the name of provisioner, that is local-exec, the actual provisioner name. And then you need to mention the command which you are going to execute on your local machine. So here the provisioner is pretty simple. You need to mention the bash command or the Unix command. So here I'm just trying to create a file. So the file name is hello.jhook.txt. And the command which I'm going to use is touch. So touch command is pretty simple in the Linux, and it is going to create one empty file, and that is hello.jhook.txt. Here is my Terraform script for local provisioner, and this is the provider, and this is the resource section. And in the resource section, we need to create a provisioner, and we need to put the name. So that is local exec provisioner. And here we need to mention the command which we are going to execute on our local machine. So here I'm going to create a file, that is hello.jhook.txt. So once you create this Terraform script, you simply need to run the command terraform init, and after that you need to run the command terraform plan. And before running the command terraform apply, just see here we don't have anything file named hello.jhook.txt over here. So we don't have that file. So once we execute the terraform apply command, then it is going to create that file over here. So simply run the terraform apply and type yes. And once Terraform apply has completed successfully, here you can see this is the hello-jhook.txt file has been created. It has been created on the local machine. It has nothing to do with the remote instance which we have started. So this is how our local provisioner works with the Terraform. Alright, so till now what we have seen the file provisioner for transferring the file. We have seen the local provisioner for performing some bash script or executing some shell commands on our local development machine. And the next provisioner which we are going to talk about is the remote exec provisioner or a remote provisioner. So as the name suggests, we are going to perform some action on a remote machine running on a cloud. So if we are talking about AWS, then we can use the remote provisioner to perform some or to execute some shell commands on running on our AWS cloud. So in our instance, we will be executing some commands on our EC2 machine, which we have running inside our AWS cloud. And similarly for Google, it will be virtual machine running inside our Google cloud. And we will be executing some command or shell commands using our Terraform remote provisioners. So let's see what this remote provisioners are. Here you can see on the left hand side, this is my local development machine, and on the right hand side, it is my AWS EC2 instance. So here on the local development machine, we will be executing our Terraform script, and below you will find a provisioner script or a provisioner code for Terraform, a remote provisioner. And here the keyword is provisioner again, and the name of the provisioner you need to type in is the remote-exec. That's the name of our remote provisioner. And here there are some commands which we want to execute on our remote machine. So how you need to define is you need to put inline, that is keyword provided by Terraform, and then you need to put some square braces, and inside that you need to put some double quotes, and there you can write some command. So here what I'm doing is I'm just trying to create one hello.txt file in my first command, and then I'm just trying to write some text. So I'm just putting this hello world remote provisioner into hello.txt. So I'm executing two commands using my remote provisioner. So by this way, you can execute multiple commands. So if you want to add further more commands, then you can just put a comma and double quotes, and you can add a new more line with your bash scripts. So this is how you define a remote provisioner. And once we execute this remote provisioner, or once we put this remote provisioner inside our Terraform script, then it is going to execute this or create this file and write some text and put it inside our AWS EC2 instance. So this is how our remote provisioner is gonna work. Here you can see this is my Terraform script for remote provisioner, and as usual we need to define some provider. After that we need to define some resource over here, and again I'm using the same t2.micro, and I'm using the EC2 instance with this AMI. So I'm using the Ubuntu as a base operating system for starting my virtual machine in the same AWS key which we have used in our file provisioner. So the only part which is changed over here is this one, that is our provisioner, that is remote exec. So here I have added this inline character, and along with that I have added the touch hello text. So it is going to create an empty hello text file, and inside that file I'm just going to write this line, that is hello world remote provisioner. So this is how our remote provisioner script of Terraform is gonna look like. Everything else is pretty much same, and the only part which we have changed is only this provisioner. To start with our first command, so the first command is terraform init. Okay, so now we have finished our terraform init command. So the next command which we are going to run is terraform plan. Okay, here you can see 3 to add. That means it's going to create 3 resources, that is EC2 and security group, and after that it is going to create a key pair. Okay, so these are the 3 resources which is being created, and the final command which we are going to run is terraform apply. Type yes. Okay, so now our terraform apply command has completed successfully. Let's go to AWS console and verify the details. So here you can see this is my AWS dashboard. So there are 0 instances running, but I need to refresh this page. And here you can see now we have 1 instance. So click on this instances. Okay, so now the page has been refreshed completely. And here you can see the instance is running. So I need to click on this instance ID and click on connect. And from here, I can copy the SSH command of my EC2 instance. So copy the command, go back to the terminal, and just go to the directory where your key file is. So my key file is AWS key. And for this demo, I have just shown you like how to create a AWS key one, but I will still use my old key. So this is the directory where my key file is. So I'm just gonna simply paste my command over here, and always remember to remove this .pane extension. We don't need it. Okay, and just hit enter. And here you can see we are now logged in into our EC2 machine. I'll clear the screen so that you can see. Probably I can increase the font also, so it will be easy for you to see. And simply run the command ls, and here you can see our hello.txt file which has been created. We can verify the content of this hello.txt, and this is the content, hello world remote provisioner. So this is the content which we wanted to write, and we can look back to our Terraform script once again. So this is our remote provisioner. Yeah, here it is. So this is the first command which is going to create a hello.txt, and which we have verified over here. So if I simply type the ls command again, so this is my hello.txt, and the content which we want to write over here is the hello remote provisioner. So I can cat the command once again, and here you can see the same content which we wanted to show onto our file. So this is how you can create a remote provisioner, and you can complete your remote provisioner script with this block. With that, we have concluded all of our 3 provisioner, that is file, local, and remote provisioner provided by Terraform. And all the code which I have used into the demo will be available on my blog post. So I'll put the link of my blog post into the description section of this video. And there is one recommendation which I would like to tell you, like it is not recommended to use provisioner too much into your Terraform project, because you will be using quite a lot lot of, or you will be introducing quite a lot of bash script into your Terraform. So that is not recommended. So try to avoid or try to use less of a provisioner inside your Terraform module. And in today's session, we are going to talk about Terraform modules. The today's session has been divided into two parts. In the first part, we are going to see what are the basics behind Terraform modules and how we can create a Terraform module. In the second part, we are going to perform a demo where we are going to create a couple of modules and we are going to deploy those two modules onto AWS. To start with our first part, let's take an example to understand the Terraform module. Because if we'll go with the official documentation and official definition of a Terraform modules, then it will be really hard to understand what the Terraform modules are. So here in this example, you can see our developer is working on his Terraform script, which will be responsible for installing Apache HTTP server. There is one more developer in the same team who is also working on the Terraform script, but that Terraform script is responsible for managing the e-commerce application. So that Terraform script is completely different and that is used for provisioning the infrastructure which is needed for an e-commerce application. With the time, there is a need for installing Apache HTTP server alongside with the e-commerce application. So here, developer 2 has its own Terraform script, but into that Terraform script, he has the infrastructure set up only for e-commerce application. There is no instruction which is provided for installing Apache HTTP server. But on the other hand, developer 1 has a Terraform script which is responsible for only installing Apache HTTP server. So is there a way our developer 2 can borrow the Terraform script from developer 1 so that he can install Apache HTTP server? So there comes the Terraform module. So what we can do over here is we can create a module in which we can define how to install HTTP server, and we can import that module into the developer 2 Terraform script. So what will happen with it is we can reuse the functionality of installing Apache HTTP server and we can use the Terraform script inside our developer 2 Terraform script. So with that, what will happen is you don't need to rewrite the whole function or the whole Terraform script for installing Apache 2 HTTP server, and we can just reuse this complete Terraform script as a module for developer 2. Alright, now we have seen an example and now we got an idea like how Terraform module works. Let's head over to demo, and in the demo what we are going to do, we are going to create a couple of modules and we are going to name them as a module 1 and module 2. And we are going to reference both the module inside our main.tf, that is going to be our main Terraform file. So once we execute or once we apply using the Terraform apply command, then both the module is going to be executed, and whatever code or whatever Terraform infrastructure code written into that module is going to be applied. So for this case, we are going to apply this on AWS. Alright, here you can see this is my Terraform module projects, and once I open this Terraform module project, then you will notice there are a couple of modules which I have created. So here this is module 1 and this is module 2. Along with that, you will also notice there is a main.tf that is going to be your parent TF or parent Terraform file. So here, first of all, you should notice over here is that we are referencing module 1 as well as module 2. So how to reference a module or how to call a module? So first of all, what you need to do is you need to create this main.terraform file, and into that file, you need to first define the provider. Since we are going to work on AWS, that's why I have defined the provider as AWS. Apart from that, you need to provide the reason, access key and the secret key. If you don't know how to fetch this reason, access key and secret key, then I would recommend you to follow the part 1 where I have shown like how you can create an EC2 instance and how you can fetch this information like a reason, access key and secret key. So I would highly recommend to follow that part 1. Alright, now we have defined the provider. The second thing what you need to do is you need to call a module. So here, the first keyword which you need to put over here is module. Apart from that, you need to define the name of the module. So this module name can be user defined. So you can put any name or any type of name of your choice for the module. So here I have put in the name as JHook Web Server 1 because in both the module we are going to install Apache HTTP server. Moving further, this is my second module, and here you can see again I have used the keyword as module and I have kept a name as JHook Web Server 2. And apart from that, we have defined as a source. So here, this is the source, and here we need to define the path of the module from where it is going to pick the module. So if you look carefully over here, so this is my main.tf, and just parallel or into the same hierarchy, you can find the module 1 as well as the module 2. That's why the path is relative over here, followed by, I think it's a /. So these are the / we are going to use to reference the module 1 as well as the module 2. Along with the today's session, I'm just going to share this guide. This is my blog post where I have taken the same example which I have just explained to you. So here you will find all the description along with the Terraform script which I have used into this demo. So I'll put the link of this guide into the description section of this video. So feel free to use this guide. And you will find this Terraform script over here. So this is the Terraform script for module 1, which you can copy from here. And this is the Terraform script for module 2. So this is also available here. So if you need to make some kind of a changes, then please feel free to make it to your own use. Now we have seen the complete structure of our Terraform module project along with the module 1 and module 2 and with our parent main.tf file. Let's head over to module 1 and see what are the content inside our module 1. So if you open this module 1 directory, then you will find a main.tf, output.tf and variables.tf. So you can easily resemble this structure with a similar Terraform project. So in a typical Terraform project, you will have a main.tf, output.tf and variables.tf. So module is just similar to a separate workspace or a separate Terraform project where it has its own main.tf file. So this is going to be our first main.tf file of our module 1. So let's open the main.tf. This main.tf file contains the code for installing Apache 2 server onto our EC2 instance. So if you look carefully, this is the bash script which is needed for installing Apache 2 server onto our EC2 instance. But let's start from the first block. So this is going to be the first block which we need to define. And we need to define the required version which is needed for this setup. So we will be using the version 0.12. Secondly, we need to create an EC2 instance. So we need to define it as a resource. And resource name is AWS instance, and here the name of AWS instance. So it can be anything of your choice, just put a suitable name over here. Then secondly, we need to put the machine ID, and here I have taken the variable that is AMI_ID, and the variable value I have defined inside my variable.tf. So this is the AMI ID which I will be using for my EC2 instance. After that, we need to define the instance type, and that also I have defined into the variable. So if you go into the variable.tf, then you will find the instance type which I am using is t2.micro. So this is just for an example purpose. That's why I'm using the t2.micro. But in case if you are working on a production environment, then just choose some higher CPU, maybe t2.large or t2.extra large. That would suit your need. So third thing is we need to define the key name. This is just an optional thing, but if you are interested in setting up your SSH keys, then just create one key pair and here assign the public key name. This key I have defined over here in the bottom. So this is the resource which we need to create for key pair. So the name should be AWS key pair, and the key name should be AWS_key. And this is my public key over here, which I have generated for this setup. I'll upload a separate video on how to create an SSH key pair and use it with a Terraform. But in case if you want to know like how to set up your SSH keys on AWS, not with Terraform, then I will put a link of that video into the description section. I have already uploaded that video onto my channel. So just go back and check that video. I'll put somewhere into the description or either into the tooltip section. Okay. Coming back to the modules, the next thing which we need to do is we need to create a security group. And here you can see this is my security group, which I have already defined over here. So here you will find the AWS security group and the name of the security group, that is main. Apart from that, you need to put the name and description, which you can put it by yourself with your suitable name. Secondly, since we will be installing the Apache HTTP 2 server, so we need to enable the port 80. That is, we need to open it. Otherwise, we will not be able to access our home page or the landing page of our Apache 2 server. Second, these ports are needed if you want to SSH or if you want to log in into your EC2 instance after you start your EC2 instance using Terraform. So this is the port which is needed. And this is the default port which I just kept it, and with the CIDR block. So this port is just optional. If you want to keep it, that's okay. If you don't want to keep it, that's also fine. Okay, so now we are done with our, we are left with one more thing, the installation script. So this is the installation script which is needed for installing Apache 2 server. And here you can see this is the bash script actually. And if we will go one by one, so whenever you need to define a long bash script, so this is the way you need to define inside your EC2 instance resource. So that is going to be AWS_instance. So this is the resource tag inside you need to define the bash script. Okay, so now we have gone through AMI, instance type, key name, security group, and now this is the bash script which we need to go through. So we'll start with the first command is we will go and update our package manager. Second, we are going to install Apache 2 using this command sudo apt install y Apache 2. Third, we are going to check the status of our Apache 2. Fourth, we are going to start the Apache 2 service. Fifth, we are going to change the permission. So as you know, once you install Apache 2, then you will get a directory created like a /var www/html. So this is the directory location, and in that directory you will find the HTML files like the home page or the landing page of Apache 2. So once you access the Apache 2, so that the default page will be available onto that directory. So we need to change the permission of that directory so that user can access it. The current user can access it actually. So this is the command for that. And the last one is we are going to create an HTML page with some hello message, and the message is going to be hello, this is module 1, and with some instance ID of the EC2 instance which we are going to start. So this is our complete Terraform file or the main.terraform file of module 1, where we are going to install Apache HTTP server with some custom message like hello, this is module 1. So this is going to be my module 1. Exactly the same thing which I am doing into the module 2 also, and here if you open the module 2, then you will not notice any much of a difference. So here everything is same, and you can see this is the bash script which I am using, and it is also going to install the same Apache 2. And the only thing which I have changed over here is the module 2 message, and here you can see this is the message which I have changed. So this is also going to install the Apache 2 server onto AWS. Now we have gone through all the modules and the parent.main.tf. Now it's time to run our Terraform script. So probably I'll reduce the font over here and I'll open the terminal. And I will reduce the path over here so that, yeah, that looks much better. Now what we need to do is we need to go into the directory where our Terraform module project is. So I will go into Terraform modules, and here if you do ls, then you will find this is our main.tf, that is going to be our parent tf, and these are the module 2 and module 1. So what we need to do is the first command which we need to run is terraform init. Okay, that's been done. The next command which I'm going to run over here is the terraform plan. Okay, now here you can see there are 5 resources which is going to be added. So now I have finished my terraform plan command, and the next command which I'm going to run is terraform apply. I'll clear the screen and I'm just going to type terraform apply. There seems to be some problem. Okay, so I think terraform, yeah, that's the correct command. Type yes. Alright, so here you can see 5 resources has been added and applied to AWS. Let's head over to our AWS dashboard and see if we are able to, if we have created those resources or not. Okay, this is my dashboard, and here this is my EC2 instance which I need to click. And as you can see, we have couple of modules, module 1 and module 2, and each module we have started an EC2 instance. So here you can see there are 2 EC2 instance which is of type t2.micro, which are up and running. So here you can see this is my instance ID 1, which I can click and open, and I'm just going to open the second one also. So this is the first instance ID, or the first instance which I have provisioned using either my module 1 or module 2, and this is the second one. So both the EC2 instance are up and running. That means we are able to execute our Terraform module project successfully. Now, after verifying that our EC2 instance is running, the next thing which we need to verify is we need to verify that we have installed the Apache HTTP server successfully or not. So for that, what you need to do, you need to copy this public IP address from here, go to the next tab, paste that IP address, and always remember, do not put HTTPS because we haven't installed any SSL certificate. So we just simply need to type in the IP address along with HTTP without any S, and just hit enter. So here you can see this is the message. Hello, this is module 1 and instance ID is this. So this was the message which we have put when we were installing the module 1, and which you can verify from here also. I will reduce the screen size, and this is the main.tf of module 1, as you can see, and this was the message. Hello, this is module 1 and the instance ID, and in the instance ID we are putting just the instance ID of my AWS instance, EC2 instance. Okay, similarly, if we go back to the other instance and here just copy this IP address, go to next tab, paste it over here, and simply type the HTTP without S, and that's it. And this is my module 2. So now you can see we are able to execute both the module, and we are able to install the Apache HTTP server using module 1 and module 2. And this is my main.tf, which were internally calling module 1 and module 2. So this main.tf was doing nothing. It was just simply calling the module 1 and module 2. So now you know like how to create Terraform modules and what are the concepts behind the Terraform module. And the today's demo just like a proof of concept. You can customize the whole project with your own software packages which you want to install along with the other Terraform module. So use this example just as a reference, and I'll share the guide along with the code which you can find into the description section of this video. So feel free to use it. This is the today's agenda for Terraform Dynamic Block. We will start with what is Terraform Dynamic Block is. Second, we will see the demo on AWS and we'll write a Terraform script for dynamic blocks. And third, we are going to see what are the best practices for using Terraform Dynamic Blocks. Starting with our point number 1, what is Terraform Dynamic Block? Consider an example. Using Terraform, we are trying to start an EC2 instance on AWS. So we have set up an EC2 instance using Terraform. And the next thing what we want to do, we want to open the ports. And the ports which I'm talking about is 22, and the next port is 443. So these 2 ports I want to start, or I want to open on my EC2 instance. Assume we don't have Terraform Dynamic Block with us. So what is the easiest way using Terraform we can open these ports? So we need to define ingress resource. So in that ingress resource, we are going to define the ports, that is 22. And the next port we are going to define 443. So we need to write these 2 sections of ingress rules, and we need to put these blocks inside our Terraform script. So once we execute this Terraform script, then it is going to open the port 22 and 443 for our EC2 instance. Well, it looks simple, like we only have 2 ports and we can write this ingress resource and we can open the port. But consider a scenario where you need to open multiple ports. So not only 22 and 443, there are 10 more ports you need to open for your different business needs. So you need to write this block of ingress resource multiple times. So that is not an efficient way of Terraform. So that's why Terraform provides us a dynamic blocks. And with the help of dynamic block, we can reduce the number of lines of code inside our Terraform script. And we don't need to write this long ingress resource rule for each port repeatedly. Let's see how we can reduce the number of lines of code which we have used to create our ingress resource. So on the left hand side, you can see this is my normal Terraform script without using Terraform dynamic block. So what I have done over here is I have defined two rules for opening the port 22 and 443. So this is the normal way without using Terraform dynamic block. And if I need to define a dynamic block, then this is how I'm going to define my dynamic block. I'll explain one by one. So I'll start with the dynamic block on the bottom right hand corner. So here you can see you need to add a keyword dynamic. Then you need to define the name of your dynamic block. So here I have put on the name ingress. The name is up to you. You can put any name of your choice. Second, we are going to use a for each loop. So now you can get an idea like why I'm using the for each loop, because I'm going to iterate some values, and the values are 22 and 443. These are my two ports for which I'm going to iterate it. So this for loop is being used for that purpose. And this local.ingress rules, this is the variable which will hold the values of ports, that is 22 and 443. So here on the top side, you can see the locals which I have defined. So locals are kind of a variables which you can define inside your Terraform script. So here I have defined the variables like ingress rules, and in that variable I have put two values like the port 443 and 22 along with the description. So this ingress rule will contain the port number along with their description. So this for each loop is going to iterate over this locals of ingress rules. Secondly, you need to define a content section inside your dynamic block. The content section is which is going to be repeated for different ports, that is 22 and 443. So here this content section is going to be repeated, or it is going to be iterated for the values which we have defined inside our locals. So here what will happen is it is going to pick the description from our locals. Like if it gets the value 443, then it is going to put the description ingress rule for port 443. It is going to put over here. And in the from port, you will see ingress.value.port. So we are using the same value, that is port. So here I'm using the same variable like values.port into from port as well as into to port. So I'll put, once I'm iterating on 443, then I'm going to put 443 in the from port and as well as into the to port. Here protocol is hard coded and the citer block is also hard coded. Now you might have gotten an idea like how we can reduce the lines of code using the Terraform dynamic block. So we had two ports with a repeated lines of code, and now we have created a single dynamic block with some locals. And next time what I need to do is I just need to add a port number inside my locals variable, and my dynamic block will work on those ports. So ports are just an example to demonstrate the dynamic block, but you can use it for other purposes and other use cases also. This is my Terraform script where I have created a dynamic block, and let's start one by one. So I'll start with the block one, that is provider. So first of all, in the Terraform, you need to define a provider. So here I'm using AWS. So that's why I have defined the provider as AWS. Secondly, you need to define the reason, access key and secret key. And if you don't know from where to get it, then I would highly recommend to follow the part one where I have shown, like where I have taken a very basic example to start an EC2 instance. So I'm talking about this EC2 instance. So please do check that part one if you're just getting started with the Terraform. But let's continue with the dynamic block. So this is my provider section. Second, as I explained to you, the locals, I have created the locals over here. This is my locals block where I have defined the ingress rules for my port 443 and 22. Third block is where I am going to create my resource, and the resource is a virtual machine running inside AWS. So that is an EC2 machine actually. So this is my resource, and where I have defined the machine ID, I am using the Ubuntu. So I have used this machine ID, and again, this I have explained in part one. And the instance type is t2.micro. So like I'm using this for example purpose. That's why I'm using the least CPU machine. So that's why I have used micro. The key name, I'm using the AWS key. I have created a public key and private key, and that's why I have created the key name over here. The security group is the way you need to define it this way if you don't want to create your custom security group. So just simply use this attributes as it is. And this is my security group. In the security group, I have created an egress as well as my ingress rules. So I'm not going to do anything with the egress. I'm just keeping it as it is. I'm just doing the dynamic block over ingress. So this is the ingress dynamic block which I have explained to you. So this is my ingress dynamic block where I have for each loop. I'm iterating over ingress rules along with the description from port to port, protocol, and CIDR blocks. So this is my Terraform script, and this is my final key pair where I'm using the public key. Okay, I'll upload a separate session where I'll show you like how to create this AWS public key and private key pair. But for the time being, just keep in mind I need to create a public key pair, a public and private key pair, and in the Terraform script you need to use the public key so that you can SSH into your EC2 instance. But I'll create a separate video for that one. So this is my Terraform script where I have created my dynamic block. So let's start by running some command. So the first command which you need to run is terraform init. After that, the next command which you need to run is terraform plan. So this command is going to tell you like how many resources it is going to add to your AWS. So here you can see there are 3 resources which is going to be added. So I'll clear over here. The next command which you need to run is terraform apply. You simply need to type yes. So here our terraform apply command has just finished. Let's head back to our AWS console because our terraform apply command has just finished. So this is my AWS console, and here you can see one instance is running. So click on it, and here you can see the state of the instance is running. So click on this instance ID. And now we need to verify the ports which we are planning to open. So the ports are 22 and 443. So you need to go to security tab over here, and there you need to scroll it down, and here you will find the port range, that is 22 and 443, and the protocol which we are using is TCP. So if you look back to our Terraform script, so we were planning to open these 2 ports, so that is 22 and 443. So here you can verify the same thing, that is 22 and 443. So this is the way like you can use the dynamic block to reduce your lines of code and create some reusable blocks inside your Terraform script. And once you're done with the demo, then once you're done with your application, then you can just simply destroy the instance by running the command terraform destroy. Now we have seen the demo of our Terraform dynamic block. Let's see what are the best practices for using Terraform dynamic block inside your Terraform scripts. The first practice over here is do not overuse. So do not try to overuse the Terraform dynamic block multiple number of times inside your Terraform file. It will increase the complexity instead of reducing it. Second, keep it clean and so that it can be reused further. What I mean by clean, don't try to nest the dynamic block inside your dynamic block. If you try to nest the dynamic block, then it will increase the complexity inside your Terraform script. So try to keep it simple so that it can be reused in future. So that's the second best practices for using Terraform dynamic blocks. I hope you liked the today's session on Terraform dynamic blocks. So if you have any question related to dynamic block, then please put down into the comment section. I'll try to answer those. Hello there, this is Rahul, and today we are going to talk about one interesting topic, that is Terraform Null resource. Lately, I have been reading about the Terraform Null resource on the official website of a Terraform, but I felt those information was not sufficient enough so that I can use the Terraform Null resource for provisioning of my infrastructure. So in today's session, we are going to take a look what the Terraform Null resource is and how you can use the Terraform Null resource for provisioning your infrastructure. Before we actually take a concrete example of a null resource, let's try to understand what null resource says. So the first thing null resource says is don't do anything. So what does it mean? So don't do anything, that means you don't have to provision or start any resource on cloud environment. So whether you are working on a AWS, whether you are working on a Google Cloud, or whether you are working on a Azure. So if you are using a null resource, then that null resource will not set up any resource onto your cloud environment. Here I'm just taking a very simple example, and this is not an example of a null resource. So if I zoom in over here, then if you'll see this is code. So this code is used to set up an EC2 machine or a virtual machine on a AWS, and this machine is t2.micro. So as soon as you execute this Terraform code, and as soon as you execute Terraform apply on this particular line of code, then what it will do, it will just set up an EC2 machine on a AWS environment. So if you can see over here, this is the end result of applying this code. So you will get an EC2 machine set up onto your AWS cloud. Okay, so now let's check the code of a null resource. So this is the code of a null resource. If I can zoom in over here, so this is the structure for defining a null resource inside your Terraform file. So first of all, you need to define the resource, and the resource name should be null resource, and then the name of the null resource. This particular null resource can be anything. You can keep any name of your choice, so it doesn't matter. So I'm referring to this name. So just put a suitable name for your null resource. And after that, you need to define two parameters. One is optional, but another one is mandatory. So here the trigger thing is optional over here. So your null resource can be with trigger or can be without trigger. Third thing, you need to define provisioners. So here I'm using the local provisioner, but in case if you need, you can use the remote provisioner also. You can use the data source or data block of Terraform also. So this is the structure or the code for defining the null resource. All right, so now we have defined the null resource. What will happen when we execute the Terraform apply command? So I'm just referring to this command Terraform apply. So as soon as you execute the Terraform apply command on a null resource, then nothing will happen or no resource will be provisioned or started on your cloud environment. So here in this example, I'm taking AWS, but if you are working on a Google Cloud or Azure, and if you are using a null resource and you apply a Terraform or you execute a Terraform apply command, then no resource will be provisioned onto that particular cloud environment. So this is the first important thing about the null resource. Now you can compare both the example over here, and you can see the end result of both the example, that is EC2 instance and the null resource, and it will ease out to understand the significance of the null resource in Terraform. So here is I'm taking one example which will help you to understand null resource in more detail. So here I'm just taking the same example code over here, and if you'll see carefully, then here I have defined the null resource, and that is over here, and here I have written a command, and that command is a shell command, and it is simply printing the hello world. The shell command I have taken over here is pretty simple so that we can understand the concept. So here you can see the output over here. This is not output, but this is the command over here, and which I'm trying to execute using the local provisioner available into our Terraform. So here I have defined the trigger, and this trigger will execute as soon as we provision the EC2 instance. I'll show you the complete example into the demo section later. But just to understand this concept over here, that whenever you define a null resource, then you need to define some kind of a provisioner or a data source or a remote provisioner with your null resource. So here I'm using the local provisioner, and in the local provisioner I have written an shell command which will be executed as a part of a null resource. So as soon as I apply or I run the Terraform apply command, then this particular command will get executed, and I'll see the output hello world into my terminal. Alright, so now we know the syntax of a null resource and the significance of a null resource in Terraform. But what are the application or the use case of a null resource? So here I have just written down some of the use cases, but these use cases depends upon your need and your project setup. So here let's take one example. So I have already shown the one example where you can execute the shell command using the local provisioner inside your null resource. So that is the first use case. Also, you can execute the scripts. So this is just one shell command which I have written for printing the hello world. But instead of that, you can just execute a shell script as a part of your null resource. So if you are having a big Terraform project where you need to execute certain shell script which is big in size, so you can just supply those shell script into your local provisioner along with your null resource, and you should be able to execute that particular shell script. The third use case which I have seen for null resource is executing the Ansible playbook. This is just an example. This is not an ideal scenario I am talking about. But if you are using a null resource and if there is a need, then you can just run the Ansible playbook also along with your null resource. The fourth use case is a little bit specific to programming setup and how you have set up your development environment. So the machine on which you are executing Terraform, and if there is a provision, if you have set up a Python or if you have installed Python onto the same machine, then you can execute the Python program also using the null resource. And that goes along with Java also, Node.js also. So these are just an example. So with the help of null resource, you can run a Python program, you can run a Java code, you can run even a Node.js code also. So that depends like what kind of programming language you have installed onto your local system. And with the help of null resource, you can just run those programs also. So these are the most significant use cases which I have found, which goes along with the null resources. Before we jump into the demo of a null resource, there is one important concept in null resource, that is trigger. So here, if you see carefully this particular code, then here I have defined one trigger over here. So trigger, as the name suggests, it will just trigger the whatever provisioner you have written over here. So here I have written the local exec provisioner, which is executing the shell command. So as soon as this trigger comes into picture of a null resource, it will just execute the local provisioner. But there are certain conditions on which this trigger will happen. So if you look carefully over here, then there is an ID and there are some value assigned to this particular ID. So whenever there is a change in this value, if there is a new value coming into this particular ID, then this trigger will execute. And if there is no change in value of this particular ID, then trigger will not execute, and this your local provisioner which is overwritten over here will not get executed. So here I have tried to explain over here also, if the value is changed and if ID gets a new value, then you will see it will execute this particular local exec provisioner. So this is an important concept when it comes to null resource, because many of the time we use triggers along with our null resource. Before we head over to the demo, I'll just try to share this link of this blog post which I have prepared for the null resource, and I'll put this link into the description section of this video so you can just follow along this blog post. So here I have documented all the code which I'm just going to use into the demo session. So just follow this guide if you feel like you need to have the similar code onto your Terraform project. Let's start with the demo, and here I have taken one of the simplest example which I can take for explaining the null resource. So start from the top. Here I have defined the provider because I am working on AWS, and this example is for AWS, but these concepts are pretty much same, and these initial two blocks will change in case if you are using the Google Cloud or Azure. Because if you are using Google Cloud, then you need to change the provider over here. Similarly, that goes for Azure also. So here this is an AWS provider because I am on AWS. Here I am sharing the credential. This is a credential file which I am using. And this is the resource. So this is an actual resource, virtual machine, that is an EC2 instance which I'll try to set up using this Terraform code. And at the bottom, the third resource which I'm talking about is the null resource. So here I have defined the null resource, and for initially I have disabled the trigger. I'll just enable it later, but I have just disabled the trigger so that I can show that you can write the null resource even without the triggers also. And here is the provisioner which I have written over here. So in this provisioner, I'm just executing the command, that is hello world command. So this is the code, and here I'll try to set up an EC2 machine first, and after that we'll just try to execute the null resource, and we'll see whether it executes or not. Let's open the terminal over here. And the first command which I'm just going to write is the terraform init command. And if it's completed successfully, then I'm just going to clear the screen. The next command which I'm just going to write is terraform plan command. And here you can see it is showing it is going to add two resources. So one resource is the null resource, and the first resource is EC2 instance. And if you go over here, then you will find the EC2 instance. So there are two resources will be added, EC2 and null resource. Okay, I'm just gonna clear the screen over here. The final command which I'm just gonna run is terraform apply. And here I'm just gonna type yes. And here you can see the command terminal output over here. Then you can see it's creating the EC2 resource. This is the ID of our EC2 instance, which is printed over here. And this is the output of our provisioner or the null resource. So here it is saying hello world. That means it has executed our null provisioner, and inside the local exec provisioner it has executed that particular shell command, and it has printed the output as a hello world. And here you can see our terraform apply command has just finished. Now here is one important concept for null resource. So as you can see, this is the first time we have executed our Terraform code where it has executed our null resource for the first time. So by default, null resource will execute for the first time, but whenever you try to execute the same null resource second time, then it will not execute. So here, this is the output of our first Terraform apply. I'm just gonna run second Terraform apply and we will see whether it has executed or not. Ideally, it should not execute the local exec provisioner, and we should not see the output hello world onto our terminal. So I'm just gonna create some space and I'm just gonna write one more command, terraform apply, and simply hit enter. And here you can see, since our EC2 instance has already been provisioned or already been started, so Terraform didn't start its second EC2 instance because it's the same instance which is running over there. And here you can see the complete output, and you will not see the output that is hello world, the shell command which we have seen in the first time. So here, this output is missing over here, which means whenever you are working with the null resource and if you have written a null resource without trigger, then it is going to execute only once. And if you try to execute it second time, that particular null resource will not execute and you will not see any kind of output. Let's destroy everything. And next time we are just gonna enable the trigger, and then we are gonna execute the same terraform apply command, and then we will see the output. Here I have enabled the trigger already. Okay, so open the terminal over here and I'm just gonna clear the screen and I'm just gonna run the terraform plan command because I have already executed the terraform init. So you don't need to do it again. So here I have executed the terraform plan command and it is going to add the two resources, that is EC2 and null. Then I'm just gonna clear the screen and then I'm just gonna run the terraform apply command and type yes. Okay, so here you can see it has completed and we have got the new ID of our EC2 instance, and after creating the EC2 instance we have the null resource has been executed, and this is the output of our null resource. So if you put the trigger inside your null resource, then null resource is going to execute only once because it will get a new ID into the trigger. And if we don't get a new ID inside the trigger, then our null resource or the local exec provisioner will not execute. So this is the tricky thing over with the null resource. So you have to be really careful when you are looking at the trigger, and if there is certain value change which is happening inside the trigger, then it is going to execute the local exec provisioner. And in this case, we have got that trigger value in the form of our EC2 ID. And here you can see this is the ID and this is the output which we have got after the executing the terraform apply command. Now, since we have enabled the trigger inside our null resource and we have executed our terraform apply command on this particular trigger once, so now what will happen when we execute the terraform apply command second time? Since the ID is going to be the same, because we are just simply executing the terraform apply command on already running EC2 instance. So that EC2 instance is already running. It has already got an ID which is unique, and second time when we run, that ID is not going to change. It is still going to be the same. Since the ID value is still same, so this trigger will not execute and this local provisioner will not execute that particular command. So I'm just gonna create some space over here and I'm just gonna run the terraform apply command once again. And here you can see it has executed the second time, but here you can see there is no output of hello world over here. So which tells again that the ID change is necessary inside your trigger, and as soon as you get a new ID, then you will execute your local or remote provisioner which you have written inside your null resource. If the ID has not changed or the value has not changed into the trigger, then it will not execute any of the local exec or remote provisioner. Alright, so now you have got an idea how the null resource work and how the trigger can be useful for your null resource. Now I'll take one more example. I'm not going to destroy anything. I'm just going to keep the same state. We have a EC2 instance running and we already got an ID of that particular EC2 instance, and I'm not destroying anything. So the only thing which I'm going to change over here is this ID. So instead of ID, I'm just going to change it to the timestamp. So here I have already commented, I'm just going to enable it and I'm just going to put a timestamp over here. So why I'm putting it over here is because I just wanted to change the value of a ID. If I'll put this particular ID, the EC2 instance ID, then it is going to be the same and I will not see a change in the null resource trigger ID. And it will not execute it. But since I have put a timestamp over here, so timestamp will just return a new timestamp value. Since I have run the same code a couple of minutes ago and now I'm trying to execute it again, so timestamp will change, and as soon as timestamp will change, then I will see the same local exec provisioner executing again inside the null resource. So as soon as I put this value inside the ID, so every time I execute my Terraform apply command, this null resource will work. So this is the key thing over here into the trigger. So as I mentioned, if something changes inside the trigger and if some new value comes in inside the trigger, then it will execute that particular provisioner inside this particular null resource. So here I have not destroyed anything. EC2 instance is still running. I'm just simply going to run terraform apply command. And I'm just going to type yes. And here you can see it has executed that particular local exec provisioner, and the reason being we have got a new ID and it doesn't matter over here. It is just a key value pair, so you can assign a string, you can assign an integer, and here you can see I have assigned the timestamp over here. So as soon as the things changes inside this trigger, it is going to execute this particular provisioner. Now I have destroyed all the resources and I have just executed the terraform destroy command. So I hope you liked today's session on Terraform null resource, and hope this session will help you to understand the concept of a null resource. And in this example which I have shown, I have just taken a local exec provisioner, but you are not limited to local exec provisioner. You can use the remote exec provisioner also. And I have shown a very basic example, that is echo hello world, but you can execute complex commands also that you will find onto my blog post, where I have shown a different example where I have executed the shell script and multiple command into the local exec provisioner. Hello there. The today's topic of discussion is Terraform data sources. So we are gonna see what is Terraform data sources are and how to use the Terraform data sources inside your Terraform project. Secondly, we are gonna perform a demo where we are going to create a Terraform data source, and then we are going to fetch some information from our AWS cloud service provider. So let's start with the first point, that is what is Terraform data source. Let's take an example to understand the Terraform data source. Assume that you are a developer and you are working on a Terraform script. So this is your Terraform script for starting an EC2 instance onto AWS. So here you will see our instance type is t2.micro. We have provided a name or the tag, that is Terraform EC2, and this is the AMI for our EC2 instance. So this is the AWS resource block of our Terraform script. Once we apply this resource block, or once we execute our Terraform script, then it is going to create an EC2 instance onto our AWS environment. But what if I want to know the public IP or the instance ID or the tags name of my EC2 instance, which I have just started using this Terraform script? So you can simply say, hey Rahul, just go back to your browser, go to or log into your AWS console, and from there you can fetch the public ID, instance ID, and the tags. That's one way of fetching the information. But what if I want to know these information only using the Terraform script? So here you can see this is the Terraform script for creating a resource of type EC2. So this is just an input instruction for AWS environment to create an EC2 instance using Terraform. But this input instruction doesn't return you back anything. So here you will see this is a simple input instruction. So if you want to get any information back from your AWS console or AWS environment, then you need to create a data sources. So that's why data sources are needed when you want to get back some information using the Terraform script. So here we have only created the resource, that's why we are not getting back any information. But if you create a data sources using Terraform, then you can get the information back in the form of public IP, instance ID, and the tags. A simple resource of AWS contains a lot of information attributes. These three are just an example, but if you create a data source, then you can get many information attributes back from your resource which you have created using Terraform. So now next thing which we are going to see the syntax of our Terraform data source and how to create the data source inside your Terraform script. Alright, so this is the structure or the definition of our Terraform data sources. So here are two concepts. One is the data block and one is the output block. So data block refers to data sources and output block refers to the information which you will get it back from AWS environment and which we are going to print onto your console. So here, as you can see, I'm printing the public IP, but I'll get back to this output block later. Let's start with our data block. So here you can see I have used the resource as AWS instance. So what does it mean? Since we are working on AWS, so the data source which I want to create is of type AWS instance. Second, we need to provide the name of my data source. That's why I have given the name as my AWS instance. So this is just like you can change the name as per your choice. It is up to you. Second thing, we need to define the filter. But why do we need to define the filter? Assume that you are working on an AWS environment where you have created multiple number of an EC2 instances. So now you want to create a data source and you want some information back from your AWS environment. But you have a multiple number of EC2 instances. So which one to choose? So that's why we define a filter. So this filter will be applicable on a particular one EC2 instance. So that EC2 instance is like which has a tag name as Terraform EC2. So it will only pick that EC2 instance which has a tag name as a Terraform EC2. That's why we need to define the filter. And if you go back to the previous slide, then you can see this is the resource block where we have created an EC2 instance. And here we have defined the tag name. So if you look this tag name, then here we have defined Terraform EC2. So we just wanted to filter only this EC2 instance using this Terraform data source. And we want to discard every other EC2 instance. Alright, second, we need to define the dependency. But why do we need to define the dependency? Alright, so in a single Terraform file, you will have like a resource block where you have created a AWS instance and EC2 example is the resource block name. So we need to find the information or we need some information returned back of this EC2 instance. So we need to define the dependency of this resource block. So just keep in mind that the name of this resource block, that is AWS instance and EC2 example. So we are going to create that dependency in this depends on block. So here AWS instance dot EC2 underscore example, and which you can again verify over here, AWS instance EC2 underscore example. So that's the dependency we need to define into data source. That's because that is how data source going to know like how I can fetch the information of our EC2 instance or the particular EC2 instance. Alright, now we have defined the data source. Second, this is the output block. And here this output block name, you can put any name of your choice like fetched info from AWS. So I have kept this just simple, but you can change as per your need. Second, we need to define the value, like what kind of information you want it back. So I want to get back public IP, But how to define that public IP attribute over here so that it can be printed onto console? So first of all, you need to use the keyword data that comes from here, data source. Second, this is of type AWS. That's why we are using AWS underscore instance. Third, what's the instance? So that's the instance which we have created over here in the data source. That is my AWS instance. Sorry, I just clicked it. So this is the instance of our data source. The name of my data source instance. So this is the name which I have kept it over here, and what information you want to get it back. So that is public IP. So this is how you create your Terraform data source to get some information back from your AWS environment. So here I am getting it back the public IP, but you can get the tag name or instance ID also. Let's head over to the demo, and this is my Terraform file for my data source and the example which I have taken just onto the slide. So first of all, this is my provider block, that is AWS, because we are working on AWS, and here we need to mention reason, access key and secret key. Just one disclaimer over here, we cannot use the plain text access key and secret key in your production environment, because that's not a recommended security practice. But this is just an example, that's why I am using it, but it is strongly discouraged to use this plain text access key and secret key. But anyway, let's move forward. And this is my resource block which I have just explained, that is AWS instance, the name of resource, the EMI which I am taking, and the instance type is t2.micro, and this is the tag name Terraform EC2. Okay, secondly, we have created a data source resource over here also, and the same the name is my AWS instance. And here again I'm filtering on the basis of tag, that is Terraform EC2, and this is the tag name which is over here. And third, that is depends upon the dependency on our this resource, that is AWS instance EC2 example. So that's the dependency. And finally, this is the output where we will be printing the public IP. Okay, but before that, what I will do, I will just comment out this section so that you will know like how the Terraform resource or the data source comes into picture. So here, if you'll notice over here, then this Terraform script is just simply going to start an EC2 instance. It is not going to return you back anything, because we have commented this data sources tags over here. All right, so what I'm just going to open the terminal and start running some Terraform commands. One more thing, this is my GitHub repo, which is public, and I'll share the link of this GitHub repo where I have created all the previous example which I have taken into the session. So you can find all the code of Terraform into this GitHub repo. And also along with that, I have prepared this guide on my blog, that is jhook.com, where you will find all the instruction and the same code which I have used into the current demo. So feel free to use both the GitHub link as well as this guide. All right, now we have commented out our data source section, this one, and we are only going to create an EC2 instance, so which you can see over here. So the first command which I'm going to run is terraform init command. All right, so now our terraform init command has executed successfully. I'll clear the screen. The second command I'm going to run is terraform plan command. And here you can see it is saying plan to add one. So it is going to create a one resource, but it has not created yet. All right, so the final command for actual creation of a resource or the EC2 instance, the command is terraform apply. Hit enter. Type yes. All right, so our Terraform apply command has just finished and it has created one resource onto AWS. So let's get back to our AWS console on a browser and verify the resource first. So this is my AWS dashboard. In the search console, we can type EC2, click on the EC2. And here you can see this is our Terraform EC2 instance, which we have just created. And if you click on the instance ID, then you can get to know all the details about your Terraform EC2 instance. So here, this is the public IP, 370.199.241. And these are the rest of the details associated with our EC2 instance, which we have just started using Terraform. Now we know our Terraform EC2 instance has been created. Let's get back to our Terraform script and enable the data source. So heading back to our Terraform script, I'll reduce the console size over here. And this is my data source block. So I'm just going to uncomment this block so that I can execute this Terraform data sources. So now I'll save the Terraform file, and now you can see we have the resource block where we have previously started the EC2 instance, and now we have the data source. So it should return you back with the public IP address. And as you know that Terraform, once if we are going to change the same Terraform file, then it is not going to start again an EC2 instance, but instead it is going to take the new change which you have done into Terraform file. So we have done the new changes, that is data sources. So this is the block which we have added. So what I'll do, I'll just increase the terminal size. I'll clear the terminal over here, and I'm just gonna run the command terraform plan apply again and hit enter. Type yes, and here you can see the apply is completed, and you can see it has not created any resources because in the previous Terraform apply command we have already created an EC2 instance, but here we have created a data source block. So that's why this data source block is just a logical block which doesn't needs to be created on AWS environment. That's why it has not created any resource. But here you can see this is the public IP address which we got back from our AWS environment. So this is the public IP which I got back of my EC2 instance, and if you go back to our EC2 instance detail, this is the same IP address 370, 199 and 241, and yeah, here it is. This is the same IP address which I got back. So this is how you can use the Terraform data sources inside your Terraform file or Terraform script to get some information back from your AWS or any other cloud environment provider such as Google Cloud or Azure. So here I'm just getting the public IP, but instead you can get the tag name, private IP, subnet, and any other details associated with your Terraform or the AWS resources. So with that, we conclude today's short session on how to use Terraform data sources inside your Terraform script or Terraform project. Hello there, this is Rahul, and in today's session we are going to talk about Terraform workspaces. Today's agenda is first we are going to see what is Terraform workspaces and how it is different from our normal versioning tool. And in the second part, we are going to see the demo where we are going to create a workspace, and then we are going to start an EC2 instance using two workspaces. One is development workspace and second is test workspace. So let's start with what is Terraform workspaces are. So if you are a developer, then I'm guessing that you might be familiar with the concepts of GitHub or SVN. These are the versioning tool where you create your own branches. So those branches are sometimes called as development branches, where you do your own development. And once you are done with the development, then you merge those changes into your master or the parent branch. So Terraform workspaces also works in the similar fashion. So here, what we do, we create a workspaces. Those workspaces are kind of like a development or test branch for Terraform. And once you are done with the development and testing part, then what you do, you create your final Terraform script that you can ship or you can execute onto your production environment. So for today's demo, what we are going to do, we are going to create two workspaces. One is development workspace and second one is the test workspace. As you can see over here, we have created a main.terraform file that is going to be your single Terraform file. And after that, we are going to create two workspaces. That is your development workspace and another one is your test workspace. So these are the two workspaces which we are going to create, and the purpose of both the workspaces is to create an EC2 instance. So here on the left hand side you will get a EC2 instance from your development workspace, and on the right hand side you will also get a EC2 instance from a test workspace. But to differentiate between these two EC2 instances, we are going to assign a tag name. So the tag name for development workspace would be dev instance, and for test workspace would be test instance. So here you can see this is the screenshot which I have taken from my AWS console. So these are the two instances which we are going to create using the Terraform workspaces. But important concept over here is we are going to use the same Terraform file. We are not going to create another one separate Terraform file. We are going to focus on a single Terraform file because Terraform workspaces helps you to create an infrastructure from a single Terraform file using the different workspaces. This is the guide which I'm gonna share with the today's session, and you can find the link of this guide into the description section of this video. As you will scroll down the guides, the first step which you will find inside our table of content is how to create a new Terraform workspace. So creating a workspace in Terraform is pretty simple. So here we need to keep in mind that we need to use three keywords. So the first keyword is Terraform, second keyword is workspace, and third one is new. So as you have understood, like new is the keyword for creating a new workspace. Workspace is the keyword which we need to specify, which tells Terraform to create a workspace. And finally, the dev. So this is my workspace name, and it can be changed, and you can keep any name of your choice for creating your workspace. This is my Terraform file, and this Terraform file is pretty simple. So we'll start with the provider. So since I'm using AWS, that's why my provider name, I have kept it over here, is AWS. So here I need to mention three things: reason, access key, and secret key. And if you don't know, or if you're just getting started with the Terraform and you don't know how to fetch this information, then I would highly recommend to watch the part 1 where I have shown like how to use the AWS and how to fetch this information like reason, access key, and secret key. So now we know like how to create a provider. The next thing which we need to look over here is the resource. I'll get back to this locals part, but first of all, let's see resource. So whenever we work with the Terraform and whenever we work with the AWS, so what we need to do is we need to create some virtual machines in AWS environment. So that's why we have to create a resource block over here. So if you look carefully, then this is the keyword AWS instance, so which tells Terraform that we are going to create a AWS instance. And which type of instance we are going to create, so that we are going to define over here at line number 16, that is instance type. So this is the variable which I have taken. So this variable value I'm going to assign inside my tf.var. So if you open this, then here you will find the instance type. So here I'm trying to create a t2.nano. Since this is the example which I'm using it for demo purpose, that's why I have kept the instance as a t2.nano. It is a very small instance which can be used for development or testing purpose. But in case if you are using for production, then please choose some higher instance type. Alright, coming back to my Terraform file. So here this is my resource. Here I have defined the instance type. Then here, this is the AMI, that is the machine ID. Since I'm using Ubuntu, so I'm using this machine ID of my Ubuntu machine. And again, this all information like AMI, reason, access key, and secret key, I have explained in part 1. So please go back and check if you don't understand from where I'm fetching this AMI. Alright. The next thing which over here is like a tag. So tag is just a useful information which we put on our instance. Since we are creating an EC2 instance, so I'm putting a tag over there. So this tag is just a string. You can keep a suitable name, like this is a development EC2 instance, so you can put a tag name onto it. So this is the tag. This is the purpose of actually the tag. Alright, the next block which we are going to take is the locals. So here I previously explained like we are going to create a tag and we are going to assign a tag name. So here I'm using the locals to create my tag name. So here consider local as a local variable for this file. So this is the instance name, which is the variable, and this variable will contain the name of the tag. And this tag is pretty much a string, as you can see over here. So this string can be any name. So you can simply hard code the string value over here. So here you can say like my tag name. Okay. And also if you don't want to put the hard coded string name, then you can just simply use the Terraform workspace variable. Don't worry, I'm just gonna explain this Terraform workspace variable later, but just to consider like this is a string and you can keep any name of your choice inside this locals block. So this is the instance name which I'm going to use for my resource tagging. Now we have seen our Terraform file and we are going to use this Terraform file to create our EC2 instance. But in today's session, we are going to talk about Terraform Workspace. So the first thing which we need to do, we need to see like how many workspaces right now we have. So this is on the left hand side, you can see this is my Terraform Workspace project. And on the right hand side at the bottom, you can see this is my terminal. So the first command which I'm going to run, I'm going to check like how many workspaces I have right now. So the command for that is Terraform space workspace followed by the list. So once you hit this enter, then it is gonna tell you like how many workspaces you have. So here you can see it is telling you default, and it's also mentioning this is star. So I'm just gonna explain one by one. So by default, if you haven't created or if you do not have any workspaces, then there will be a one workspace with you, that is the default workspace, and there is a star. What does it mean? So that means this is your active workspace. So if you haven't created any workspace before, and this is going to be your default workspace and which will always be active. That's why we have a star over here. So this is the way you can look on how many workspaces you have currently onto your Terraform workspaces or Terraform project. Let's create our first workspace, and the command for that is terraform workspace new followed by your actual workspace name. So my workspace name currently I'm using over here is dev. So once you write this command, just simply hit enter. And once you run this command, then you will see a message like created and switched to the workspace dev. So what does it mean? So if you run the command terraform workspace list, then you will get to know that it has made the dev workspace as your active workspace. So that means previously you were having a default workspace which was active and there were no any other workspace present. So once you created a new workspace that is dev, then that will become your default active workspace. Let's create one more workspace so that we can play along with a couple of workspaces and see the differences between them. So the next command which I'm going to run is again the same workspace create command, and here I'm just going to specify a new workspace named test. And here you can see it has created and also switched our active workspace as a test workspace, and that you can verify using the command terraform workspace list. So here the star is now in front of the test workspace. So that means test is going to be your default active workspace. Coming back to the guide, so the first step was to create a new workspace. So now we have seen like how to create our workspace, and we have created a workspace named dev, as well as we have created a workspace named test. So once you create the workspace, then the next command is how to list all the workspace which you have created. So the command for that is terraform workspace list, which we have already seen. And it will list out all the workspaces which you have created along with the star. So that means it will also show you like which is your active workspace. Okay, so the next command which I'm going to show to you is like if you want to know like which is your active workspace right now. So you want to see only the active workspace. So the command for that is terraform workspace show. So you simply copy this command from here and go back to your terminal and just paste this command. So it will show you only the active workspace. So here you can see this is showing you test. And if you remember like the previous list command, it was showing you all the workspaces which has been created along with the active one. But this workspace show command will only show you the active workspace for you. Now the next question comes like how to switch between the workspaces in Terraform. So what does it mean? So let's consider a scenario where you have created a multiple workspaces, around 3 or 4 workspaces, and you need to work between those multiple workspaces. Then how you are going to switch those workspaces? So the command for that is terraform workspace select. Select is the keyword for switching the workspace, and then the actual workspace name onto which you want to make a switch. So I'm just going to copy this command from here and head back to my terminal, and here I'm just gonna paste the command. But one thing over here, I'm already on a test workspace, so I need to switch to dev workspace. So I'm just gonna change the name to dev and simply hit enter. So now it's gonna show you the message like switched to the workspace dev, and that you can verify by using either the command show that will show you dev, which is your active workspace, or either you can use the list command also. So here, now we have created the couple of workspaces, and now we are able to switch from test to the dev workspace. Moving further, the next thing which we are going to talk about is Terraform workspace variable. So I have shown you this variable inside my Terraform file where my workspace project is. So this is my locals. This is my locals block. This is my locals block. And inside this locals block, I'm using this terraform.workspace variable. So this variable is going to send me or tell me the workspace name. So since I'm working in a development workspace, then it is going to print the development workspace name over here. So that's the main purpose of this variable. Now let's see how we are going to use this Terraform workspace variable to create our EC2 instance and use the tag name as the Terraform workspace name. So here this is the tag name, and here I'm using the instance name, and this instance name is coming from this Terraform workspace variable. Let's apply this Terraform configuration, and right now I'm on an active workspace, that is dev. So dev is my current active workspace right now. So the first command which I'm going to run is terraform init command. Alright, so now my terraform init command has completed. The next command which I'm going to run is terraform plan command, and then in this terraform plan command we are going to supply a var file, that is dev.tfvar file. So here in this dev.tfvar file we have used the instance type as t2nano. So that's the only variable which we have defined over here, that is t2.nano, and the variable we are going to use over here in the instance type. Okay, so that's the var file we are going to specify along with our terraform plan command. So I'm just gonna simply hit enter, and here you can see our one resource is planning to be added. So that means we are going to create a one resource once we run a terraform apply command. So this is just a plan command which just tells you like how many resource is going to be added. So yes, we are going to create a EC2 instance. That's why it is telling me that one resource to be added. Now I'll clear the screen and I'm just gonna run the terraform apply command, so I can update the same old plan command. So I'm just gonna switch from plan to apply, and I'm just gonna supply the same dev.tfvar file because we are going to use the same variable file in our dev workspace. So simply hit enter. Here it will ask like would you like to create? Simply type yes. Alright, so now terraform apply command had just finished, and here is the message. Let's verify our EC2 instance by going back to our AWS dashboard. So this is my AWS dashboard. So simply you can type over here EC2. Click on the first option. And here you can see our dev instance is ready and the status is up and running. So that means we are able to start our EC2 instance using our Terraform script, and we are using the workspace as our dev is our default workspace. So which you can verify by going into the tags also. So here you can see the tag name is dev dash instance. So if you go back to our Terraform script, then I have shown to you like this is our Terraform workspace variable, and this variable will return you the actual workspace name. And after that I have concatenated or I have added my instance as my string. So the tag name which I have created over here is dev dash instance. So that means you can use the Terraform workspace variable in that manner to separate or differentiate between your different EC2 instance or any other AWS resources. Now after creating an EC2 instance inside our development or dev workspace, let's create a same EC2 instance using the test workspace. So first of all, what we need to do, we need to switch our workspace to the test workspace. So I'm just going to copy this command from here and I'm just going to paste it over here and hit enter. So as you can see, our workspace has been switched to the test workspace. Now after switching the workspace to the test workspace, the next command which I'm going to run terraform plan, and this time I'm going to supply my test tfvar file. So I'm just going to change the name over here for my tfvar file and simply hit enter. And here you can see it is showing me like it is going to add or create a one resource. The next command which I'm going to run is terraform apply, and here I'm going to use the same plan command, but I'm just going to change the plan to apply. And the next thing which I'm going to change, oh, I don't need to change the var file name, that is going to be test.tfvar. So I'm just simply going to hit enter. So it will ask like whether would you like to create these resources, simply type yes. And here you can see our one resource has been created, or our EC2 instance has been created. Let's head back to our AWS dashboard. And here you can see this was our previous dev instance. Let's refresh this page. And here you can see we have a one more instance, that is test instance, which is up and running. So if you remember, or if you know like how the workspaces work, so now we are running the same Terraform script using different workspace name. So the first workspace which we have used is the dev workspace, and we have created a EC2 instance for development workspace. Then we have created a second EC2 instance using the test workspace. So both the workspaces are completely separated or completely different, and those workspaces doesn't interfere with each other, although you are running the same Terraform script. So here you can see I have this second test instance of my EC2, which is up and running. And you can select this instance also over here, and we can verify the tag name at the bottom. So here you can see the instance tag name, that is test dash instance. So that's the same instance name or the tag name which we have specified in our Terraform script. So if you go back to your Terraform script, then you will see inside your Terraform file that you have used the instance name using the Terraform workspace variable. So here it is. So this is how you can differentiate between the different resources using the workspaces. And if you use it logically, then it will really helpful for your development and testing purposes. The next thing which we are going to see after this is we are going to destroy the EC2 instance. But the destroy also works in the same way we have created the instance. If you are using a test workspace and you are trying to destroy the EC2 instance, then it is going to destroy the resources only for the test workspace. It is not going to touch the resources for development workspace. So you need to switch to development workspace to delete the resources which you have created from your development workspaces. Let's start deleting the resources which we have created. But first of all, let's check onto which workspace we are. So the command is terraform workspace show. And we can say we are on a test workspace which is active. So I'm simply going to run the destroy command, and using the test tf.var file because we are into the test workspace, and simply hit enter. It is going to ask whether you want to destroy. Simply type yes. Alright, so now our EC2 instance has been destroyed from our test workspace. Let's head over to our EC2 dashboard and refresh this page. And here you can see this was our test instance and the current state is terminated, but our dev instance is still running. So what does it mean? So the way you have created the workspaces and the one workspace which is active, you should be able to delete or create any resources into that active workspace. It will not going to touch the other workspaces. So here in this current example, we have seen we use the test workspace as our active workspace, and we have created our resource, and after that we are trying to destroy it. So once we hit the destroy command, then it is going to only destroy the resources available into the test workspace. Now let's try to delete the EC2 instance from our development or the dev workspace, and the command for that, first of all, we need to use is we need to select the development workspace. And for that we need to change the workspace name over here. So the command is terraform workspace select dev. Hit enter. And now you have switched to development workspace, and now you can issue your terraform destroy command. So here I'm just gonna update. I don't need to update. I need to update the tfvar file. So I'm just gonna switch to dev.tf.var file. And after that, we are just simply gonna hit enter. And remember, in previously we have destroyed the resources for test workspace. Now we are trying to destroy the resources for our development workspace. So here onto EC2 dashboard, you can see previously we have destroyed test instance and that is terminated, but our dev instance is still running. And now I have issued the destroy command for my development workspace. So it will going to ask, are you want to sure? So I'm just simply type yes, and it might take some time, and then your development instance will also go into terminated state after running the destroy command. So here you can see our instance has been destroyed, and if you go back to our dashboard and just refresh this page, so this state from running, it should be terminated now. And here you can see our both EC2 instance of our test as well as the development workspace has been terminated. I hope you liked today's session on Terraform workspaces and how to create the workspaces for your test development or staging environment. Try to use the workspaces efficiently rather than creating multiple number of workspaces. Stick to some 2 or 3 workspaces, which will really help you to boost your development process. Hello there, this is Rahul, and today we are going to talk about the Terraform user data block. Terraform user data block, an important concept when you're trying to set up a virtual machine, but you also want to do some pre-configuration or a bootstrapping setup. So what does it mean by the pre-configuration or bootstrapping setup? Suppose you have started a virtual machine which is empty, but you don't want an empty virtual machine. You want to have certain packages installed already onto your virtual machine. So what you're going to do, you're just going to use the user data block, and with the help of user data block, you can execute some shell script, and in those shell script you can specify you want to install Python, you want to install Ansible, you want to install Apache, you want to install Nginx server. So this user data block is a part of a Terraform code, and whenever you're just going to run the Terraform code, then it is going to set up a virtual machine as well as install those packages also. So yeah, it might sound complex right now, but it is really easy, and that we will see into this particular demo. So let's switch over to the demo and see what the user data means. All right, let's start with our first point, and what is the user data and why should we use inside our Terraform. So just to explain a bit, so here I have taken a very basic example, and in this example, first of all, I'm just trying to set up an EC2 machine over here. So this is the initial code which you can see where I have specified the AMI and the type of the machine. And in case if you are using GCP, Google Cloud or Azure, then this part will change because there you will set up a different instructions for provisioning the virtual machine in Google Cloud and Azure. But the concept is same pretty much. So here, first of all, I'm just writing this code to set up an EC2 virtual machine, which is based on Ubuntu. And second, here I'm just writing this user data block over here. So in this user data block, I'm just writing a shell script. So if you'll see carefully over here, so this is the beginning of the shell script, and this is the actual shell script which is just creating a hello.txt file. So this is the hello.txt file which I'm just creating over here. And this is the echo message which will be get written into this hello.txt file. So this is a very simple example which I have found to explain the user data. So whenever you're working with the user data, then you use user data block to do a pre-setup for your virtual machine. So what will happen when you will execute the Terraform apply command on this particular example? So it will create an EC2 virtual machine, but as well as it will just execute this user data block. And once it executes this user data block, then it will just create this hello.txt file inside your EC2 machine. So that's the purpose of our user data block, to do the initial setup or a bootstrapping setup whenever you are provisioning any virtual machine on any cloud platform, whether it's AWS, whether it's Google Cloud, or whether it's Azure. Let's switch over to the IntelliJ, which is my IDE, and do some demo with the example which I have just explained to you. So here is my example code. So here I'm using the AWS because I'm working on an AWS environment. So here I have specified the reason and my credential file. Secondly, this is my resource, which is AWS instance, and here I'm specifying what kind of an instance I'm using. So that is t2.micro, which is a small machine which I'm using for the demo. And here are some setups which I have done. Don't worry, you will get all this code from my GitHub repository, so you can just copy everything. But the important thing over here is this user data block. So here I have written the bash script, and in that bash script, I'm just writing an echo message and just writing that echo message into my text file. So this is just an example. So I will just switch over to my terminal, and here the first command which I'll just execute is terraform init. That's been done. I'll clear the screen. The next command which I'm just going to execute is terraform plan, just to see how many resources it is going to add or create. So here you can see it is going to create 3 resources. That's fine. I'll just clear the screen. And the final command which I'm just going to run is terraform apply. It might take a couple of minutes, so I'll just fast forward this one. I'll just type yes. Alright, so as you can see, our Terraform apply has been completed successfully, and here you can see the message, it has added the 3 resources. Now the next thing we will do, we will SSH into our EC2 machine and we will just verify that hello.txt file has been created or not using our user data block. Before we SSH into our EC2 machine, I just wanted to show you the AWS console of my EC2 instance. So here you can see this is the EC2 instance which is running, and if you click on connect, then you can see the public subnet of my EC2 machine, which we are going to use to SSH into our EC2 machine. Okay, so now coming back to the terminal, I'm just clear the screen and I'm just gonna paste the SSH command, and I'm just gonna simply hit enter, type yes to accept. And here you can see we have SSH into our EC2 machine which we have just set up. I'm just gonna clear the screen so that I can get a little bit more space. And first of all, we just want to check where we are. So I'm just going to issue the pwd command, and here you can see we are on a home and Ubuntu, but our text file has been created at the root location because that's the default location where user data executes. So I'm just going to go back. So I'm just going to jump one directory back, verify. Yeah, we are at home directory. I'm just going to jump one more directory back. And now we are at root location, here you can see. And I'm just going to issue the command ls, and here you can see this is the hello.txt which we have just created using our user data block. And we can just issue the cat hello.txt command also to verify the content. So here you can see the hello world dot, which is like a return using the user data block using inside our Terraform example. Now we have seen the basic example of a Terraform user data. So the next question comes, like, what advanced thing which you can do with your Terraform user data block? So here you can see one example which I am taking it over here. So here I am writing a shell script file, which is a separate shell script file, which will be responsible for creating some directories and installing some Apache onto our EC2 virtual machine. So here you can see, if I'll zoom it over here, so here it is first of all updating the package manager for our EC2 machine, which we will set up using our Terraform. Then it is going to install the Apache, then it is going to start the Apache, and then it is going to enable the Apache so that we can access the home page of our Apache 2 server. And then this is the message which we are going to create. This is just going to be an HTML file which we will be accessing. So this is a little bit more advanced stuff which you can achieve with the user data block inside your Terraform. But now you have created this file, and this file is you have saved with the name install.apache.sh. So this is the file which is residing separately. So how will you call this shell script file inside the user data block? Like in the previous example we have seen, we have actually hard coded our shell script, but here we are just creating this file separately. So here, this is the example code for how to refer or how to call that particular shell script file. So here you will notice we are pretty much using the same thing. Here we are trying to set up an EC2 machine over here. So this is an EC2 machine. But here, if you look carefully, so this is the function, that is the file function we need to use. And here we need to specify the name of the file. So this is going to be the file where we have written our shell script. And this is the user data block, the concept which we are talking about. So you need to specify the user data block, you need to specify the file function because our file, the shell script file, resides separately. And then you need to specify the name of the file. So once you do this, then what will happen? As soon as you start your EC2 machine, it will just read this user data block, it will just execute this particular shell script, and it will do all the things which is written inside that particular shell script file. Okay, let's head over to our IntelliJ and see this demo in action. Alright, so here is my IntelliJ. So I'll just comment out my previous example where we have created a hello.txt. So I just don't want that. So I will comment out this section and I will enable the file function where we will be calling the install apache.sh. So I'm talking about this. And if I show you over here onto my screen, so if I can increase it a little, give me a second. So here you can see I have created the install apache.sh separately, and this is the content of my install apache.sh. So where we will be updating the package, installing the Apache, starting the Apache, and then finally enabling the Apache. Let's head over to terminal and run some Terraform command. So this is my terminal, and the first command which I'm just going to run is terraform init. Then I'll just clear it. And the second command which I'm just going to run is terraform plan. And here you can see it is planning to add 3 resources, which is fine. I'll just clear the screen once again. And the final command which I'm just going to run is terraform apply. And type yes. It might take a few minutes, but I'll just fast forward and I'll just come back when it's ready. So here you can see our terraform apply command had just finished, and I can just show you the AWS console also. I'll just refresh it over here, and here you can see our instance is running, and these are the public subnet to connect to our EC2 instance. All right, so I'll just move it to the right hand side, and this is the command which I'll be using to connect to my EC2 instance. I'll just copy it, I'll just clear the screen, and I'll just paste the command. Type yes to accept it, and here you can see we are able to SSH into our EC2 machine. Let's first verify whether we have installed the Apache 2 server successfully or not. So the first command which I'm just going to run is to verify the status of Apache 2. So I'm just going to run systemctl status Apache 2, and here you can see the service is up and running. So next thing which I'm just going to verify is by curling localhost, because I am inside the machine. That's why I'm using localhost, and enter. And here you can see I can access the basic HTML page like deployed via Terraform. And here you can see this is the echo message which I have written inside my shell script, and which was creating a very basic HTML file for our Apache. So this was just a little bit more advanced example, like how you can use the user data block to achieve some complex functionality using the shell script. So this was just a small demo on how to use the user data block inside your Terraform projects, and I hope you can use this basic example to implement the complex functionality based on your needs. I'll put the link of the guide which I have just shared into the demo into the description section, just so feel free to use it, and also share the GitHub repository where I have created all these examples. So just feel free to clone that GitHub repo also. Let's discuss the Terraform depend on meta tag today. Let's first discuss why do you need a Terraform depend on meta tag inside your Terraform project. So when you use Terraform, then with the help of Terraform, you can create multiple resources inside your cloud platform. So if you are using AWS, then you can create S3 bucket, EC2 instances, you can create Kubernetes cluster. And similarly, if you are using Terraform for GCP, then you can create a compute instances, you can create a cloud storage, and many more things. But Terraform depend on tag is really important when you want to define a dependency between these resources. Let's take one concrete example and how we are going to use the Terraform depend on meta tag. So here onto the screen, you can see this is the code which I'll use to create a S3 bucket onto my AWS environment. And similarly, I have this next code which is available for me to create an EC2 instance on the same AWS environment. So with this Terraform code, I can create 2 resources. One is S3 bucket and second is EC2 instance. All right, let's rearrange the code and try to define the dependency between these 2 resources. So for example, I have taken an S3 bucket and EC2 instance. So what I need to do is I need to create a dependency on a S3 bucket. So first of all, I want to tell Terraform that first create an S3 bucket, and once after creation of S3 bucket successfully, then try to go and create an EC2 instance. So I don't want EC2 instance to be created before S3 bucket. So here what I will do, I will just write my Terraform code, and first of all, I'll just create an S3 resource. And after creating an S3 resource, then I'm just going to write the resource block for my EC2 instance. And inside that EC2 instance, I'm just going to use the depends on meta tag. So here onto the screen, you can see I have used the depends on meta tag. And inside that depends on meta tag, I can provide a reference to the S3 bucket. And as soon as you provide the reference to the S3 bucket, then Terraform knows that we need to create this EC2 instance, but we need to create this EC2 instance after I create a S3 bucket. So here we are just trying to define a sequence. So first, Terraform will read this code. It will first create an S3 bucket, and after successful creation of a S3 bucket, then it is going to create an EC2 instance. So that's how Terraform will know that which resource it needs to create first and which resource it needs to create last. Let's switch over to the desktop and see the demo. All right, so this is my desktop and we'll start from the top. So here on the top, you will see I have created a provider section where I have specified like on which cloud platform I will be working. So I'll be working on AWS. Second, I have specified the region where I'll be deploying my resources. So that is EU Central. Second, I have specified the credential file. So where I have stored my project secrets. So in case if you don't want to use the credential file, then you can just replace the secrets over here. But just hard code the secret only for your learning purposes. Don't do this in production. All right, moving further. So this is the first resource which I will be creating. So that is going to be my AWS S3 bucket resource. So here I have just used the S3 bucket resource. This is the name of my resource. And remember, we need to use this name later on into my depend on block. Depend on meta tag. So here, this is my name of my S3 bucket resource, and this is the bucket which I'll be creating, the name I will be giving to my bucket. And remember, don't confuse with this name and this name. This is the name of the resource which I'll be referencing inside Terraform, but this is the name which will be assigned to the bucket once it is created. So that's the difference. I just wanted to make it clear. And here I have created few tags. Moving further, so the second resource which I'm just going to create is the EC2 instance. So here I have just defined the resource type, that is AWS instance. The name of the resource inside Terraform is going to be EC2 example. This is the machine ID which I'll be using. The instance type is going to be t2.micro, and the tag name which I'll be creating is Terraform EC2. Okay, now that's the necessary code which you need to define for creating an EC2 instance. Now comes the depends on meta tag. So here I'm just trying to define the dependency over a S3 bucket and how to define that particular dependency. So first of all, you need to define or you need to put the correct resource type. So that is AWS S3 bucket. So this is resource type. You will find it over here. So that's the dependency you're just going to define on that particular resource. But then you need to define or you need to reference to the exact name of the resource. So name of the resource is my test bucket. And here I have just specified my test bucket reference. So that's how you just create a dependency on a S3 bucket. So you just always be careful like what kind of a dependency you are trying to define over here. So here I'm just trying to define with the resource type and the resource name. So that can be any resource inside your Terraform project. One more thing over here, this is an array. So here you can create a one more resource, or here you can define the one more resource dependency also. So this is just an example purpose. I'm showing it to you, but in case you might be wondering that I have so many resources and I have so many dependency I need to create. So this depend upon tag does not restrict you with the one resource. You can assign multiple resource name over here, and that will be the dependency which Terraform will create. All right, let's open the terminal and run the Terraform command. So here I'm just going to open the terminal. This is my terminal. The first command which I'm just going to run is Terraform init. I'll clear the screen after successful execution. The next command which I'm just going to run is the Terraform plan command. And here you can see it is planning to add two resources, which is fine because we are just creating an S3 bucket as well as an EC2 instance. All right, so I'll just reopen the terminal once again. I'll just drag it over here. I'll just clear the screen. And the next command which I'm just going to run is Terraform apply. Hit enter and type yes. Let's see what's the error says. So bucket test one for import is not available. So I think I have taken this name before. So I just need to rename it. So let's put a name over here is the 2. Go to your terminal. Clear the screen and rerun the command. Type yes. And here you can see test bucket 2 for import. I think test bucket 1 I have already taken, so that's why it was not allowing me to use it. All right, so now my Terraform apply command has just finished, and here you can see that 2 resources has been added. And if you check the sequence of resource creation over here, then first of all, it has created an S3 bucket, and after that it has created an EC2 EC2 instance over here. So these two lines which will indicate that first S3 bucket has been created, and after that we are able to create the EC2 instance. So that's how it creates a dependency inside your Terraform project using this Terraform depend on meta tag. Well, this was a very small example, but important thing over here is to understand the depend on meta tag. So this is how you're just going to create a dependency and use this dependency inside your Terraform project. But always try to remember, don't put a cyclic dependency. So what does it mean? So if you're trying to create an S3 bucket and then after that you're just trying to create an EC2 instance, then don't do the reverse order in the same way. Otherwise it will create a lot of cyclic dependency inside your Terraform project. So always keep the things linear and sequential. So always go from top to bottom, where you create first resource and then you create a second resource, but don't create a cyclic dependency where first resource is dependent on the second resource. Then it will screw a lot of things inside your Terraform project. I hope today's session will help you to understand the Terraform depends on meta tag, and I'll share the link of this repository inside the description section. So feel free to clone that repository. And if you have any question, then please put down into the comment section. I'll try to answer those. So see you into the next session of a Terraform or DevOps. Till then, take care and bye-bye. As you can see on the drawing board, we are just going to cover the 6 points in today's session. So we will first start with what is Terraform template and what's the importance of Terraform template is. Also, we are going to see like how to create a Terraform template and what are the extensions by which you can save your Terraform template. And also we are going to have a look on to where to put your Terraform template in your project and how to call a Terraform template inside your Terraform script. And at last, we are just going to perform a demo where we are going to set up a Terraform template, and using that template, we are just going to set up AWS IAM user and the different role associated with that user. To start with, let's first try to answer the question, what is Terraform template? So as you can see over here, I have taken a very basic example, and here I have taken a word template. So I'm just trying to explain the concept of a template first. So here you can see this is a very standard template which is used for preparing the letter. So here you will find the placeholder for your name. So you can enter your name over here. Similarly, here you can enter your street address, city, zip code, and here also you will find a placeholder for that, company, again city and zip code. So this is a pretty much standard template in the Word, MS Word, which you can use for writing or preparing the letter. So you don't need to create this design every time you need to write a letter. You can simply reuse this template and generate hundreds of letters. Now you might be wondering, like, do we have a very simple example to see the Terraform template? So here you can see on the drawing board, I have taken a very basic example to show a Terraform template. So here you can see this is a Terraform template which is we are using to create a bash file. So this is a typical bash file syntax, and here you will see a placeholder. So the placeholder over here is this one, which is like a $sign, curly braces, and inside there is a variable. So that variable name is console address. So this is actually a placeholder where actual value will be inserted. Okay, so this is a typical or the smallest template file which I have found over here to show it to you so that you can understand how the Terraform template looks like. Secondly, the extension, like how you're going to save your Terraform file. So here you will see, so this is the name of the file, and if you look carefully over here, then this is an extension that is .tpl. So this is the extension by which we save our Terraform template. Also, there is one more popular extension for storing the Terraform file, that is tftvars. So this is, I have written it over here. So you can save your Terraform template using this extension also. Let's take one more example to show you the Terraform template. And this time I'm just going to take an example of a JSON template. So here on the screen you can see a JSON file, but this is not a JSON file. This is a JSON template which we will be using inside our Terraform code. And also this same template I will be using in the demo into the later session. Okay, so in the file, if you look carefully, then you will notice a placeholder. So this is a placeholder, and this placeholder will be used to generate the EC2 policy name. So this is the value we will be passing later into the demo. So there we will insert some actual policy names over here. So this is one more example on how to create a Terraform template. Alright, so now you're familiar with the concept of a Terraform template and you have seen a couple of examples of a Terraform template file. Now let's see the project structure of a Terraform and where you can place your Terraform template file. So here you can see over here, this is my main.terraform file, and along with that I'm putting my Terraform template file over here. So you can place your Terraform template in parallel to your main Terraform file, but you need to specify the path when you're trying to use the Terraform template, and this which we are going to see later into the demo. So this is how you're gonna put your template file. So similarly, I have some more projects over here. So you will notice this is our main.terraform file and this is our template file. And here this is a one more template file with the extension tftpl. So and here this is our main.terraform file. So this is a typical structure on how you are going to create your main.terraform file and how you are going to put your template file inside the Terraform project. So this was the intro part of a Terraform template. Let's switch over to desktop and see some demo in action. Before we jump into the demo, I have prepared a README file over here. So let's have a look onto that file first. So in the README file, you will notice I have taken some code snippet on how to call a Terraform template. So let's have a look into more details. So here you will see this is the resource which I have created. So this is a typical syntax which is provided by a Terraform to use the Terraform template. So what you need to do, you need to write a resource and the resource name should be template file. After that, you need to put the name of that resource. So here I have named the resource as a policy. So this is a user defined name. You can keep any name of your choice. Second, you need to define the path from where you will be importing or using the Terraform template. So here you can see this is the variable, that is template, and this is the name of the file or the file path where our template file is available. So if you go over here, so here our main.tf, and here you will see that I'm using the same thing over here, and this is my template file which is just present parallel to our main.terraform. So this is a typical syntax which you need to use, and if you look carefully, so this is our policy and here I'm using the variable as name. So this is a placeholder for our Terraform template. And if you go back to our main.tf file, so here I'm passing that variable. So this is the value which I just wanted to insert inside my Terraform template. So this is over here. So if you open again, so there is also one more thing which is important. So this is the name of the variable. So as of now, I have kept the variable name as name, and that should be same inside your Terraform template because that is the placeholder by which you are going to pass that value, and that value will be inserted into this Terraform template. Coming back to the README file, and the next syntax which I would like to show you is the template file function, which is also provided by Terraform. So here you will notice this is a template file function which I am using over here, and in this function you need to pass two things. So the first thing is the template file, the path of the template file, and the variable name. So this variable name can be a single variable, or it can be a list, or it can be a map. So you can pass those variables over here. This could be the second parameter of our template file function. And one more thing, this particular resource, the template file resource, has been deprecated into the Terraform. So this is not recommended to use anymore, but instead you can use the data source for implementing the same feature. You can check the data source tutorial which I have uploaded previously onto my Terraform playlist. Alright, so now I am assuming that you are a bit familiar with the Terraform template file function and the resource template file. So let's have a look like where you can use this Terraform template inside your Terraform template configuration. So here, the first thing which I have said over here is the locals. So if you create Terraform locals, then also you can use this template file function inside that locals. Similarly, if you create a data source or data block, then also it is possible to use inside that data block of Terraform. And also one more thing, if you are creating any resource or AWS resource, so let's say for example a AWS IAM policy or EC2 instance or S3 bucket, then it's also possible to use this template file function inside those resources. So as you can see, the template file function is pretty generic and it can be used in most of the resources which is provided by Terraform. Alright, let's take our first example, and here you will find this is our main.terraform file, and here I am creating the template file resource, not template file function. So here I am just creating a template file resource, and here I am mentioning the path of my Terraform template and the variable name. Switching over to my terminal, the first command which I would like to run is the terraform init command. And after the terraform init command has successfully finished, let's run the next command, that is terraform plan. And as you can see, I have already told you that template file resource has been deprecated by Terraform, but still we can use it. I'll clear the screen. The next command I'm just going to run is terraform apply. And here you can see the output which we get over here is the policy for Rahul Bag. So if you go back to our policy.tpl, so here policy for, this is the text which I have hard coded, and the value of the variable, that is my name. Talking about our next example where we will be using template file function inside our data source block. So this is the directory where my main.terraform file is present. So just open it. So here you can see this is our data source block, and here I have used the template file function. And remember, you need to specify the path as well as the variable name over here. And again, I have defined this as a inputs inside my data source block. Let's switch over to the terminal and run some Terraform commands. So this is my terminal, and the first command which I'm going to run is terraform init. And after it successfully run, the next command which I'm going to run is terraform plan. And yeah, it's also successful. The next command which I'm going to run is terraform apply. And here you can see this is the output which we are getting, policy for Rahul Bag, data source example. And if you open our data source main.tf file, it should be here. So here you can see data source example. So it is the correct output which we are getting when we run the terraform apply command. Now talking about the next example, now we are going to call a template file function inside the Terraform local. So as you can see over here onto my IDE, so this is my locals block of Terraform, and here I'm using the template file function. And as I have already told you, you need to specify the path as well as the variable name. So here the variable name I have using my name along with just to identify that I am calling the correct Terraform template or the Terraform main file. So here I have added a locals just to differentiate from my previous example. Let's switch over to the terminal and run some Terraform commands for this example. So this is my terminal, and the first command which I'm going to run is terraform init. And it's successful. I'll clear the screen. The next command which I'm going to run is terraform plan. And that's also successful. I'll clear the screen. And the final command which I'm going to run is terraform apply. Type yes over here. And as you can see, this is the output which I am getting, policy Rahul Bag -local. So that's the value which I have provided into the variable. So this is how you can use the Terraform template file function inside your local. And in the previous example, we have seen how to use it inside our data source block. Alright, so now you have a familiarity with the Terraform template file and how to call that template file inside your Terraform configuration. So now we will take a very real example where we will be setting an IAM user and we will be setting the policies for that particular user and all the things which we will be doing through our Terraform template. Okay, so here you can see on my IDE, so this is under AWS IAM policy directory, and this is my main.tf file, and there is a user policy.tf TPL. That is the Terraform template. We will talk a little bit later. So let's have a look onto the code. So here, first of all, if you're working with the AWS, then you need to define the provider. So which I have done it over here. Then I need to create a IAM user. So that's why I'm going to use the resource that is AWS IAM user over here, and the name, which is a user defined name. So I just put it as a test user. But the name of the actual user is the test Terraform user. So this user will be get created inside our AWS cloud. All right. Secondly, we need to define the access key. So here I'm using the resource because access key is needed to generate the access key and the secret key for that particular user. So this is the resource for that. And I have mentioned the step number 1 over here because before we actually use a Terraform template, I just wanted to show you the code if we don't use the Terraform template. So now what we have done so far, we have defined the provider, we have added the resource for creating a user, and we have added a resource for generating the access key and the secret key. And now we need to define the policies for that particular user. And remember, we are not using Terraform template over here. So what we will do, we will just use the resource IAM user policy, And here we are just gonna use the same user which we have created. So I am user test user dot name. So it should be similar to I am user test user and the name. So we are referring to the same user which we have just created over here. And then here we are just defining the policies. So here you can see I have hard coded these policies over here. So what will happen? It will create a user, it will generate access key and secret key, and it will attach these policies to that particular user. And everything is done, and this is done via hard coding it. There is no problem with it. So what we will do, let's run this example without using Terraform template, and this is my terminal. And remember, I'm just skipping the Terraform init and Terraform plan command because I have already run it just to save the time. So I'm just going to run the command terraform apply and enter and type the value yes. And here you can see it has added 3 resources over here. Let's switch over to our AWS console and see that user has been created or not. So I'll just go to my browser, and this is my IAM section of my AWS account. So here you can see the test Terraform user has been created. And if we open the policies, then these are the policies which we have assigned to that particular user. And remember, everything which we have done, it's done via hard coding everything into our main.tf file. Okay, now we have seen the example without Terraform template. I'll just run the Terraform destroy command to destroy everything over here. And then we will be using the Terraform template to implement the same thing using our template file. So as you can see on my AWS console, that resource or that particular user which I have created has been destroyed or deleted. So let's switch over to our IDE and see the example once again. So this was the step 1. I just mentioned it because I will be commenting this resource block again because this is where I have not used the Terraform template. So let's comment out this section over here and till here, and then enable this particular second step over here. So I'll just enable it. And here there is one thing which I'd like to mention over here, that I'm using a Terraform template now. So here this is the template file, and previously if you notice we have not used anything over here. Okay, that's fine. So here I'm using the template file function. I'm specifying the path of the template file which is present inside my project. So here if you go into this directory AWS IAM policy, this is my main.tf file and this is my user policy template file. So this is the typical template file which is needed for assigning the policies to that particular user. So here this is the template, and here this is our placeholder, so where we will be putting our values. Alright, so one thing also which I would like to mention, that whenever you create AWS policies, then that should be created into the JSON format. So that's why this is a typical JSON format structure, and I have told you into the introduction session that we will be using this template later. So this is the same template which I have shown you earlier. So since it is in a JSON format, so we have to use the JSON encode function. Otherwise, you will not be able to render those values into the JSON format. So here I'll be using the JSON encode function, and inside that I'll be passing the variable name, that is ec2_policies. And if you go back to our main.tf file, so this is our template file function, this is the path which you have just seen, and this is our variable, that is ec2_policies. So this is the same variable which we are using over here along with our JSON encode function, so that it can generate the policy into the JSON format. So this is the change which I have done, and these are the policies which I'll be passing over here. So this is how I'm just going to change my existing hard-coded EC2 policy and using the template and passing those as a variable. Let's switch over to the terminal and run some Terraform commands onto this example. So this is my terminal over here. So the first command which I'm just going to run is terraform init, and I'll clear it after successful running. The next command which I'm going to run is terraform plan. And as you can see, it is trying to add the 3 new resources. That's fine. I'll clear it again. And the final command which I'm going to run is terraform apply. Type yes over here. And as you can see, it has created the 3 resources. So let's switch over to our desktop and refresh this page over here. And here you can see the test Terraform user has been created. And if you open that particular user and go to the policy section, then these are the policies which has been added over here. So this is how you can implement the Terraform template file function and you can create your own template. Well, this is a very basic example which I have taken, but you can automate this example, or you can just take the reference of this example to implement a Terraform template file function for your complex business functionality. One more thing, in this example, the improvement which you can implement is here still I'm hard coding the policies inside my Terraform file. So my recommendation over here is to move this section or these comma separated values, the EC2 policies, into a variable file so that you can get rid of all of these things and you can insert some variable over here. So that what it will do, it will reduce the size of your main.terraform file and it will look more readable. And that way you can improve your code a little bit more. So that's something you can do. I think the implementation of this thing into the locals or variables is pretty easy in Terraform. So that's the improvement which I would suggest on this particular example. So I hope you liked the today's session on Terraform template, and if you have any questions or suggestions, then please put down into the comment section and I'll try to answer those. And you can find the same content on my DevOps blog, which I'll be updating later after preparing this session. So you will find all this instruction and the GitHub link into the description section along with the blog post with the detailed steps. So you can go there and follow all these things, and let me know if you have any questions or some queries related to the today's session. Debugging is a very crucial when it comes to the development. Insufficient logging or the missing log trace can really be a showstopper for your development and troubleshooting. Today we are going to see how to enable the debugging inside your Terraform projects and how to set up a different log level, that is debug, trace, info and warn. In the second half of this session, we'll also look at the Terraform validate module, and which you can use inside your Terraform project to put some additional validation and to help you with the troubleshooting and debugging. To enable the debugging in the Terraform project, you need to set two environment variables. The first variable is going to be the tf log, where you will be setting the different log level. It can either be debug, trace, warn or info. The second variable where you will be mentioning the log file name, and the variable name will be tf log path, and inside that variable you will be mentioning the log file where you will be storing the log generated by your Terraform project. Let's switch over to desktop and start setting these environment variables. As I have already told you, you need to set the environment variable for setting up the log level. So the first environment variable which I'm going to set is the tf log, and here the value should be debug because we will be setting the log level to the debug. I'll just copy this command from here, go to my terminal, and I'll just paste it over here. And we can verify the variable value by running the command echo so that we have set the correct value over there. So I'm just gonna paste it over here, and here you can see the value is set to debug. The next environment variable which we need to set is for our log file, and the variable name should be tf log path, and the value should be the path of the log file where you want to store the Terraform log. So here in my case, this is the path where I'll be storing the Terraform log. This path may differ based on your operating system and your directory structure, but you can update the path as per your need. So I'm just going to copy this command over here, go back to my terminal, and I'm just going to paste it over here. And we can verify by running the command tf log path. And here you can see this has been exported successfully. Now after exporting the environment variable, we will switch over to the Terraform project. This is my Terraform projects, and we will run some Terraform commands so that we can generate the logs. So this is one of my simplest Terraform project which is running on AWS. I'm just trying to set up an EC2 instance onto my AWS account. And the instance type is t2.micro. I'm just setting a very small virtual machine onto my AWS. So it's very basic example. I'll drop the link of my this GitHub project into the description section so you can follow this. And the commands which I'm just going to run, the first command which I'll run is terraform init. The second command which I'm just going to run, I'll just clear the screen over here, terraform plan. And the last command, so that I can apply the changes, here you can see in the Terraform plan, it's planning to add one resource, but it has not added yet. So the final command which I'm just going to run is terraform apply. So I'm just going to run terraform apply, and it will create an EC2 instance onto my AWS account. I'm just going to type yes, and it might take a couple of minutes to set up an EC2 instance. As you can see, my Terraform apply command has successfully finished and I'm able to create an EC2 instance on AWS. And you can verify onto my EC2 dashboard. You can see Terraform EC2, and this is the same thing which we have provisioned using the Terraform. And if you jump into our code, then you can see Terraform EC2. So our EC2 instance has been created successfully. The next thing which we need to verify is our log file. So go back to your path. So this is the path which I have given, user Rahul Wag documents and log. And if you check our environment variable, then it is like same path, user Rahul Wag documents log and debug.log file, the name of my log file. So here, this is my debug.log file, and you can open with any of your editor. So I'm just open with the Sublime. And here you can see these are the logs which has been generated. And we can find our EC2 instance here also. So we can type example, and here you can see AWS underscore instance EC2 underscore example. So these are the logs which has been generated with our Terraform project, and you can verify the same thing from our Visual Studio Code. So here you can see EC2 example. So I just wanted to show you the log trace which has been generated once I have set the log level to be debug. So that was just in one example where you can set the log level to debug, and that was just a very small project. But if you have a big project, then you can set the log level based on your requirement, like error, info, trace, or warn. Now the next topic which we are going to look for debugging is the validation. We have a Terraform validate module which can really help for troubleshooting and debugging purpose. So let's switch over to our desktop once again and see the Terraform validate module. Again, jumping back to the project which I have explained to you earlier for setting up the debug log level. So here I have declared a variable. Inside that we have created a validation block. So here I'm just going to put some validation condition so that before creating any EC2 instance, we should validate what kind of a EC2 instance we are just going to create. So this validation condition puts up a check like you can either create a nano, micro, or small EC2 instance. And if you are trying to create any other EC2 instance, let's say large or extra large, then it will not allow you to create. It will just throw an error message into the logs. So with that way, you can put some kind of a certain validation inside your Terraform projects. To verify this, what I'm going to do, I'm just going to change the type from t2.micro. So I'm just going to put t2.large, and I'm just going to save the file. And from the terminal, since I have already run the terraform init command, so I don't need to run it. So I can run the terraform plan command. And here you can see you got the error message, invalid value for the variable because our validation has caught. And here you can see we are just trying to pass a t2.large, but the allowed values are nano, micro, and small. So here you can see the error message also, like invalid instance type. You can only choose t2.nano, micro, or t2.small. So this kind of a validation which you can also include inside your Terraform project, which can help you to put some errorful messages into the console. So whenever someone is trying to run or execute this project, then he will or she will face this kind of an error message onto the console. I hope you liked today's session on Terraform debugging and validation, and I hope these tips can help you to improve your Terraform project's troubleshooting and debugging. Today we are going to discuss one of the utility of a Terraform, that is Terraform version manager, and this will help you to manage the different version of a Terraform which you can run and install onto your development machine. This utility, Terraform version manager, doesn't come default with a Terraform. You need to install this utility explicitly after installing the Terraform. But you might be wondering, like, why do we need to have a Terraform version manager? So as a typical software development cycle, Terraform releases the new versions of a Terraform, which either include bug fixes and the new feature. But sometimes what happens is, like with the newer version of a Terraform, some of the provider or some of the plugins or the existing stable plugin doesn't work. So in such scenario, you either need to roll back your Terraform version, or if you are running some older version of a Terraform, then in that case, you need to upgrade your Terraform version. So in such kind of scenarios where providers and plugins are not compatible with the latest version of a Terraform, then in that case, you can use the Terraform version manager to roll back or either upgrade your Terraform version. Well, this is just an example which I'm just talking about, but you can either roll back, you can either upgrade your Terraform version. So I think this utility is a really good to have, and you must install this utility along with your Terraform. Let's switch over to desktop and see how we can install Terraform Version Manager. As I have already told you, Terraform Version Manager doesn't come default with the Terraform. You need to install this utility separately. And this is the GitHub page which you can follow, and I'll also show you like how you can install it. So I'll put the link of this GitHub page into the description section. So once you open this page, and if you'll follow along with the instruction, then you will find the respective instructions for Mac OS and Linux. If you are using Mac OS and you are a fan of a brew, then you can just copy this command to install onto Mac operating system. Or else, if you are using a Linux operating system, then I would recommend using this instruction where you need to clone the GitHub repository and then you need to transfer the executable into the bin directory. I'm just going to use, although I'm using the Mac operating system, but I can pretty much follow these instructions for installing the Terraform Version Manager. I'm not just going to use the brew. I'm just simply going to follow this manual way of installing the Terraform Version Manager. So I'm just going to start with the cloning the GitHub repo of a Terraform Version Manager. Copy this link over here, go to terminal and paste it over here. It will just clone the GitHub repo. Second, it will export the environment variable or add to bash profile. So I'm just going to copy this command and paste it over here. After that, there is one more command for bash rc. So I'm just going to copy it. It is also exporting the path, and I'm just going to paste it over here. And once you're done with these commands, then you can run the command tfenv-v. That will verify the version which you have installed. So here you can see the version which I have installed is 3.0.0. After installing the Terraform Version Manager, let's run some Terraform Version Manager commands to verify the available versions of a Terraform. So the command which I'm just going to run is terraform env list remote. And here you can see it is giving you the list of a version. So these are the versions which is available for you for installing the Terraform. So here you can see this will start from, I think, the very basic or the first version of a Terraform, and it will go all the way to the latest version, that is 1.3.0 alpha. And here you can see the latest stable version is 1.2.6. So here you can see, it will show you all the available versions of Terraform till the date. Now let's assume you want to install some older version of a Terraform. Then how can you do that using the Terraform Version Manager? So the command which you need to use is terraform env, then followed by install and the version. So I'm just gonna install the version 2.4. And here you can see it has installed the Terraform version 1.2.4. One more interesting thing, you can install multiple versions of a Terraform using Terraform Version Manager, and you can set which one to use it. So I'm just gonna install one more version, that is 1.2.3. And after that, we will tell Terraform Version Manager to use 1.2.3. And here you can see it is switching the version from the 1.2.6 to 1.2.3. And if you're not sure like which version of a Terraform you should install, and you want to install the latest version of a Terraform, then what you can do, you can simply run the command tfenv followed by install, and then you can just simply apply the latest. So it will install the latest stable version of a Terraform onto your system. Also, the good thing about this Terraform Version Manager is you can install multiple versions of a Terraform, but you can explicitly tell Terraform Version Manager to use which version of a Terraform. So here you can see I have tell Terraform Version Manager to use 1.2.6. So already I have installed 1.2.3 as well as 1.2.4. So I have the multiple version which is already installed, but I can tell like just to use the 1.2.6 which I want to run onto my machine. So these are the benefits of using Terraform Version Manager. Hello there, Rahul this side, and this is one of the most requested videos from many of you guys, and like how to import the resource back into our Terraform code. So I have prepared this session where I'll be taking two examples. So in the first example, I'll be just creating an EC2 instance on AWS manually from the web GUI console. So where I'll go and create an EC2 instance, and then I'll use the Terraform import command to import that EC2 instance back to our Terraform code. And once I have imported that resource, then I'm just gonna write the Terraform code or reconstruct the Terraform code for that particular EC2 instance. So that is going to be one basic example so that you know like how Terraform import works. Second, we are just going to take one more example where we will be creating an S3 bucket manually from the GUI console of AWS. And then we are just going to run the Terraform import command to re-import the whole S3 bucket back into our Terraform code and reconstruct the Terraform code for our S3 bucket. So these are the two examples which I'll be covering this session, but these concepts and the command are pretty much common, which you can use whenever you're working with any other resource on AWS as well as on a Google Cloud or Azure. So let's switch over to my desktop and let's see some demo in action. Let's try to understand the situation over here. So on the right hand side, if you'll see, this is our AWS environment, and in this AWS environment we have already started an EC2 machine which is running, and for that EC2 instance we have got a unique ID associated with that EC2 instance. But that EC2 instance has been started manually or someone has already done in the past. But if you take a look on the left hand side, then we don't have the Terraform code for that particular EC2 machine. So whenever we talk about Terraform, then we should have an infrastructure as a code for each resource which we are trying to start on cloud environment. But in this scenario, we don't have the code or the Terraform code for that particular EC2 instance. So I'm just talking about this code. This code is completely missing. So in that kind of a scenario, we need to import the resource back and reconstruct our Terraform file so that we can later on use the Terraform init, plan, and apply command. Now you might be wondering, like, what's the syntax or what's the import command to import any resource from the cloud environment. So here, if you look carefully over here into the screen, then I have written an syntax for importing a resource. So first of all, you need to write Terraform, then import, and here you need to mention the resource type over here. After that, you need to mention the resource name and the resource ID. So if you compare with the current example, so this resource ID, we are going to put I1, 2, 3, 4, 5. This is just an arbitrary example I'm just taking, but I'm just trying to refer to this example over here onto the top. And the resource name, this resource name, you can keep anything, whichever you want. So it's up to you. You can keep any resource name of your choice. But the resource type, you need to mention the exact resource type. So if it's an EC2 instance, then you need to use AWS instance over here. And if you are using S3 bucket, then you need to use that S3 bucket name over here. So you need to carefully define or put the AWS instance type over here. So here is the example command, which is I have written considering the scenario which I have explained to you. So here, this is Terraform, this is import, and here I'm just writing the type of the instance, that is AWS instance, then the name, which is EC2 example, and the ID, which I want to import back. Now we have a little background on how to import the resource back. Let's try to simulate the scenario. So first of all, I'm just going to manually create an EC2 instance onto my AWS console. So this is my AWS account. I'll just go and click on launch instances. I'll put the name of the instance, that is EC2 example. I'm just going to use any Ubuntu machine. And here I'm just gonna verify all the details. So I'm just gonna use T2 micro because I'm just doing it for demo. That's why. And here let's keep the key pair name. I just don't want to associate any key pair. And I will just go with the default configuration. Actually, I just wanted to set up something for EC2 instance. And I'll just click on the launch instance. Oh, I need to create the key pair. So I will just go over here and I will just select this one, which I have already created. And I'll just click on launch instance. So this will set up an EC2 instance for me. And I think it's already done it. So if you go on instances, so you can see over here. So this instance is just getting started. So the key thing which you need to remember over here is the instance ID, which you can see over here. I'll zoom in a bit. So this is the instance ID, which is important for us because that instance ID we will be needing for importing our resources. So now I'll switch back to my IDE and we will run some Terraform import commands. Okay, so here is my IDE and this is the Terraform code which I need to write. So first of all, if you look carefully, so I have written only the resource block over here. The resource block is empty because we have not imported anything yet. So first of all, just create a provider. Since I'm using AWS, that's why the provider over here is AWS. And the resource type. So here I'm just trying to import the EC2 instance. So that's why the resource type is AWS instance. And here EC2 example, this is just my own defined name, which you can keep by your own choice. So, and after that, the body of the resource should be empty because we are just trying to import the resource. All right. Now we need to create the Terraform import command. So just this is an example I have already written for Terraform import command, which I have commented. So here we need to replace this instance ID. So I will just go back to my AWS console, and here I will just copy this ID, go back to my IDE. I'll just replace the command. Okay, so here I'm just trying to write the Terraform import on AWS instance. The instance is EC2 example, which is a user defined name, and the instance ID. So this is the command which we are going to use for importing the resource. Let's copy the whole command and go to your terminal. So this is my terminal, and just paste the command and hit enter. And here you can see import successful, which means you have imported the EC2 instance from AWS console or AWS environment to your local Terraform workspace. Now, once you have imported the resource from AWS console, you need to reconstruct the Terraform code for your EC2 instance. So as of now, you can see our body is still empty, but we have already imported our resource. So what we are gonna do, we are just gonna insert the missing tags or missing attributes, which is necessary for creating an EC2 instance. So the important attribute which we are talking about is the AMI, the machine ID, which is needed for provisioning an EC2 instance, the instance type, which is t2.micro. If you remember previously from the UI console, we have set up this t2.micro, and the tag name. Tag names are kind of optional. If you have inserted over there, then just try to keep the same tag name. All right, so now we have reconstructed the body of our EC2 instance, and we have already imported the resource. Now we need to verify that our Terraform code is correct in accordance with our EC2 instance, which is running on an AWS environment. So for that, what we can do, we just need to run the Terraform plan, and after that we can just run the Terraform apply command. So both the commands should be successful, and it should not create any new EC2 instance because our EC2 instance is already running. Our aim is to recreate the whole Terraform code, not to restart or not to recreate the resource. So here, once we will run the Terraform plan and once we will run the Terraform apply command, then nothing will get provisioned. It will just complete successfully without adding or removing any new resources. Let's open the terminal over here. And the next command which I'm just going to run is Terraform plan, just to verify that whether we have imported the resource successfully or not. So the command which I'm just going to run is Terraform plan. And here you can see, after importing the resource, we are able to run the Terraform plan command, and it says like no changes, your infrastructure matches the configuration. So that means we have successfully imported the resource back. And similarly, if we are gonna run the Terraform apply command, then also it's just gonna run successful without adding or destroying any resource. So I'm just gonna run Terraform apply, and here you can see all apply complete without any resource has been added or destroyed. So that means you have successfully imported the resource back into your Terraform code. Now we have seen in the previous example how to import an EC2 instance. Now the next example, we are going to see how to import an S3 bucket back into our Terraform code. So for that, I'm just gonna first create an S3 bucket. So I'm just gonna go over here onto AWS console and S3, and then click on create bucket. And here you can mention the name of the bucket. So I'm just gonna keep my demo jhook bucket. Just for an example, I'm just gonna correct the typo name over here. Sorry, it should be bucket. Yeah, I'll just go with the default configuration over here, and I'll just create a tag also. So I'll just put a name, and I'll just put the name of the tag, that is bucket. And after that, I'm just gonna click on create bucket. It might take few time. And here you can see our test bucket has been created. Now we are just gonna re-import this test bucket into our Terraform code. And now I'll switch over to my IDE and then we will run the Terraform import commands. So this is my IDE, and here we need to reconstruct the Terraform import command with the correct bucket name. So if you go back to our browser, and here you will see the name of the bucket is my demo jhook bucket. That's the name of my bucket. So if you go back to IDE, then you will find I have written the command with the bucket name. So the command is again pretty simple: Terraform import. The resource name is AWS S3 bucket. This is the resource type name for AWS. You need to be really careful. And then the resource type name, this can be user defined name, but this one should be AWS S3 bucket because it signifies the resource type, and this one signifies the name which you are trying to assign to that particular type. And this is the actual bucket which we have created over there onto GUI. So this is the command. And also here I'm just creating the resource block, which is empty because first of all, I just want to import. And also whenever you're trying to import the bucket, then you need to create the AWS S3 bucket ACL resource block also. Otherwise you will not be import all the attributes of S3 bucket from AWS. All right, so now we have placed everything. So I'm just going to copy this command from here. Go to my terminal and paste the command over here and hit enter. And here you can see we have imported the S3 bucket successfully onto our local workspace. Till now we have only imported the one part of the S3 bucket. The next part which we need to import is the AWS S3 bucket ACL, and the command is again pretty simple: Terraform import. Type of the resource, that is AWS S3 bucket ACL, and the name which is I am taking over here is example, so I'm just kept the same thing over here, and the name of the bucket for which this AWS S3 bucket ACL belongs. So that's the my demo jhook bucket, which is same as over here. So I'm just gonna rerun this command also so that we can import the second part of this AWS S3 bucket ACL also. So I'm just gonna head over to terminal. I'm just gonna paste the command over here and hit enter. And here you can see it has been imported successfully. Now the next thing what we are gonna do, we are just gonna reconstruct the piece of code in our Terraform file. Coming back to my code, so here first thing which we need to insert the attribute is the bucket, and that should match with the name, that is bucket name, and this is the bucket name which we are trying to import. Then secondly, the tags, which is the important attribute. So this is the tag which we have created at the time of creation of a S3 bucket manually from the GUI console. So these are the two important attributes which we need to put in over here. And secondly, for AWS S3 ACL bucket, we need to, I have just copied it already. So you need to reference the original bucket. So here AWS S3, which is this one, the my test bucket, which is this one, and the ID. So the whatever ID which we have got in AWS, the same ID we are going to refer over here. So this way, this is going to point to this particular bucket. So these are the block or the Terraform code which you need to fill in after importing the resources. After that, we are just going to run the Terraform plan, and then we are just going to run the Terraform apply command. And again, same, this Terraform plan and Terraform apply command will not do anything, but it should complete successfully so that you can verify that you have imported everything successfully. All right, so this is my terminal, and I'm just going to clean the previous output. The next command which I'm just going to run is Terraform plan. And here you can see it says no changes and your infrastructure matches the configuration, which means we have successfully imported all the resources related to our S3 bucket. And here you can see the resources name, that is our S3 bucket, and AWS S3 bucket ACL. So these two resources we have imported successfully. And at the same time, if you're trying to run the Terraform apply command also, then also it's gonna execute successfully without adding or changing any kind of a resources. So here you can see no changes. Your configuration matches the configuration. So this is how you are going to import the resource. I have just shown a very basic example for EC2 instance and S3 bucket. But if you have any kind of a resource which is already provisioned, then you need to look for that resource definition, like how you can create that particular resource using Terraform. And then you need to run the Terraform import command and reconstruct the Terraform code for that particular resource. I hope this tutorial will help you to understand the concept of a Terraform import, and this Terraform import concept can be used for any cloud environment, whether it's a Google Cloud or whether it's Azure. So you can just look for the like actual code, like what kind of a code or what kind of a resource you are trying to provision, and then try to look for the IDs which are associated with that resource and try to run the Terraform import command. And then you need to reconstruct the whole code of your Terraform, and that you can reconstruct by referring to the Terraform documentation, because they have a really good documentation for all this. So you just need to reconstruct the body of your Terraform code, and then you should be able to reconstruct the whole Terraform code for already provisioned resources. So I hope you liked the today's session on Terraform import, and if you are interested into the similar concept on Terraform or DevOps, then please consider subscribing to this channel. And if you have any comments or suggestion, then please put down into the comment section below, and I'll try to answer those. So see you into the next session of a Terraform. Till then, take care and bye bye.